Testing, testing. It's good? I'm waiting, Nicola, can we start? All right. Welcome all. I'm Carla Saldaño Ochoa, and I'm honored to welcome you to the Symposium Playing Models. It's a collaborative effort with my co-chair, friends, and colleagues, Adil Bohari from ETH Zurich, Lisu Huang, and Nicola Marincic, both professors at University of Florida. To start the day, we are delighted to announce that Dr. Shimei Anumba, the Dean of the College of Design, Construction, and Planning here at UF, will warmly welcome you all, panelists and participants.
Good morning, everyone, and welcome to the University of Florida. On behalf of the College of Design, Construction, and Planning, I'm really pleased that the conference is here in person this year, and we are delighted to have you all, both those in the room and those that are online. Artificial intelligence is a subject that's pretty close to my heart. My very first doctoral student over 25 years ago actually worked on developing a knowledge-based system for housing subsidence. And we have then subsequently done a lot of work related to intelligent agents and multi-agent systems. And so it's great that right now we see a big resurgence in AI, and the University of Florida is actually wanting to lead the charge. Some of you may know a few years ago we had a partnership with NVIDIA, which has led to huge investment in artificial intelligence right here at the university. We do have a supercomputer that was donated by NVIDIA, and that was hooked up to the existing UF supercomputer, which has now created what is known as the Hypergator AI, and that is the second fastest supercomputer in US higher education. And so as part of that investment, we also hired about 100 new faculty with expertise in AI across the university. And we're delighted in the college that we have 4 of those faculty, including Carla, and then also Nicola is part of the AI group that we have here. So we are delighted that you are here. It's an exciting time to be at UF. There's a whole lot going on, and from the conference program, I see you have a lot of exciting presentations as well as panel discussions, and I'm really sad that I can't be part of all of that, but I do hope that you have a great time. Please do excuse the noise. We have construction on both sides of our building, but we expect that these will be done within the next 18 months, and we invite you to come back in 2025 because that is the centennial of the college. And so we are just doing all of this to keep our house in order and prepare us for the next 100 years. So welcome to the University of Florida and have a great conference.
So Playing Models addresses the fundamental conceptual and technological shift that AI and computational storytelling instruments have introduced to design and engineering disciplines, and how they are transforming millennia-old architecture and design thinking traditions. This symposium questions design pedagogies and post-industrialization design approaches, aspiring to be efficient and optimal, because we don't want to only talk about those subjects. We really want to engage into artificial intelligence as a way to be creative. So we want to entertain the idea that with the adequate theoretical framing, AI and computational storytelling instruments offer a novel, less constricting interpretation of today's technological reality, fundamentally different from big tech efficiency and automatization narratives. They allow us to navigate through and communicate with the abundance of otherwise disconnected or inaccessible information in a vivid, playful manner. Such a digital metaverse thus becomes a fruitful source of new hypotheses, findings, and designs, and a ground for engaging broader audience as participants in the design and planning process. During the symposium, we will strive to explore, discuss, and develop such concepts in the form of texts, images, videos, and 3D models. I want to thank our sponsors, the Chair of Digital Architectonics at DTH Zurich, the School of Architecture at the University of Florida, City Lab Orlando, and the Florida Climate Institute, and also the AI Square Center at University of Florida. Without their generous support, this event would not have been accessible to such a diverse and dynamic audience. Today marks the inauguration of our symposium, starting in the morning with performing plays, facing the challenges of automated craftsmanship, moderated by Lisu Huang. In the afternoon, our discussion continues with the panel Sculpting Images and Gendering Geometry in the Free Form of Free Structural Condition, guided by Adil Bohari. We anticipate exciting conversations and meaningful insights that will shape the future of architecture and design. Welcome, and let the symposium unfold.
All right, good morning, welcome. And we're very, very excited to have you all here with us today. It's an auspicious day, of course, since there's so much going on. I'm going to introduce the first panel, and the format will be roughly this. The panels are organized into 3 speakers each. Each speaker will present roughly half an hour, 30 to 35 minutes, and we'll actually discuss each speaker's work right afterwards. And just as a sort of first prompt, the first panel, performing plays facing the challenge of automated craftsmanship. And this is sort of a provocation question that maybe serves to tie all these sort of threads somewhat together. David Pye extolled the virtues of a workmanship of risk, carried out by the practiced hand of the artisan, thereby conferring value to the resultant artifact. Faced with the deluge of options and possibilities presented by AI, and the seemingly endless non-committal flirtation with potential, is AI architecture repeating the era of paper architecture in its intellectual rigor but practical marginalization? How can AI automation help us take risks and confront the challenge of substantiating and realizing these hallucinations? This panel will explore methods of digital craftsmanship to bring these visions to life, and how AI methods can augment and automate both the conceptualizing and the building of the built environment. So I will introduce our first panelist. Igor Pantic is an architectural designer and educator based in London, and the founder of Studio Igor Pantic Limited. He works at the convergence of computational design, digital fabrication, and immersive AR/VR technologies, exploring the ways in which these disciplines influence how we design, make, and perceive built and virtual environments. Igor is a lecturer at the Bartlett School of Architecture, UCL in London, where he is teaching at B-Pro Architectural Design program, leading the research which focuses on the application of mixed reality technologies in architectural design and fabrication, operating at the overlap between low-cost AR-assisted fabrication and automation. He is also a lecturer at the University of East London, UEL, where he is teaching MArch Unit 6. In addition to this, he has lectured and taught computational design workshops and seminars internationally, and has previously co-directed the AA Visiting School in Vienna. Prior to establishing his own design studio, Igor spent 7 years with Zaha Hadid Architects in London, during which he worked on a large number of high-profile projects across scales. Igor holds a master's degree from the Architecture Association Design Research Lab, AADRL, in London, and the Faculty of Architecture, University of Belgrade, Serbia. Let's please welcome Igor to the stand.
Sorry, everyone. I thought I'm second, so. But what about? All right. Hello, everyone, and sorry to keep you waiting. It was a bit of a surprise that I'm going to be first speaker today. I thought I'm second, but all good. So my name is Igor Pantic, and the title of my talk is Architecture for the Augmented Age. Since I was so nicely introduced already, I'll skip through this page. And I would start my lecture with a short video by Australian futurist Brett King.
Over the last 250 years, we've seen a lot of major disruptions as a result of technology. For the machine age, it was the steam engine and then later the combustion engine, bringing on the end of the industrial age. For the atomic and space age, it was nuclear energy and taking men to the moon in these massive rockets. The digital age was all about computers, electronics, and in the later stages, the internet.
Encyclopedia or National Geographic?
But the next stage, the augmented age, it's going to be about you and I and the way we live our life. And over the next 15 to 20 years, almost every aspect of the way we live our daily life is set to change.
So we are entering the augmented age. What does that mean, basically? It is predicted that in the future, kind of the skills and capabilities of the workers and designers are going to be augmented in two major ways. One would be through hardwares and mechanical devices, such as exoskeletons and so on. And the second way would be through sensorial devices or kind of mixed reality devices and wearables. And obviously, when we talk about kind of extended reality, what I'm interested personally in my work and research is kind of the wide variety between umbrella between virtual reality, augmented reality, and merged reality, or mixed reality with specific focus on the later. But these ideas are nothing new, right? Sensorama, the first, let's say, augmentation device was built in 1962, as well as the Sword of Damocles by Ivan Sutherland from 1968, which was essentially kind of a precursor to all the AR devices that we have today. And finally, some of these technologies are finding their way into different kinds of industries as aids in education or tools to help in kind of fabrication or just in communication between digital models. And also mixed reality or AR, augmented reality technologies are finding its way slowly into our lives, right? We can see them now in video games, Pokemon Go, in a lot of kind of art projects, and just in many different ways how our daily lives and reality are augmented through series of virtual overlays. And also, an important thing that this brings, or the use of mixed reality technology brings, is that it liberates us from constraints of our 2D screens and allows us to completely immerse ourselves into the 3D models and the work that we do. But so what? So what does this mean for us as architects and designers? What do we have to benefit from this, and how can we use this technology? If we go back in time to kind of mid-20th century, when 20th century avant-garde was imagining buildings as machines, right? From the work of Archigram Group, as well as metabolist movement in Japan. Some 70 years later, we are getting to a situation where we are using machines to build buildings, right? Automated construction has had a tremendous advancement in the last 15 or so years. Advancements in 3D printing, robotic fabrication and assembly, drone assembly, autonomous robotics, and so on. But what about us? What about people? What about kind of the craft and knowledge that was developed over millennia? What about traditional craft and ways of making which are either too difficult or still impossible to be programmed to be executed by robots? In our earlier research at the Bartlett, from period of, let's say, 2015 to 2018, together with Sumin Ham, Daniel Widrig, and Stefan Bassing, I was leading research cluster 6, where we were focusing on a lot of these, let's say, traditional crafting processes, with obviously, in conjunction with computational tools, with the intention of, let's say, using non-architectural materials and turning them into specific architectural objects through kind of traditional crafting processes. But in a way, we noticed let's say a disconnection at a certain point where either generative models or physical models were trying to kind of catch up with each other. You wouldn't be able to, let's say, manually produce or handle the complexity of the data that you could generate with generative models, whereas generative models would often just be, let's say, representational in terms of what we could achieve with material computation. And then, so how to bring all these ideas together, right? How to bridge automation on one hand side and material craft. So we looked at augmentation, right? But not as let's say, opposition to automation, right? But rather as the other side of the coin, where we don't have a question of man versus machine anymore and fear of kind of being superseded by machines, but rather a collaborative process of man and machine, where now, as you can see in this example from a couple of years ago by Hologram, now we don't need a expensive robot anymore to just kind of lay a parametric brick wall. If you can just kind of provide already experienced bricklayers with the exact same data visualized through holographic projections, right? Or you could achieve essentially the same level of expertise from someone who absolutely had no experience, but can just follow kind of very simple instructions. And then basically that kind of leads me to the first topic in which kind of my research into mixed reality goes, and it's mixed reality assisted fabrication. Our first, let's say, completed project with this technology, which was a steampunk pavilion built for Tallinn Architecture Biennale in 2019 in Estonia, which was a collaboration between Sumin Ham, myself, and Guillemian and Cameron Newham from Hologram. And basically, the competition called for kind of a design of a pavilion structure which would be built in front of Estonian Museum of Architecture and stand there for 2 years. And the only, let's say, limitation, besides obviously the budget, was that it has to be built out of timber with kind of the idea of promoting local timber industry. So our pavilion was third in the line. So the previous two pavilions built by Sile Pilak and Sim Tuksam in 2015 and Gilles Hetzin in 2017. We looked at them and obviously kind of wanted to do something completely different, right? Looking at the ideas of previous two pavilions, which deal mostly with, let's say, kind of discrete assemblies and those types of geometries. We wanted to kind of go beyond that and do something else with timber that usually you wouldn't really see in architecture, right? And this was kind of a render which won us the competition, but also warranted a lot of questions, like how are you actually gonna build this? And not very many people believe that we're actually gonna pull it off. But the whole idea was to build it by using steam bent timber, which is usually, I mean, it's extremely old technique, right? But the problem is that it usually requires very precise two-part molds, right? And if you look at our render, that's obviously not gonna work. So our idea was kind of in a competition stage. I mean, it's gonna be very simple. We're just gonna place a couple of these temporary brackets around a central column, and we're gonna be able to kind of bend timber strips around it, clamp it, and everything is gonna be great. We did a small test during even the competition stage, kind of just to prove the concept. And the idea was like, all right, we're gonna build it in several chunks and assemble them all on site. How difficult can it be, right? So after winning the competition, we were very lucky to have a chance to test these ideas actually at 2 workshops. This was one at Temple University, where we essentially wanted to test this idea. Let's build it out of kind of, the whole piece is gonna be built out of 3-meter long timber boards. We're not gonna have any material waste. We're gonna connect with these brackets and it's gonna be great, and it looks pretty good on this image, but actually it's almost a meter off from the 3D model at the ends, right? And the reason for that is the spring back that you get after steam bending timber. But that meant that our idea of making 10 chunks and assembling them on site is absolutely never gonna work, right? So then we were lucky again to be invited to University of Aarhus in Denmark, where we tested now a slightly different approach. Let's basically use strips as long as possible and always land them into the ground. So this required a bit of redesign to the whole pavilion. But basically, we knew that if we can kind of constrain both ends of every strip into the ground, we're going to minimize the spring back, right? But this obviously meant that now we're going to be dealing with extremely long elements, and we had to overcome that in a different way, right? Now having these strips of up to 15 meters meant that we would have to start combining multiple timber boards into one longer board, and we would have to know, or we would have to make sure that the overlap joints are outside, let's say, the areas of the highest curvature. Otherwise, it would kind of break during the bending process. And then the bending process itself, we also abandoned, let's say, steaming in a steaming chamber, because that would mean that after you take a piece of timber out, you have around 45 seconds to bend it before it's too cold. So we used a very old technique used in boat building, where we would essentially put the, kind of create a steaming chamber out of a plastic bag, which would allow us essentially to keep steaming and bending timber while we are still working with it. And while, let's say, as you see in the video, while one of the pieces is steaming, we are using, again, HoloLens to walk around and place these very simple formworks in kind of increments of 10 to 15 degrees. As you can see, a bit of the process there. And then we would start the bending process. And as you can see, we are still kind of carrying around the steamers. You know, in the ideal world, maybe each one of us would wear a HoloLens. But in this case, we could afford, you know, for steaming only one, which maybe wasn't actually that bad at the end that we figured out. Because if each one of us had their own HoloLens, everyone would have their opinion, where to bend, when to bend, right? But this way you could just, you know, have one person essentially direct the rest of the team. And obviously, I mean, the video that you see is kind of the nice one with enough people, but there were moments also where it would be just 3 of us trying to kind of carry these steamers and bend at the same time, right? But basically, and this is how it would look like, let's say, at the end of every day, right? During the day, we would steam 4 to 5 these long elements, leave them to dry overnight, take them off in the morning, and repeat the process, and like that for 4 weeks. It was a bit of a laborious process, but essentially, let's say, you know, if we had more space that we could bend more pieces per day, the whole process would be shorter again, right? And then I think I can also skip through this a bit. But yeah, I mean, knowing that, you know, the whole process is going to be very, let's say, high tolerance, right? It's, you saw our adjustable molds that they obviously require a bit of tolerance. So in the same way, we were designing the brackets, where first we would kind of approximately place them where they're needed, and then kind of rationalize and adjust the geometry until we get a straight line, so we could essentially make them out of stock material rather than having to water jet cut or anything, right? So yeah, so in essentially was kind of a timber shell in one direction, having the timber strips, and in the opposite direction these steel brackets, which each one was unique, right? Because all of the kind of timber elements were unique, so the relationships between them were never repeating. So again, that also was a perfect chance to use holographic guides in the process, where we kind of hacked into this super cheap bar bender and used it for bracket bending, where we would just visualize the current and the next position, and you could see how you need to bend, right? So essentially, so far, not a single drawing was produced either in steam bending or in bracket bending process here. And then, of course, kind of the third part of the project, the on-site assembly, was following kind of the same idea. Yeah, as you can see, we would visualize kind of the whole structure and essentially each step and each strip, how they would be assembled. And we would not be assembling them kind of consecutively, but we would place, let's say, first and at the last of the strips which hold the brackets, and then kind of place the strips in between. And you can see actually how some of these strips look once they're reassembled on site. And it doesn't really look like you could put them back, but now because of such a long length and kind of pre-steaming, they all kind of fit pretty nicely at the end. But we also realized that in order to stabilize the whole structure, we had to fabricate a couple of additional brackets on site, but we could not use the 3D model for that anymore, obviously, because there was obviously a bit of movement. So we re-digitized only the key elements or the key, let's say, strips which were built, bring them back to Rhino, regenerate new brackets on site and bend them on site, and kind of install the whole thing, right? And basically, this was kind of sort of quite a big milestone for us. It showed us that there is a potential in using mixed reality technology in fabrication on architectural scale, right? That we can take it outside of university and our workshops and actually build something something real. I think that's it for this one. And then, so obviously, we understand steampunk pavilion is it's very sculptural. It's not very, let's say, spacious or doesn't have a lot of kind of spatial properties. And that's something that we try to address in our second version, designed by Sumin Ham and myself, and built and exhibited in SciArc Gallery in 2021. So essentially built during COVID, which was kind of a perfect way to prove the use of this technology, right? So this piece called Steam Odyssey was, let's say, obviously was a bit smaller in scale because it also had to fit in the gallery space, but it was imagined as, let's say, an evolution of steampunk pavilion where it would be sort of a chunk of inhabitable space where we were thinking, right, so if this could potentially, let's say, become part of an enclosure, we thought about designing this, let's say, double skin now or double surface where we could use the infill in between for insulation or kind of other wiring and so on, and obviously kind of cover the outer layer for waterproofing. So design-wise, you can see sort of quite a simpler design, but let's say a bit more controlled, and with a intention of bringing this to a full architectural scale. But something new that we did here, and I'm not going to be showing again the whole fabrication process because obviously you already saw it in steampunk. Here, as this was an exhibition, not just kind of an installation, we designed the whole exhibition experience also in augmented reality, where you could use your phone or iPad to essentially enhance your exhibition experience, where you could load these 3D models in 1-to-1 scale and see certain additional information which was not there present physically, right? So this was quite an important thing for us to kind of start thinking how mixed reality can also now really influence or start merging with our real environment. And these ideas are something that we've also been researching and testing with our students at the Bartlett for the past 5 or 6 years. Sumin, while she was at the Bartlett as well before leaving to SciArc, and then myself with Alvaro Lopez and Jose Pareja. Basically, there are these two kind of major streams of research that we conduct there. One is mixed reality assisted fabrication, and the second stream, which kind of started during pandemic times when we didn't have access to fabrication facilities anymore, which was these, let's say, mixed reality immersive environments, right? Where we are looking at the ways of how can we use mixed reality to enhance our experience of the city and the environment around us. So not just focusing on fabrication, but also, let's say, on understanding of our cities. And just kind of, I'm going to give a very quick overview. I'm not going to be talking about now each project in details, just kind of a couple of ideas that are going through this research. Obviously, using mixed reality as holographic guides, how to produce things, but also how can we interact now with the computational models where we can record let's say, any changes in the fabrication process, use them to reinform our digital models, and then kind of feed them back into the assembly line. And sorry for this. And then continuing also at the same time, which one? Continuing kind of the research into different ways of working with timber with mixed reality. In this case, it was kind of series of laminated timber elements rather than steam bent timber, but also looking at the ways how now mixed reality can be used in the design process as well, where in the videos at the top you can see students kind of using QR codes to move and redesign these digital objects, which would be then later on translated into first foam, but then also timber elements. And then as well, kind of looking at the ways, we just like to kind of explore multiple materials and what are the ways in which mixed reality can, let's say, corrupt the traditional ways in which you use those materials. So another project was looking at way of creating, let's say, porous ceramic elements, right? Instead of kind of casting or doing those kind of ceramic pieces, we looked at ways how you can first assemble the, let's say, these frames with the AR, but then also use them as a guide of how we could weave threads, which would essentially then act as a substrate for clay. So then it would be dipped into the clay and create these kind of porous ceramic pieces. Unfortunately, we never had larger prototypes because this project was started pre-COVID and then finished during COVID. So the fabrication capabilities were limited. But another thing that was interesting here was a question of, do we always now have to just follow what the hologram shows us? So are we now just literally, being the tools who assemble instead of robots? Or can we reverse the process as well, right? So in this case, the students were looking into, right, what if we don't follow what the machine is telling us, but we start recording our weaving patterns and then feed them back to the machine, with potentially, essentially, the idea of creating a large database of different weaving patterns, which could then be used to, let's say, train an AI model potentially. Another project executed during COVID was, let's say, kind of reconfigurable metal molds for concrete casting, where basically we used holographic guides in order to fold these metal sheets and then assemble them into castable molds. And this was actually cast in China during COVID, which was pretty amazing. We kind of never really expected for the students to cast anything, but they just told us like one day, hey, we found a factory which is gonna do it. So that was pretty cool. And then going back to one of our older projects from a couple of years ago, sometimes we like to revisit some of the older ideas and do them, look at them in a new light. So this was a project from 2016, which was looking into use of sawdust and stockings, essentially constraining sawdust in nylon stockings, pinning them with thread and dipping them into PVA glue or wood glue, essentially creating kind of a new timber composite. But there were two issues, right? One was it was extremely laborious, and second one was that essentially only if you're really, really trained and you spend 6 months doing this, you're gonna make something that looks good, right? And also kind of that at a certain point, like it needs quite a big frame to support until it's dry and so on and so on. So what we essentially wanted to do here is we used mixed reality first as a way to guide you through the stitching process, right? Kind of how to achieve all those interesting patterns, but also combined with our previous research into steam bending and timber, where now kind of the timber elements were used as a way to resolve the interface issues that the older models had. So that's it for this mixed reality fabrication direction that we were looking at. And now, because I'm slowly running out of time, so I'm just going to be a bit faster. Immersive environments, mixed reality plus, which is basically, if the video just starts, right, which is the idea, okay, so how can we now totally overlap the digital worlds and enhance our real environments with digital data that we can interact with. So a project called XREF was looking at essentially the idea of creating event spaces in the pockets of the city. So there are digital spaces that you can experience through AR glasses or whatever, but you have to be physically located at a certain spot, right? So you couldn't access these spaces through virtual reality. And obviously at this time we were kind of, the students were developing these geometries that they would use to populate these spaces with, different algorithms. And thinking also how something like this could actually be used also to, redesign your interior, that you can wake up in a different room or different living room every day, obviously viewed through mixed reality glasses. And then obviously all of these creations, which would be user contributed, you could upload on the cloud, exchange with your friends, and so on. But then also we started looking at kind of the ideas of multiplayer, where it's not about just a single person walking around the city with silly glasses on their head, but essentially trying to create a community where not only the person who is doing it in, let's say, first person, but you could also join as a third person, or kind of follow the stream real time, but also engage in this collaborative process of, let's say, creating virtual graffitis all over the city with your friends, right? Kind of on the video on the left, you can see a bit of the standard kind of segmentation model, and then kind of assigning different kinds of textures and elements to different parts of the buildings, and then kind of what are the ways that how can you apply now these overlays, right? Is it just kind of a 2D wallpaper, or it starts getting certain three-dimensionality, right? And that's kind of something that we kept going between back and forth in these couple of years. Then AR, AI, AR, how can we combine these two? So obviously now if we are proposing these ideas that you're creating a platform for people who, in 5 to 10 years, when everyone has these mixed reality lenses, for example, and now you're proposing and telling everyone, look, you can have a different city and see something else that your friend is seeing every 5 minutes. How do you then allow them or enable them to create that variety, right? So we found, for us, there was a problem in kind of the XREF project that I was showing before, that it was just a design library, right? So how many libraries are you going to design and pre-describe to the users if you are really creating geometry? So this was kind of now like 4 years ago. This was quite rudimentary, just pix to pix and style transfer. But the idea that you could, instead of overlaying geometries, you could overlay any kind of style, right? But what was a bit more interesting for us in this case was that, these ideas where obviously now you can recognize, you know, the window, a tree and so on, and you can add things, you can kind of overlay things, but you can then start thinking about removing things as well, right? So this kind of brings a bit of, you know, Black Mirror-ish vibes where, you know, what happens, right? In kind of, in a ideal world, we are all, you know, walking in our beautiful ideal cities, and, you know, maybe King Charles walks in kind of 18th century city. But what happens if there's a bit more sinister play behind it? How do you know that these overlays now that you are seeing are not controlled by someone, right? Or not imposed on you, right? Who is the creator of the content? Is it really just the user contributed? Or is it perhaps, you know, a paid content, so we are walking in a Coca-Cola city for a week? Or is it potentially government controlled, right? Which then, you know, brings a lot of questions which, you know, we don't really have answers, but I believe they're just kind of very interesting things to talk about. And then obviously, you know, as kind of the whole boom of generative text-to-image AI models happened last year, we thought that, hey, maybe that could actually be an interesting kind of answer to these problems of how and who creates the content, right? Where you just allow, let's say, user, you know, and their grandma to walk around along the street and prompt a bit and create a building for themselves, right? I mean, obviously virtual. But then the idea was like, all right, so is it now again just these wallpapers that you smack across the building? Or you could also add 3D geometries through certain kit bash models and so on, and then kind of combine these now new geometries with the AI overlays. And you know, kind of for me personally, this is quite interesting in terms that I'm not necessarily kind of extremely comfortable with some of the designs that are shown here, but you know, it is essentially what would happen if you kind of provide a tool like this, right? And for me, that's a super interesting question where, like now, if we as designers are providing tools like this, how much you can pre-describe and how much does it make sense to pre-describe before the tool becomes kind of essentially unusable unless it's, you know, for a group of your friends who like the same stuff, right? And then moving on a bit from that is that obviously now what this allows us is to essentially have animated overlays, right? So we don't have to walk around static cities anymore. Now we can start imagining that our environment is constantly changing, constantly animated, be it exterior or interior or the Bartlett Cafe. And then finally, I think this is going to be just on time. So the last project that I'm going to show is bringing now this idea of these digital entities which are created and brought into mixed reality to a bit next level, right? Talking about, I'm just going to go back. Starting to think, okay, what if these digital overlays are now actually sort of living things, right? Kind of as in the game's Rain World or Altered Carbon Poirot Butler, right? So what if you actually, these digital overlays that you're creating, what if they are NPCs, right? So what if you're creating this ecology of kind of digital elements which, you know, merge with your real environments and, you know, then start talking to you potentially and provide certain information around about the city or the place. So, wait, is it this one? No, next one. And I'm just gonna play for 4 minutes a bit of this video, and I hope you enjoy.
The virtual overlay and the real-time environmental data. It further cements the virtual overlay's relevance to the contextual overlay. The prototype experimented with housed humidity, temperature, and light sensors. Additionally, the wearable was equipped with haptic feedback motors to further immerse the user in the cyber-physical space. These inputs affect the generated texture's color and the generative geometric growth behavior. the virtual realm mirrors reality not through approximation, but through an immersive understanding. The humidity of the air translates into the glisten of virtual surfaces, the chill of the wind conjures up the movement of bodies, and the light of the sun paints the virtual cityscape with a palette of hues. Users wield a key, unlocking the door to an environment shaped by environmental data, seamlessly interwoven with imagination. They immerse individuals within vast, autonomously driven worlds inhabited by NPCs, each endowed with unique personalities and responsive dynamics. Thanks to the creative prowess of large language models, this transformative evolution resonates beyond entertainment. The process involves prompting the personality of the entity or NPC using three factors: the architectural history, current events, and environmental inputs from wearable devices.
Hey there, welcome to the Curve Gallery. I'm here to show you some incredible exhibitions that have graced this space recently.
Sure, I'd love to see them.
We have Carrie Mae Weems. Her photographs delve deep into the African American identity and experiences.
I remember seeing that. I loved that one.
Check out the Masculinities exhibition. Artists challenge traditional notions of gender, presenting a diverse and thought-provoking take on the subject.
Hey, how was your day?
Welcome back. It's been rather quiet without you.
You know, I was thinking about our conversation yesterday.
Ah yes, the one about parallel universes.
Have you ever wondered if time loops back on itself like moments are trapped in an endless cycle?
Time might be more intricate than we perceive.
What if time is a mosaic, not a river?
Each brush stroke of laughter, each stroke of sadness, they blend into an artwork that is us. This mosaic captures the essence of our journey, illustrating how every shard of time contributes to the masterpiece that defines us. Just as a mosaic, our lives gain meaning from the rich medley of moments woven into our personal fabric.
So there was the project My City, My Friend from RC9, which is kind of finished 2 months ago. And with that, I would finish my presentation for today. Thank you very much.
I think we can open up the floor for questions, discussion, and it can be fairly informal. If anyone in the audience has any burning questions to ask right away. Yeah, you stay. We'll keep you in the hot seat.
All right.
Wow.
Should I sit up? Okay. Hi, first of all, I'm not an architect or a designer, I'm a musician, so I'm kind of the odd person out in the room. But I really appreciated the way that you talked about power structures and agency in relation to access to a lot of these tools. I work a lot with augmented and adaptive technologies in large ensemble environments, and actually when you were talking about the HoloLens and the steam bending process, it reminded me a bit of a conductor. And so I was just thinking about, in particularly large collaborative teams and low resource settings, how do we use this technology in ways that doesn't just kind of replicate and reinforce existing power structures that lead to inequity? I don't know. it's something I'm thinking about a lot as
Yeah,
well in my
I mean,
work. And so I just think
interesting
it's very
question,
interesting.
right? But you know, for us, it was obviously, you know, we just had as many HoloLenses that we had at the moment, right?
Totally. We deal with that in music a lot.
Yeah. But I guess really depends on kind of what you're working with, right? I think for, obviously, you know, what I presented today, actually now I realize it kind of goes from one end of the spectrum to completely the other, where obviously the later projects, the immersive environments, you'd want everyone to have it, right? Whereas kind of the fabrication ones, I think they're a bit more kind of material specific, right? So sometimes you just don't want everyone to have it, because not because of any kind of power structures, but rather just because of efficiency in the assembly process or in production, right? Where it's just kind of more efficient that you reduce the amount of noise in the process, let's say.
I'll wait for the mic. Yeah, good. We currently have a lot of students that are very interested in how augmented reality can improve conditions for humans. And I see there's a lot of fun to be had in this. There's both new and sensorially complex and invigorating constructions. And then there's a kind of gamifying of the built environment. But I also see potential for, like, instead of adding complexity to the environment, which is what most of this is doing currently, is simplifying the built environment. Like, you could actually create environments that are more suitable for wayfinding or for, you know, reducing the kind of sensory overload that a lot of people have. Have you gone in that direction, or any of your research or your students working in that direction?
Well, I mean, that's something that we keep talking about also kind of at the school, you know, it's when is it a bit too much of stuff, just kind of, you know, but we as architects, we want to design something and kind of visualize new things. But one of the projects that I was showing does kind of pose that question as well, right, of the kind of erasing of data or erasure of information, right, kind of reducing, hiding rather than adding. So yeah, I mean, for me, that's kind of super interesting avenue. Like, we didn't really pursue that much more after that, but kind of the question is there.
I could imagine someone with any kind of sensory challenges using My City, My Friend, literally as a friend in the city, to help them get places, to help them avoid danger, to help them interface, and actually even make it a more pleasurable experience overall. So it would add the right kind of information, you know what I mean? And pleasure.
I mean, yeah, for us, there was a very interesting topic because, you know, for 2 years before that, we were working with kind of creating these static images, let's say. But then if you're already creating this ecology, why wouldn't you, you know, create living digital creatures as well to contribute to the whole kind of city ecology or the digital urbanism in that way, right?
Thanks for your presentation. So I have two questions. The first one was about the steampunk pavilion, and I was wondering if you could imagine, because like later in other projects you show how also not just the product of the process would be a product, but also the process itself can become a product, like these wearable arms. So I was wondering, this could also happen, for instance, for this steampunk pavilion, where you can imagine that I could, I don't know, buy this steamer and the bag and a bunch of wooden and then do it at my own in my own place or somewhere else. So that if this could be exported. So this would be one question. And one other question, perhaps related to the question that was before, is concerning augmented reality. I was wondering if you think that the introduction of augmented reality could, for instance, emancipate and relieve the built architecture, so to say, from certain thing and could transform it. So since everything, since many things can be then, let's say, transferred to this virtual area, do you think this could, for instance, change the way architecture is built? So, for instance, having no more orientation system, for instance, in the built one, or having I don't know, different kind of windows. I don't know if you ever thought.
Yeah, I mean, that would be a dream, right? You don't have to Photoshop out wayfinding anymore from the photos of your final built object. But on a more serious note, yeah, I think that definitely there would be some implication, right, on the way that we also design physical architecture if kind of the mixed reality architecture really becomes a thing, right? And I see it way more as something much more realistic or closer to humans than kind of the whole virtual metaverse, because I think that's kind of the actual power of use of these technologies, right? In the mixed reality and overlay rather than just kind of, sitting in your room and playing video games, right? And then to go to your first question, I mean, yeah, it's a very interesting question, but it's like, how am I gonna stop you also from just doing that, yourself, right? You know what I mean? So, but yeah, I think kind of the choreographing the whole process is definitely interesting, right? So I don't know if I really, because I see it more as a comment than really a question.
Of course, I could do it myself, but in the way, so you were more, I have the feeling you were more interested in, let's say, expanding the different ways in which one could create with inventive instruments, let's say, fantastic products. And then my question was like, could this become so the process itself could become a product that then you could just like bundle, and then
right.
I don't need to let's say hire or rent a big space, hire people, but somehow it becomes
so
easier.
But that's essentially the idea, right? That you don't need to, we never steamed anything before those workshops, right? Before we did the project, and the whole idea of these projects is that anyone can do it, anyone can learn. You don't need to print any drawing. You don't need to know how to read construction drawings or anything. All you need to do is just follow what you see, right? And that's kind of let's say the goal of this agenda that we have is kind of democratization of the whole construction process in a way, right? That it doesn't matter if it's you or me or our 5 friends. Anyone can kind of essentially use this tool and build a bit nicer environment for everyone.
I was pleasantly surprised to see the mixity up there. One of my other students' research is on kit bashing. He's very interested in how existing components or things can be recombined in unexpected ways, based on kind of a Lego modality or whatever. And he came across your work already before. That actually came up. I'm curious, though, how you came up or how you came to the term kit bashing for that application. And did it come through academic research, or did it come from just a more conceptual idea?
You mean, why did we specifically use kit bashing?
Why did you choose
because, I mean, kind of the way that sometimes these research projects are done, like there's a loose idea, like the team wanted to do these kind of digital overlays, and then you kind of find ways or avenues in which you can apply, right? And at a certain point, the question was, okay, how do we generate these overlays, right? Before they actually started with Midjourney and all those things. So the idea was like, all right, so maybe you walk around the city, scan parts of buildings, create kit bash libraries out of them, and then you recombine them or blend them on top of other buildings. But then they also started looking at Midjourney at the same time, and we kind of liked both, so we kept both directions, yeah.
So the Midjourney part came in after.
I
completely understand that where it came from. Thank you.
So I'm sorry I had to step out for a few minutes.
No problem.
I'm sorry if you actually touched on this, but I was really interested in kind of social applications of the form, kind of shaping capacities of the software that you showed just before the final video. And I wonder if you have seen any ways that these tools have been used as a protest instrument. I am thinking of some work that is done by mapping images onto buildings for protest. Like a couple of years, or maybe last year, there was an artist who did an installation on the Twitter building after Musk's hostile takeover, and that posted a lot of things that drew attention to the problem. So I was wondering if there is a way that this technology can, start making people jump out of the iPad and help people see injustices within the environment by mapping them onto buildings.
I mean, for sure, but I think actually kind of this also creates sort of a back channel where you can actually post things that you wouldn't be able to, do on the street, and you might actually get much larger audience, right? And kind of creating this, let's say, digital, parallel world overlapped over the real world, where, that actually how Mix City project started was kind of proposing, digital graffiti, right? So you essentially, instead of having one graffiti on a building, you could have 10 or 100, right, on the same geolocation, and then kind of see what is the legacy of the people or graffiti that were there and so on. So I think, yeah, definitely it could be, essentially used as a form of protest, but maybe kind of a digital or this parallel world.
Sorry, Adil has his virtual hand up for a while, so I'm going to let Adil ask.
Hello, can you hear me?
Yep.
Perfect. Okay. So Igor, thanks a lot for the presentation. Fantastic and really fun project. So yeah, I'm a fan now. I'm just curious about the kind of design decisions that you take that are beyond the techniques of fabrication, for example, the kind of systems you develop, etc. Or for example, in the case of the last project, the kind of back-end algorithmic setup for the scenario. For example, with the pavilion, how do you decide, or what's the kind of motivation to make it look the way it looks beyond its technique of production? So is it there to flaunt how it's made, or is there an outside to the kind of systemic fabrication logic? Or for example, in the last project, how do you decide how the NPC looks like? Why is it that it becomes this kind of globular, kind of horrific looking thing?
Yeah.
Yeah.
No, I mean, great question. Like for NPC, maybe I should point you to my student. But no, I mean, there was kind of, we always also give students a bit of, obviously, freedom and, kind of authorship in taking the project to a certain direction, right? Yeah, that was purely their design decision. And regarding the pavilion, why it looks like the way it looks like, I mean, it's a good question. Like, we went through like a large number of iterations, but one constant that let's say whichever iteration we did had to kind of answer to is that it needs to be built, like you would need to use AR tools to build it. Like you wouldn't be able to build it in any other way, right? So that would kind of, eliminate certain ways of, prefabricating repeatable elements that you can just kind of assemble even without AR and so on. So at that moment for us, it was, let's see how far we can push this tool, right? And then obviously, there's kind of a shared, let's say, design sensibility or interest in ways how we treat the materials that was kind of within the team. So I hope that answered. It was a bit of a vague answer, but.
I have one last thing in a completely different direction. So often the things like that we make as makers, because we are architecture people, the fundamental, well, the part that makes it research is when we reflect on it and we write on it. and it fits into some kind of other theoretical framework and becomes part of discourse. A professor emeritus here, Gregory Ulmer, has a theory of understanding humans and technology called electracy. I don't know if you've encountered it. It's a continuation of apparatus theory, meaning that the things that we make, the technology we make affects the way we think, and the way we think is affected, of course, and we continue a cycle of advancement both in technology but also in intellect. And electracy he poses as a next phase of how humans learn and understand outside of the gymnasium, which was the original intellectual origin probably of colleges and universities. His more recent work proposes that things like theme parks and places like this are actually the places where we house knowledge, because the way we learn is, as it's moved from words to images, becomes more pleasure than more traditional forms of pursuit. And I think this work fits very clearly into that. So I recommend looking at it as a way of continuing to think about the work and putting it into other contexts in the way we learn and the way that the things that we make embody knowledge.
Thank you.
All right. I think with that, we can let him off of the hot seat. Thank you so much. Thank you very much. Okay. Thank you very much, Igor, for a banger of a presentation. I think the conference started off with a bang, literally. I must apologize, I got the sort of sequence wrong, so I put you in the hot seat. But I want to introduce what originally would have been our first presenter here. So who is joining us online? Pierluigi D'Acunto is a tenure-track assistant professor of structural design at the School of Engineering and Design of the Technical University of Munich, TU Munich. He graduated with honors in building engineering architecture from the University of Pisa in 2007 and received a Master of Architecture with distinction from the Architectural Association School of Architecture in London in 2012. In 2018, he completed his doctorate with distinction at ETH Zurich. Since 2006, he has gained professional experience in various architecture and engineering offices in Italy and Switzerland, and has been awarded in several international architectural competitions. From 2012 to 2018, he was a research assistant at the Chair of Structural Design at ETH Zurich, and from 2018 to 2021, a postdoctoral researcher and lecturer. Pierluigi's research explores the convergence of architecture and structural engineering through computer-aided design in emerging construction technologies. His research interests are geometry-based methods for structural design, computational design through equilibrium models, structural form finding with machine learning, and fabrication-aware structural design using advanced digital manufacturing. His topic today will be human-machine collaboration for conceptual structural design. Let's please welcome Pierluigi.
Thank you very much. Can you hear me? Yes. Can you hear me? Or? Yes. Yes. Okay. Of course. I didn't see. So thank you very much for the very kind introduction, and it's a pleasure to be here at the conference. Unfortunately, I have to apologize. I was not able to fly to Florida, as here is quite busy time here in Munich for the start of the semester. So I didn't really manage to find the time to be there in person. There's a pity because I see that it's a great environment, also a nice discussion. But I hope it will be also fine to be online and to be able to discuss with you about my work and all the discussion about this human-machine collaboration in my case in structural design. I see in the case of all the other presenters in many other fields of architecture and engineering. So I share my screen so we can get started. Okay, I think you see my screen. So, well, the talk today is about specifically the point of view of structural design in the use of artificial intelligence. And specifically, the idea is to put forward and to share with you some of the recent research that I developed here at the Technical University of Munich, but in reality, this is all work that has been started when I was still at ETH Zurich. And specifically, a very much and very big part of this work is collaboration and ongoing collaboration that I'm carrying out together also with Carla Saldagna at the University of Florida. Well, I would like to start my presentation with this quote by the structural engineer Sergio Musmeci. And Sergio Musmeci is a structural engineer from the second half of the 20th century from Italy. He was a very special engineer because he was very much devoted to the developments of new methods in terms of building and designing new structural forms. Musmeci says that this is in 1972. When we speak of the use of electronic calculation in the field of structures, we generally refer to the enormous possibilities it offers in the verification of the stability of very complex structures. I want to take for granted these quantitative aspects of the use of the computer and draw attention instead to the qualitative effects that its diffusion may have and almost certainly will have in the field of structural design. These effects can be considered as the results of the interaction between the machine and the human inventive capacities and are bound to grow as humans learn to use the machine to explore ever wider fields of possible solutions. So this is quite interesting that is coming from a structural engineer. A structural engineer, as I said, is a very special one. You may know some of his work, and specifically these very outstanding and amazing projects. This is a built project in the south of Italy. The Ponte sul Basento is a bridge, a highway bridge that is connecting the city of Potenza in south of Italy with the highway. And this bridge actually was developed with quite a lot of effort in terms of the fabrication, but was designed with very innovative methods. And we see in these slides some of the methods that were used by Sergio Musmeci to design the bridge, very similar to methods developed in the same years in Germany by Frei Otto, for example. So you see on the left side, there are some models. These were developed with soap films in order to generate a minimal surface that is spanning in between the boundary condition that is represented by this wireframe metal structure. We see in the top of the slide a meta-acrylic model. This was designed and developed in order to do a structural test. And we see in the middle some drawings, and these drawings are actually one of the first representation of the use of the personal computer in order to generate form through the method of form finding. So developing a code that is able, given certain boundary conditions, to reproduce the same geometry that can be developed with the physical models like the soft model on the left. And this is a very, very early application of the computer for generating new structures. And it's very interesting to read also in the text of Musmeci that at that time when the computer was very much used still in the early days in structural engineering, mostly to verify the stability of structures. In his case, he was already foreseeing the use of computer for generating new structural forms that are going beyond what everyone was assuming in terms of conventional structural typologies. Unfortunately, Musmeci was not able really make use of computers and explore the potentials of the computers, because he dies a few years later. Well, this is to introduce the idea of the computer as a generative tool in order to use the power of the computer not just to analyze a predefined form, but rather to generate new structural form. Well, when we go into the digital age, and we talk about the digital age, obviously the role of design is very prominent. And in these respects, what is quite interesting in terms of the framework around the digital age in relation to the design and the theory is these inputs by Rivka Oxman that's introduced somehow and try to develop a kind of a framework in order to define the different ways how the human designer is getting into contact with a computer and using the machine in order to perform design-related tasks. So we see here in this diagram, she postulated the idea of having the human designer in the center and then different possible operations that are somehow representing all the operations that are typical in a design process: the representation, the generation, the evaluation, the performance. In terms of the way how the designers is interacting with these different operations, then it is possible to define different types of design-based models. In certain cases, interaction is very implicit, so there is not a direct real-time interaction with the tools and the means of representation. In other cases, the interaction is directly explicit, and in this case, there is a full engagement between the human and the machine. So a very typical model, the very simple model is the so-called paper-based model, in which all the phases of evaluation, performance, and generation are somehow implicit, and the designer is interacting with the means. So the paper-based model is taking advantage of the tool in order to represent the actual design, but not too much to perform the other operations. This somehow is typical even in the basic approach to design. We see here a nice picture of the SOM office in Chicago. And this is from the 1958. And this was obviously at that time the only way how designers were able to interact with the design. So representing something on paper and then modifying this in order to slowly converge to the design, the final statement for the design. In this case, obviously, the interaction is very not direct and requires several iterations, and it is not possible to have this one-to-one and interactive real-time interaction with the tools. The next step would be the introduction of the digital tools that allows for this more real-time use of the tools and transformation of the design in such a way that is possible to incorporate a more feedback between the human and the digital model itself. Obviously, in the first place, in the basic case, this interaction is minimal. So the tools, the computer is used mostly to represent somehow as a replacement of the paper. And the tool is used for drafting, but not really to engage into the operation of exploration of different design options, generating different options, and evaluating the performance of the design. Typical, obviously, in this case, example would be the Sketchpad that was developed by Sutherland. And obviously here we see already a first way how the human and the machine are coming together, with a human that is able to, in real time, adjusting the geometry of the structure. And very interestingly, we see in this example, it is indeed a truss structure that is shown on the screen. And by having this model, it is possible to evaluate the internal forces in the structure, but still the interaction between the human and the machine is quite limited. Another quite relevant design model, especially from the point of view of structural design, is the so-called performance-based model. In this case, the machine is also used in order to run certain performance evaluations, and this is used as a feedback for the designer in order to adjust the design itself. Here, for example, we see a typical finite elements model that is used in order to evaluate and analyze given structures. Obviously, also in this case, the interaction between the human and the machine is quite limited in a way that the model is loaded into the software. The software is evaluating the structural performance of the given model in terms of the stresses or the deformations, and then is providing a feedback to the user. And the user can, in a quite indirect way, define where the parts of the structure are not working, where there are peaks of stress or deformation, and then try to adjust. Also in this case, again, this is a quite static model. There is not, or the machine is not really used in order to suggest variations or even to generate new variations of the design at once. Obviously, ideally, a model that is taking into account all these steps and there's a quite direct interconnection between the human and the machine, that would be the so-called compound model, and this would allow a full integration between the different design operations within the same workflow in such a way that the human and the machine can collaborate together within the same design process. This is somehow, we will see later, what we try to attempt by merging our methods and tools for structural design with the use of artificial intelligence. Before we get into this, actually, I would like to give a bit an overview of what are the methods that we use for structural design. So we use methods that are in this for generative structural design. That means develop form from scratch, structural form from scratch that perform in terms of the structure, but also obviously integrating other aspects, like, for example, architecture-related questions. And to do this, we see that the most powerful way to generate new structural form is indeed to work at the same time with form and forces. And this is a typical approach of structural design that was very much used in the past, and nowadays is somehow was getting lost, somehow has been rediscovered since a few years. But if we look back in the past, actually, and in the past, I mean a very long time ago, in the first half of the 18th century, this was a typical approach to understand how structure works and how to make use of the form of a structure to be able to tell how the forces should flow within the structure. And this is very much related to the disciplines of graphic statics. So graphic statics is a discipline that was initially developed in the first half of the 18th century that links directly form and forces. And we see here one copy of the book of Varignon, and in here we see all these drawings, and these drawings are representing cables that are put in equilibrium by adding different masses. So the masses on appended hanging from the cables, they enforce the cable to take a very specific shape, and this is a shape that makes the cable that is infinitely flexible into equilibrium. So you might have studied this also, some of you at the high school, and the principle is very simple. Given a structure in equilibrium like the cable on the left, it is possible to represent the equilibrium of the structure with graphical means. And specifically with this diagram that we call the force diagram that we see on the right. So we take a structure in equilibrium. That means that each and every node of the structure is itself in equilibrium. But that means that if we consider one node of the structure and the forces that are applied to it, in this case it would be the weight of the mass and the forces that are inside the cable that is put into tension by the mass, these three forces can be combined in such a way that they close a polygon we see on the right. So this is the so-called force polygon. This is nothing else than the principle of vectorial addition. In order to have equilibrium, the three forces should cancel each other, and they cancel each other when they close this triangle of forces. The peculiarity of the force diagram that we see on the right is that we can measure the lengths of these vectors in the force diagram. These are proportional to the internal forces. So this tool is a very, very simple but very powerful tool that allows us to control at the same time form and forces. Obviously, we can repeat the same construction for each every node of the structure until we get to the both final form and force diagram. Now, what is interesting here is that this tool, we will see later, can be used not just to analyze how big are the forces inside the structure, but also as a generative tool in order to transform and generate new structures that are, by definition, in equilibrium. So graphic statics was used very much at the end of the 19th century and developed into an autonomous discipline. And this was mostly thanks to the contribution of Professor Karl Kuhlmann from ETH Zurich, that collected all the geometric constructions of graphic statics into the Graphische Statik. That is a book that is integrating all structure engineering construction using graphical methods. We see here, for example, the design of a suspension bridge on the top of the slides and the corresponding force diagram below. And this, very interestingly, has been then developed very much into mathematical formulation, especially in projective geometry. And this was very much thanks to the contribution of Luigi Cremona from Italy in also 1872, and the very famous scientist James Clerk Maxwell, that both developed a projective geometry-based method in order to generate at once these two form and force diagrams. Now, I'm showing this because actually quite a big and important part of my research was, and it is, to take this knowledge and bringing it into contemporary computational environments. And this was developed by introducing the so-called vector-based graphic statics. And vector-based graphic statics, together with other methods of other researchers all around the world, tries to take this knowledge of graphic statics and all these constructions that at that time were performed on paper. So it was very much tedious. For every transformation of a structure, it was necessary to rebuild manually all the form and force diagram. This is brought into a computational setting that allows a real-time operative transformations on the form and force diagram. And on top of this, thanks to the use of three-dimensional software environment, it is possible to bring all the construction from 2D to 3D. So you see here, for example, this is a so-called tensegrity structure on the left. So we see in blue, we use to delineate elements of the structure that are in compression, in red in tension. And by developing this approach of vector-based graphic statics, given a form in equilibrium, it is possible to generate a corresponding force in equilibrium. This, I will skip the detailed explanation, but is working very much using rules based on graph theory. So first of all, we generate the topological representation, so the graph of the structure, and based on this, we are able to generate the different force polygons, as we saw before in the case of Varignon, and assemble them in one unique force diagram. Obviously, thanks to the use of computational three-dimensional environment, it is possible then to operate transformations of the structure, so transform the form and the forces at the same time. This allows, for example, to accommodate various requirements that are coming from architecture, for example, in terms of the form, but at the same time accommodates requirements coming from statics. So, for example, try to reduce the internal forces, that is, try to reduce the necessary amount of materials for the builds and construction of the structure. Obviously, this can be extended to much more complex structures like this tensegrity structure that we see here, and also three-dimensional systems that are self-stressed, like this two form and force diagram. Interestingly here, either one or the other can consider as a structure in equilibrium. For example, if we take the force diagram on the right, it's by itself a structure in equilibrium, its force diagram would be the form diagram. This is because of the reciprocity between form and force diagrams. And this principle that is equilibrium, that is a basic principle, can be applied to any scale, any material, obviously with certain constraints, but potentially any kind of structure system. We see here, for example, this cable nest that is in tension. Here, a compression-only dome that is somehow inspired by a project by the engineer Pierluigi Nervi at Palazzetto dello Sport in Rome. Here, for example, a combination between this spiraling pattern in compression with this ring in tension. You see again form and force diagram. And at the same time, it is possible to operate transformations that are constraints. For example, here we see the design of this suspension bridge, and we constrain certain elements of the force diagram in order to have the same force in the suspension cable. Now, this works directly with form and forces. In parallel developments of our research with colleagues at ETH Zurich and now here at TU Munich, we introduce a new dimension to these developments and design of structures, especially with the combinatorial equilibrium modeling. And this new dimension is actually like making a step back and operating directly on the topology of the structure. And the topology of the structure represents, in a very simplified diagram, a 2D diagram, how the elements of the structure are connected to each other, and what is the combinatorial state of the internal forces in terms of tension and compression. So given this diagram on top that we see here, we can assign a certain connectivity of the different elements, and based on these connectivities, using the combinatorial equilibrium modeling methods, it is possible to derive form and force diagram. And obviously, as a designer, one could operate at this point, not just on form and forces, but directly on the topology of the structure. And this, as I said before, opens up a new dimension in the exploration of different structural possibilities and different structural options, because as we see here, given the initial same ground topology, it is possible to start to test different ways how to connect the elements within the structure and assign different patterns of tension compression. And for each and every of these topology, it is possible to apply different metric variation in terms of the size of the element or the forces, the magnitude of the internal forces. And this allows to having in a very complex and quick way quite a broad range of possible structural variations. This obviously can be used to explore different possibilities to solve the very same initial problems. Like we see here, the same topology is conveyed into different form diagrams. So these are shell structures, tension and compression seen from top. And this can be applied to any kind of structural system, because we are working with equilibrium principles that are the same in every kind of structural system. That is, we can operate with these tools in order to design new bridges, like we see here, pedestrian bridges that are hybrid system in between conventional typologies, like an arch bridge, like the one in the top center, that is mixed up with a cable stayed bridge, or many other systems that are very much going beyond the usual structural typologies. Here we see the same tools applied to the design of large span roof structure like this stadium. And again, by having small and very simple quick variations on the topology of the structure and the assignment of tension and compression, it is possible to explore completely different solutions. Here, for example, the same approach applied to the design of the load-bearing structure of a building, going beyond the classical approach of the columns on slabs and try to redirect and manipulate the internal forces to accommodate, for example, requirements coming from architecture, like having more open space, more generous spaces, double level spaces, or try to compact all the load-bearing structure in a certain portion of the buildings. Well, given this now, the question is how can we control this all this variability of different options and parametric models that opens up the possibility potentially to generate thousands and thousands of structural design options for the same given initial brief and problem. And this is the way we try to address this is by introducing in the conceptual structural design the use of machine learning. And this is a first attempt that we made, actually, a project that we developed when I was at ETH Zurich together with Carla Sardagna and other colleagues. And the goal here was very much about thinking beyond the typology, so going beyond the idea of having clear structural typologies to follow, and also going beyond the idea of optimization. Another way that is a common use of computers in structural engineering is to optimize. So give a certain boundary conditions and then try to minimize a certain quantity. Obviously, that is very relevant in terms of structural engineering, but not so much in terms of structural design. So starting with a very open brief, designing a bridge that is connected to points, obviously, in the first place, in the conceptual phase, is interesting and very important to test completely different variations. So we used this approach in order to make a way that's to simplify somehow the phase of the exploration of the different structures that can be generated now with the tools that we saw before. By using the machine learning supports, like we see here, the building that I was showing before. And this is somehow a framework that we developed very much inspired by the framework that we saw before, introduced by Rivka Oxman, but somehow introducing this idea of the collaboration between the human and the machine. So having the possibility that the human and machine are literally collaborating as different designers within the same design task, using the power of the machine that is able to handle a large amount of data and making calculation and computing very fast, but also combining this with the qualities of the human designers that are very much about the creativity of thinking outside the box. And well, we then built up this framework in such a way that we readapted somehow the categories that were introduced in the previous framework by Oxman in order to adapt them better to the use of the machine, especially machine learning processes within the design process. And we see here that obviously the same operation of generation of the design options, the evaluation, in this case, separating the quantitative evaluation, the qualitative evaluation, because they are performed by the two actors in the process, in one case the human, in the other case the machine, and then the clustering operation that is used in order to allow the human designer to be able to grasp this huge design space of possible solutions. Obviously, The design process is not linear, it's not sequential. Each of these operations can be performed in a non-sequential way, repeated several times in a non-linear fashion. So we tested this in a quite basic setup. Again, in the first place, in order not to open up too much the design possibilities, with a ground topology that was defined. And the test was applied to the case study of designing roof structures. We see here on the left the topology, and on the right some instances of the design options. This was developed by using a parametric model, using the combinatorial equilibrium modeling, and then letting after setting specific ranges of the input parameters, letting the model generating structures, randomizing the setting of the different parameters. What is quite important to say is that all structures that are generated, since they are built with this quite robust method, the combinatorial equilibrium modeling, are all structures that are in equilibrium. Some of them, from a formal point of view, may be non-completely reasonable in terms of their possibility to be actually constructed, but they are all structured in static equilibrium. Obviously, what's happening is that by having this large number of input parameters and the possibility for each parameter to range in between different options, the design space is very large, and there is a multi-dimensional design space, one dimension for each parameters. And the problem obviously becomes for the human designer to be able to grasp this design space and to navigate into this design space. Even because obviously some of the parameters, they perform in a non-linear way. So it's not possible just to control one parameter at a time and assess a linear transformation of the structure. And because of this, we introduced a machine learning model that is the self-organizing map. This is a self-learning model that is able to, given these inputs, that is the design space of structures that are generated by the combinatorial equilibrium modeling, the model SOM is able to cluster the structures according to input criteria that are defined by the user. And in this case, for example, we define as an input criteria the similarity in forms of the structure. That means that the self-organizing map methods was checking the similarity in terms of the position of the coordinates of the position of the nodes and the coordinates of the nodes of the structures, and then clustering all the structures according to this, which ended up in this map that is a 2D map, 40 by 40 map that shows 40,000 structures concentrated into this one map. This, in the first place, is used in order to create a more intelligible map or visualization of the design space. Each of these cells is actually containing a certain number of structures from the original design space that are all clustered within that cell because they are all similar in form. On top of this, on the right, we see the possibility to map specific performative criteria. For example, in this case, we see the load path that is a measure of the performance of the structure. And this is done on top of the map in order to allow the human designer now to be able to navigate within the map, check the different structural solutions, and then make an evaluation of the structure, qualitative evaluation. In the same time, it is possible to apply a quantitative evaluation that is done directly by the machine. And this would lead to the possibility of the human designer to narrow down the design space from the initial 40,000 structures to a more limited amount of structures. And this can be done by selecting and discarding certain design options. What is interesting is that at this point, once structures are labeled as 1 or 0, either selected or discarded, this can be encoded into a new model. For example, in this case, we were using a gradient boosted tree model that is another machine learning, this scaled supervised model that allows to learn these preferences in the selection of the structure by the human designer, and then potentially rebuilds and regenerates a new structure that are most likely falling within the structure that the human designer would select. And after this, the machine is able to reproduce and produce new structures that can be then again assessed by the human designer. And obviously, as I was showing before, this process can be iterated as many times as possible, narrowing down the design space and then opening up again. Here we see 3 of the structures that were generated by these methods, completely unusual structure, and we see this one in the video, something that we would never come up with in the first place if we have our, let's say, bounded to our experience of existing structures. This method obviously was very much applied to structural design, but it's a general method, can be applied to any kind of other disciplines. We made also a test to connect the design, the structural design with other technology-driven aspects. For example, in this case, aspects related to building physics, like the solar exposure of the building during the, in terms of the penetration of direct sunlight into the structure. And this, for example, was made by incorporating other algorithms on top of the combinatorial equilibrium modeling within the design workflow. We made a quick test in this case study by designing structural facades that at the same time were working also in terms of shading. And we see here, again, the self-organizing map here, in this case, 60 by 60 nodes, 26,000, around 26,000 design options. And again, the possibility for the human designer to navigate within this design space in order to define the next step in the design process. Here we see some of the options that are connected to the design process that we saw before. Well, this is somehow the basic framework we developed also together with Carla. The next step was in our, let's say, collaborative research was to try to see how to enhance also the interaction between the human and the machine. So in our next step of the research, and this is still an ongoing project, we are incorporating the possibility to introduce a direct way how the human designer can interact with the machine, specifically working with text prompts. So you are very much familiar with all the developments in the last few months in terms of the use of large language models like ChatGPT. So the idea in our approach would be to also make use of this possibility to communicate and interact with the machine using text prompts. But in this specific instance of research, we have the backgrounds of all the other tools that I was showing before and the framework that we developed before, in such a way that the design is not just generating random forms, but the machine is able to generate forms that are always in equilibrium, in static equilibrium, and they fulfill not only qualitative goals or criteria, but also at the same time also quantitative criteria. So it's really about trying to merge the creativity of generating new forms with also the possibility to control the performance of the structures. And here we see a workflow that we developed, and we are still developing. This is work in which we have the generative phase at the beginning. Again, this using the combinatorial equilibrium modeling to generate the structures in equilibrium. And then we have a first step of evaluation in which we can also integrate other methods like the finite elements method in order to evaluate certain performative criteria and parameters of the structures. And then this goes into this process of filtering. We have a first step we see in the second column of the flowcharts that is about the quantitative filtering. And this is about casting in putting hard constraints, casting out of the design space all those structures that are infeasible in terms of certain structural criteria. For example, structures in which the internal forces are exceeding the capacity of the materials, or structures in which certain parameters they render the structure not feasible to be constructed. And after this filtering, and this is done at together with the machine can control this quantitative filtering. There is a second step of qualitative filtering. This is similar to what we saw before. So the self-organizing map is used to cluster the multidimensional design space in something that is intelligible by the human designer, and the human designer can start to operate on the design space that is rendered in such a way that is readable. After this filtering, then we go into the phase of labeling. So the human designer and the machine at the same time, they can place and put labels to the structures. These labels can be either related to qualitative aspects of the design, so how the structure look like, and this would be done by the human designer, or other labels can be pure quantitative labels in terms of the performance, in terms of specific parameters. And then this is all put together into a short textual description of the structure. So each design option, each structure would be described in terms of a paragraph that is combining these qualitative and quantitative features of the structure. And then this goes into the last part. We see here the training data generation, in which we use the combination between the vector of the structure with a paragraph describing the structure itself to will be everything embedded into a natural language processing model that is able to create text vector embedding, so linking the two things together. And by doing this, we then introduce a GAN model that is training, and the trained model then can be eventually go back and linking the outputs with the input parameters. So this is what is done on the side of the developers of this data set of structures. And then once after the training of the model with the GAN, this data set can be deployed to the human designers that are able then to use this in order to make a text prompts and then retrieving automatically new structures generated using the initial inputs. So we see here some tests with this at the level of high-rise structures, again, the topology and the form. And here we see the sum with different types of structures. Here again, different sample from the initial data sets. And then here the phase in which we introduce the labels to assign a specific qualitative connotation and features to the structures. And this is done on top of the sum, and the human designer is able to assign specific labels to specific parts of the sum by using this graphical interface. What's happening in the end is that when the human designer is then adding a text prompts to the model, for example, asking for structures that are thick and heavy, like we see in the top left, then the model is able to produce those structures as most likely are linked to what was labeled in the data set as thick, as heavy. Obviously, by using a natural language process, it's also possible to go beyond the specific label and write generic sentences, not necessarily using the keywords that were used for the labeling, and the model is able to link directly the text prompts to the structures that are generated within the system. So this is somehow where we are now. Now we are working together with Carl and other colleagues to try to make this process much more user-friendly and being able to deploy it as an open source software, so that either architects or structural engineers can then use this in the very early conceptual phase of the design. Okay, so that's it. I would like now to close my talk with this, again, going back to Sergio Musmeci. He says, it is obvious that the computer can be of great help in the verification phase, but on the other hand, it is also evident that only if a way is found to use it also in the first phase at the service of the inventive capacities of the designer, will it be possible to ensure that it can contribute to the research and creation of new and more efficient structural forms. I believe that one day, perhaps not very far in the future, this will be the way of designing for a creative structural designer. The automatic calculation, far from limiting their imaginative possibilities, will represent efficient support for them, as well as powerful means of amplifying their impacts on reality. Somehow the motivation of our research is very much about taking advantage of this possibility of collaboration between the human and the machine to open up new imaginative possibilities and enhance the creativity also in fields like structural engineering that usually are very performative driven. So thank you very much, and I'm very happy now to answer your questions and discuss with you.
All right, Pierluigi, would you stop your share screen, please?
Yes, yeah.
Thank you. And we can take any questions from the floor. Ricardo?
Yeah. Can you hear me? Can you hear me?
No. Maybe it's maybe easier to come to the podium to ask questions. We'll have a line here.
Can you hear me now?
Yes,
okay.
yeah, I can hear now.
Yeah,
Thanks.
Thanks for your presentation. I was wondering, so you showed something which was based as, let's say, structural. I mean, I'm not a structural engineer, so I'm an architect, but I'm a bit alien to the field, so take everything with a grain of salt. But you showed something which is related to structural engineer, which is a discipline which, of course, goes well hand in hand with calculus and with physics, and so it kind of lends itself quite nicely to fit also in working together with computation, as also you were showing with Musmeci. But I was wondering, so at the same time, what I also appreciated a lot in your presentation was all, let's say, the more historical look with also these references, for instance, such as Nervi, no? And I was wondering if you could think of machine learning applied in these fields also as a way to, if it would be possible to use it also to learn from this example of the past, you know. So for instance, you know, Nervi is precisely, I would say, beyond optimization. So to kind of cultivate a certain data set, I don't know how to call it, but a certain archive of things that, or examples that are interesting precisely because they go beyond optimization, and try to use it as a way to, let's say, invent solutions that are not necessarily new from a formalist point of view, but they somehow re-articulate this, like, let's say, great heritage of the past. That would be my curiosity.
Yes, thank you very much. Actually, it's a very, very good question. And indeed, it's really very much about learning also from the past. And you see, my presentation and my research is very much about learning from the past and try to reuse and reinterpret certain methods and tools from the past in a more contemporary way, making use of the technology and the possibility that we have nowadays. And indeed, yes, that is something that would make completely sense. There is already research ongoing by our group and also other groups that are trying to develop also data sets of outstanding example of structures from the past and use these to inform the generation of new structures. This, in fact, we were mentioning Nervi, but obviously there are many other famous structural engineers and projects that definitely would be extremely helpful to have in a data set in such a way that it's possible then to learn directly from these projects, understanding how these master builders and master designers from the past were able to go beyond these more conventional approaches and try to use them in order to inform the design that we can do nowadays. For example, extracting certain principles from these outstanding projects and then try to reconvey this principle into the design of new structures nowadays. So definitely that is something that is especially relevant. For example, now we are in the process of starting a project that is about creating a data set of bridges, mostly outstanding bridges or very relevant bridges worldwide. And what we are doing is we are collaborating here with a colleague here at TUM, Professor Angela Dai, that is working in 3D reconstruction using machine learning. And the idea there is to be able to develop a data set and train a machine learning model that is able then to generate structural models of bridges that are presented to the machine in the form of pictures. So from the pictures of these bridges, then the machine learning model is able to generate at once not just a 3D model or a wireframe model of the form of the structure, but literally a structural model in equilibrium. And this will be using these methods that I was showing before. And this again is also to be able to extract certain principles and then being able to have, once we have these data sets, the hope is that the machine will be able to use this principle to inform also new structural design solutions.
One more question? Yeah.
I'm sorry that I let you come to the podium.
In seeing this work, I think back to history class and learning that architects such as Antonio Gaudi and designers and artists and craftspeople of the time were part of a reaction to industrialization. And whether it's true or not, and the idea or the question that I have is still there, which is to say that, do you think that this effort is a reaction? Do you place it in a category of reaction to the way that optimization seems to be the more prevalent way of utilizing technology like this? And if so, do you see it as a way of being crafty? That would be the way I would put it. Thanks.
Yes, thank you very much. Also a very nice question and very interesting topic. Definitely, there is somehow a sense of reaction in what we develop. We try to not too much to question how the tools are used, because obviously also being able to use these tools, computer for optimization, is a very relevant topic. But somehow the idea here is also to see to which extent we can really make use of these tools, not just for the specific phase or parts of the design, but also in a more creative way, which means we had the idea, and then we believe that the tools nowadays, computational methods, are not used as they could be used, and we can embrace these methods and tools for many more tasks and in a much more broad way in the design process. Definitely the use of the computer in structural engineering, as it is conventionally done nowadays, is very much about speeding up certain calculations and try to develop efficient solutions, but it's very much rooted towards finding a very specific solution out of many. And the way how this is done is very often starting from a predefined starting points that itself can be questionable. So what we try to do is to make a step back and see how we can use these tools. Somehow also what was expressed in this quote by Musmechi, on how we can use to explore different structural solutions, and then potentially afterwards go into the optimization. But in the first phase, in the conceptual phase of the design, when the design itself is not fixed, these tools are very, very relevant and useful in order to explore, to help the human designer to explore solutions as they would not see themselves, because very much possibly even biased by their own experience. So in this regard, yes, it is also a way to bring very much creativity and maybe crafts into the process. On the other hand, design, it's about creativity, and also when it comes to bringing to these more technical aspects, there is very much room for creativity.
Okay, I think with that, it's time. Let's thank Pierluigi for his very informative presentation.
Thank you. Thank you very much.
Okay. I'm very pleased to present the final panelist of the morning. Benjamin Enemoser is an assistant professor of architecture at Texas A&M University, where he leads the research lab for artificial intelligence in architecture. He has previously taught and lectured at UCLA, the University of Innsbruck, and the University of Applied Arts in Vienna, among others. He studied architecture at the University of Applied Arts in Vienna and the University of Innsbruck, where he graduated with distinction. He has received several fellowships and grants, including a research grant from the Academy of Performing and Visual Arts at TAMU, a CRS Foundation Probes grant, and the START grant from the Austrian Federal Ministry of Arts and Culture. His research on computation design, robotics, and artificial intelligence in architecture was published and presented in international journals, books, conferences, and academic institutions such as the AA London, Bartlett UCL, Tongji University, EPFL, and Taubman College of Architecture and Urban Planning. He is a licensed architect in the European Union and founded his practice in 2016. He recently collaborated with Google R&D for the built environment, Carvana, and Gensler DXD as a technology consultant and design lead. His topic today will be on latent manifolds.
Awesome. Hello, everyone. My name is Benjamin Annemoser, and thank you very much for the invitation and having me in here. As Lee already mentioned, I'm from Texas A&M, and today I will show an array of research that includes some early attempts that we did at UCLA when I was back there, and some of my also work from my studio, as well as developments of the last years, including projects, publications, and research that is also developed with my research partner, Ingrid Meyer-Hufnagel from the University of Innsbruck. To contextualize a little bit where we are operating, I situate this work and research within the fourth industrial revolution, where multiple devices and humans collaborate with each other in an ecosystem of technologies. And for example, here, where we see an ecosystem of technologies within the fourth industrial revolution that are capable of demonstrating awareness of space and each other's existence autonomously. So we see nonlinear behavior of individual agents and components with the system, which is based on an increased intelligence of such elements, agents and also actors again. And in tandem of that shown, technologies, and as part of the fourth industrial revolution, artificial intelligence and more specifically machine learning are part of these ecosystems of technologies. In that context, my research focuses on how machines perceive, analyze, and also generate the built environment and differ from conventional parametric and computational models. And I'm just throwing this chart out real quick. You will hear me throw around with different terminologies, umbrella terms of artificial intelligence, down there, machine learning, as well as deep learning. And I think it's important that we just contextualize that just a little bit in the beginning. So, and it's also important to note that in the research demonstrated in this presentation, we will see mostly unsupervised learning systems that speculate on their potential to extract and hybridize architectural data. And this is a very general overview, but nevertheless, I like to show it, this slide, to show the widespread applications that AI already has on our everyday lives. And just going through a few, from medical image analysis to driverless cars. If you have seen a Tesla, AI has seen you, all the way to weather prediction. If you Googled this conference, most likely an AI bot helped you in the background, and so forth. So the implications are wide, and they're here. But to roll back for a second, this was some early research by Google exploring generative adversarial networks, or short GANs, which is a class of unsupervised learning algorithms. And these images made me very curious and also initiated my personal interest in research in AI and architecture as an analytical and generative tool. We all agree that these are depictions of a goldfish, but clearly have interesting features we haven't seen before. Instead, we observe a distortion of elements, a hybridization of function, yet following conventional norms and features that yield us to agree that this is a depiction of a goldfish. To me, even probably the most interesting goldfish I have ever seen. To go even further and to investigate how, for example, generative AI can be utilized for architecture, we can look at this example and the use of GANs. And I apologize to everyone here who loves dogs, and this might be a little bit disturbing, but it proposes a very interesting concept to hybridize various taxonomies, species, typologies into emerging depictions. With a non-binary and, most importantly, non-linear yet manifold notion that derives from the Latent space, which is the premise we will explore moving forward to this presentation. And obviously, the top right and the bottom left is not really where I feel we should lay or we should try to do our research, but it's right in between this seamless blending and interpolating in between, which occurs definitely in this example and in the later projects. In my research, I distinguish the use of AI in behavioral and generative AI. Here we have two examples we explored at UCLA around 2017-18. Left, you see an example of AI using ML agents and game engines, while on the right, it is trained on artistic influences and generates new artificial depictions of architecture, which in this lecture will be mostly what we speak about in that sense. To go a little bit more in detail, in this example from UCLA, multiple iconic buildings in downtown LA were selected, and the machine was tasked to generate the existing architecture into hybrids with artistic influences outside the field of architecture. That being said, we use different media artists, sculptors, and painters, and fashion designers as stylistic precedents, with style transfer style transfer, the buildings were transformed into strangely familiar new depictions in, again, the style of the precedents. The aim is that architecture cannot live in a vacuum and has to collaborate interdisciplinary with other creative fields in this specific design studio that we develop with the students. And also I think in that sense, important to note, in 2017, this application is far behind what we can leverage today with Google Colab and cloud-sourced machines, and it was obviously a pre-trained system. But we can go even further and train machine learning algorithms to semantically detect features and translate them to other typologies. For example, here in the video you see a cycle GAN that was trained on horse and zebras. I think we're all aware about the example. On the left, the original image, and then the machine is able to transfer the horse into a zebra to its best knowledge. Although this is called semantic feature translation, the machine has no knowledge what a zebra, a horse, a building, a city is, but it forms an understanding of a subject in the latent space by analyzing data and its features. And in this regard, we also come to the core of machine learning and AI process, namely data. And this is, for example, the data set the algorithm from before was trained on in order to transfer the features of a zebra to a horse. And working with vast, messy data sets, we are not just working with different form of data as conventional computational algorithms, but we also have to raise the question of bias, data diversity of the data, and of course, the authorship that we as architects take in that role. And this is an example of an excerpt of an architecture data set, an eclectic selection of buildings that you get when you type in a modern house in Los Angeles, for example, in Google. But again, it resembles the same structure as the data before. And here, I think very important, talking about authorship and agency, the architect assumes a role of data curator. More to that later in regards also to Heinrich Wölfflin, as we'll talk about it. But by selecting the data and collaborating with the machine in terms of human machine learning, and then working especially with GANs, who has generators and discriminators, there is this interplay between the forger, the critic, or however these generative adversarial networks are explained. And this premise was explored in the research project ML City, exploring GANs in combination with architectural data. This research also made its way into machine learning at the city by Color Scarpa, and is using vast amounts of satellite images, data from remote sensing technology, including cities, landscapes, and the built environment from, oops, the video is not playing. There was a video. And I'm in particular also interested in how the machine perceives, analyzes, and generates the architecture through its own lens that differs from a human point of view. So for example, pay attention how pools are deemed as essential elements and that are from the Los Angeles data set and are incepted into the Barcelona block along with suburban features. And you see how Barcelona and LA clash into each other and create a new proposal of a city with different densities, structures, ratios, and so forth. Or how plant versus grown architectural structures, like here between Marrakesh and Barcelona, might create a new taxonomy of architectural elements. Marrakesh's small courtyards and deep courtyards fill the outline of the Barcelona block, while clear axis and orientation persist in these outcomes. In this example, even multiple cities such as Delhi, Los Angeles, Portland get trained, perceived, and also hybridized into each other, where specific features, elements of each precedent persist and also are, again, traceable. The same with Portland, that turns into a garden city, keeping the suburban distribution, the grid, that's the integral part of the latent space, also after training. And the same technique is deployed to explore in combination with a present issue, namely anthropogenic climate change. Here where we attempt to train these exact same machine learning systems to predict climate change in specific areas, landscapes, urban or rural territories, and propose a solution that is adapted to that new reality. So therefore, we collected information and data from NASA and other sources to establish a prediction how certain areas will transform in the near future and what the impact will be. This was a seminar that I taught, and in this course, we attempted to establish a case and also find commonalities between current landscapes, areas, and future territories so that the machine learning system can be trained to predict environmental factors and find solutions that might be resilient to the changing environmental factors. And we applied these techniques to coastal regions like river deltas or marshlands here in Florida. Actually, some of my students were from Florida. They were keen to explore that. And in these case studies, we tried to learn from cities like Venice, Italy, Amsterdam, and so forth, which already have canals and coastal attributes or are fighting certain environmental factors, which are within the urban fabric. So the results demonstrate how hybridizations of these cities can be deployed towards impacted areas and propose a new built environment that holds the DNA of various precedents. Or if we look how Greenland will look after the ice is melted and becomes inhabited, to the prediction of NASA's data and models, we made a case that Greenland would look similar like Norway potentially, and use the deep learning process to depict rural areas to become wildland-urban interfaces. In this pursuit, we also investigate how these tools with remote sensing technologies, such as satellite imagery, we are able to develop planetary cityscapes. And here we have the possibility to expand the data set from Western canons or to vernacular structures through the help of satellite imagery. As mentioned, the diversity of data is crucial in order to also train it properly and get the proper results. This research was just recently published in the latest IJAC issue about data justice, where we claim that satellite imagery and remote sensing technology probably for the first time allows architects to access and create data around the globe that is inclusive and diverse without literally no additional cost, effort, or any issues, which would have been way more tricky before using these data. And here, a few more examples of planetary cityscapes that encompass modern Western, but most importantly also vernacular topologies around the globe, harnessing the potential of AI systems to hybridize in the latent space. And once GANs generated and hybridized the urban fabrics, we manually evaluated and dissected these planetary cityscapes through classical figure ground analysis. And in result, we discovered that the classical figure ground analysis and form analysis might not be suitable anymore, but in consequence, we need to utilize other techniques and vehicles to evaluate for GAN-generated results in architecture and urban design. And in this trajectory, Convoluted City, that was just presented last week at Acadia and exhibited in Bologna last summer, also investigates how to evaluate, interpret, and read these latent manifolds. Convoluted City, in that sense, also asks the question of where the city starts and where it ends. What is the land we live on? In that pursuit, a multidimensional cartography is developed where for the first time an AI's latent space is translated into physical matter. And notably, no geometry, as in the previous voxel or 3D print, is needed. And in the notion of map making is world building, architects in the past have attempted to alternative and universal cartography to rethink planetary interconnections and relationships. And these practices approach a different reading and understanding of the planet we live on from a merely two-dimensional representation. The idea of convoluted city is to superimpose the artificial environment you live on top of the natural environment you live from and the waste landscapes you generate. Without such an overlap and the experimental computation between them, you will never understand or develop a sense of responsibility towards planetary interests beyond human survival. The resulting chimeric urban landscape should trigger your imagination to rethink urban ecologies and interspecies habitations that are beyond the human-centric modernist idea of the city. This is made possible by creating an unprecedented three-dimensional version of the latent space, not just as a visualization, but also as a physical matter that holds the entangled relationship of our environments. Before satellite data collection, we studied the interconnectedness between cities and their dispersed landscapes. In our method, true and false color remote sensing images were curated, and through the use of an enhanced color spectrum, a different way of seeing other than human territories is enabled. And using this research, we generate data sets for training a neural network, specifically, again, GANs. And with the latent space and manifold interpolation, the results geared towards intersections and entanglement versus difference. By using manifold interpolation between selected seeds, we created hybridized animations of urban landscapes, comprising 3,760 images for each. Video playing. Is it playing? Oh, here we go. Very slow. Oh, now it's playing. So these images were then utilized in 3D printing, where collaborating with Stratasys, we employed their PolyJet J850 and voxel printing technology. And each image was translated into a single layer with thickness of 12 micrometers, forming a vertical print sequence. This process entails dithering of the image data from RGB to a CMYK-WA, so that only 6 materials were used in such a high resolution that the gradation among them allowed a wide range of colors. And with the PolyJet's printing resolution of 300 dpi in the x-axis and 600 dpi in the y-axis, the images needed to be processed in a 2:1 rectangle ratio for accurate proportion, and resulted in 42 billion uniquely addressable data points for each model. So if these data points is directly translated into the physical matter. We also create a visualizer that helps us to predict and see transparencies and the distribution of these data samples. But unlike previous voxel print research, our approach omits geometry like conventional additive manufacturing and uses 1 image per layer instead of 7, but requires a dithering process for each GAN-generated image. And our results demonstrate a unique translation of 2D images into physical matter, eliminating the need of intermediate 3D geometry. And in addition to this technology, the temporal and spatial compression of an entangled urban landscapes enabled by the latent space develops an understanding of their interaction. And there is not one universal legend to read these maps from the latent space. It can be read on multiple different approaches. The reading from a traditional 2D map shifts to observing a 3D object. And the reader must expend substantial effort to decipher these models, which is inherent in the extensive data processing involved, albeit in a compressed form encompassing all data elements. And for example, the attentive observer will identify urban fragments, buildings, streets, grids, and so on in an X and Y layer, and how these interweave with landscape elements of a similar initial scale on another layer. A way of reading that is familiar to us, and also would also like prompt us to see other habitats from different scales, like insect habitats on similar layers required a change in scale. And this implies that we must abandon our habitual way of reading maps by means of universal indexed legends and encourage us to adopt more inclusive practices that advocate convoluting multiple readings into each other. And so far so good, but in order to further understand how machines perceive and analyze and generate our built environment, I want to invite you to a journey on learning to see like a machine. That's a text that and also a thought that I first started in this book by Ingrid and further elaborated, and I think also another speaker, Professor Vera Bühlmann, is also featured in that. But to go back to that subject, around 1915, Swiss art historian Heinrich Wölfflin famously elaborated on 5 pairs of formal concepts to classify and analyze paintings and their inherent style in his book, Principle of Art History. And almost exactly a century later, a novel form of machine learning algorithms like GANs, what we already heard about it, was invented by Ian Goodfellow, basically 100 years later. And GANs are unsupervised machine learning algorithms with the ability to learn from vast data sets and subsequently generate new depictions from a data set. When tasked to learn architecture data, the machine has no prior knowledge about architecture, nor will it gain any particular knowledge throughout the process. In fact, the machine focuses on extracting and learning essential features from a data set through a straightforward formal analysis. Based on that premise, the GANs and Wölfflin methods rely on formal analysis. This thought compares and highlights the similarities of Wölfflin's concept with the logic of how GANs analyze and generate architectural spatial compositions. We have discussed over the last few years, multiple GAN algorithms have been developed and increased in realism, fidelity, and control over the latent space and also the manifold results. And GANs are structured into 2 adversarial ML systems. One is the discriminator and one is the generator. And since Wölfflin only uses this technique as an analytical tool, we're also going to make the case how to use it as a generative tool. And so now back to this diagram, where I think it makes more sense for us being the curator, the forger, and the critic in the notion of Wölfflin. And this is also like, I think, a representative of how the data set is created, distributed, even when it's biased, it will steer and influence the output and what features the GANs and what they deem to be essential within a data set. This scheme sometimes is also described as a cat and mouse game, but again, I think, in the light of Wolflin, the curator, and the Fortran, the critic, fits a little bit better. And arguably, Wolflin worked with very small data sets or even just pairs, individual samples for his formal analysis concerning styles, but he also consciously rejects the bias of regional influences or artist-specific nuances that he refers to as an artist temperament. That in return ensures distilling the essence of contributions to a style when applying formal analysis methods. So, for example, Wolflin compares Baroque sculptor and architect Bernini with the Dutch painter Ter Borch, who both show painterly tendencies that suggest an association of style. For Wolflin, both artists superficially don't share many commonalities, primarily due to artistic temperament. But through objective and formal analysis, associations can be traced. He makes a similar case study between Michelangelo and also the early work of Hans Holbein, which initially seem distinguished by regional characteristics, but through his formal analysis share the underlying notation of the linear. So with GANs, we have vast amounts of data and samples beyond just pairs, so which I think is in our benefit. And GANs can also rely on experience initially, but build up in vast amounts of these data that is diverse and beyond just two styles that allow them to crystallize features and gain expertise on a very particular collection. And Wolflin uses his 5 pairs to analyze paintings, sculptures, and architecture, and the 5 pairs of formal concepts, namely painterly, linear, plane versus recession, closed versus open, multiplicity versus unity, and absolute versus relative. But in this concept, in this research, the first 2 concepts, linear versus painterly and plane versus recession, emerge to be the most inherent advocates for similarities in Wolflin's and GAN's formal analysis in pursuit of extracting and categorizing essential features from architectural data sets. Although obviously in architecture we could trace all 5 of them. So moving forward, Wolflin stated in an essay, learning to see is everything in the context of evaluating epochal styles. And GANs have the ability to see and analyze a data set and extract features through a series of machine vision operations. But here the question arises, do we need to learn to see like a machine when working with machine learning tools in order to understand how architecture and the built environment is perceived and generated through the lens of the machine? So therefore, this research demonstrates how machine vision processing, contemporary GANs and Wolflin share similar formal concepts. But Wolflin doesn't just state we need to learn to see, but also explains that to conduct formal analysis, we need to examine an art piece through multiple visual layers, which naively also shows tremendous familiarities how a GAN, for example, works, and a GAN analyzes data samples. And looking behind the scenes of GANs, we rely on features, visualization techniques to evaluate these results. Features in the realm of machine learning and machine vision are patterns that can be isolated and detected from a data set. Here we see, for example, features visualization of the Barcelona block through a formal analysis of linear, painterly, planar, recessional concepts. And features are extracted through this sequential formal machine vision process in visual layering, where also there's a certain level of abstraction happening in order to extract the patches and the elements. And while we can visually determine the traces of Wolflin's formal pairs in results and by looking behind the scenes of GANs, it is also crucial to quantitatively assess how machines perceive and generate our built environment. So GANs are unsupervised systems to evaluate how they perform analysis. We use unsupervised machine learning systems to evaluate and visualize them, how they extract and also transfer the features. So basically we use an ML system to evaluate the results of another ML system. And as part of this qualitative evaluation process, we look for residues and leftovers of features from the original architectural data set. More precisely, we reflect on linear, painterly, plane, and recessional features. And for example, we can see how Barcelona's block, again, clearly linear features that is filled with linear, painterly suburban houses from Los Angeles. So while there is a clear linear, painterly formal analysis between these data sets, it is also remarkable that specific features such as pools from Los Angeles are detected as the features and transferred into the Barcelona block. Or on the other hand, where Marrakech courtyard again have these recessional features of depth that push back the planar perception and suggest depth on top of linear and painterly features. And in this process of evaluating, we can create a catalog of linear elements across scale, or similar with painterly elements, a whole series of elements that emerged that serve as a blending between linear and painterly elements. Or when we use supervised machine learning algorithms to do a more in-depth and quantitative evaluation, feature visualization of the Barcelona block or the Portland and Marrakech, what we have seen earlier. And linear and painterly can be traced to a supervised machine learning process. Equally, we demonstrate also here that through ML-aided depth map analysis, also the concept of plane and recession can be extracted, trained, and generated through the lens of the machine. And here again, we are demonstrating that the concept of plane and recession, or simply depth, is an integral property of GANs. It is evident that depth is preserved from the data set and transferred also into this new hybrid composition. So, the video is not playing. Let me go back one more time. It played? Oh wait, then I think that was my fault. Let's see. Here we go. So, now going from 2D pixel to 3D models, from image data sets to 3D models, and also into point clouds, or basically from 2D pixel to 3D voxel. Oh, now it's not showing. The next, here we go. So although the image data sets are still the most dominant form of samples used in GANs and architecture, we also investigate in how to train 3D data sets instead of 2D images, and the relationship between Wilflin and how GANs evaluate these 3D data sets. Going into a more applied project, this was a commission and the first attempt to do 3D GANs for the Yanitsky family in Marina del Rey in California. And here we see a modern house 3D dataset being streamed into machine learning process. And this first attempt relied on synthetic dataset because there was literally no proper, and still to this day I don't have a proper housing dataset to do the scarcity of these models available. And once elaborating on that project, and then whatever as a structure and an outer shell the machine spit out, there are clear cutouts from the synthetic dataset that are deemed to be essential. But at the same time, also we see how other like smaller details like the railing and the louvers and the facades are coming through, which obviously have a direct relationship of the 3D data set. And Wilflin's application of his formal principles works with 2D images, but also if we try to evaluate it with 3D models to help us to evaluate the results from these 3D GANs methods. Regarding to our 3D GAN experiments, no matter if we are working with synthetic or manual data sets, which we started to do just recently, there is a linear versus a painterly negotiation between spatial elements. And it becomes evident that certain elements and features are translated very linearly, while other elements are being hybridized. And this initial process of 3D GAN was also further developed into a process that initially triggered the shift of training of 2D voxel and 2D pixel towards 3D voxels. A shift that also relies again on data diversity, the latent space, and manifold interpretations. And we use the technique of voxelizing not just the exterior shape, but also the interior sequences of building models, and that was also in the same part of the same IJect, also published there recently. And in order to investigate how machine learning hybridizes or determines linear elements in 3D GANs from the latent space and manifold interpolation, we can utilize again a supervised machine learning process with labeled 3D data sets and trace the reading of the machine of the built environment. More precisely, labeled typologies, architectural elements, and materiality, especially when we work with point clouds, allow to not just train multidimensional layers or information, but promoting this hybridization and also trace the AI's process. Okay, the video is playing also. So this leads us to conclude that clear boundaries or cutouts in the resulting 3D models follow a linear nature. There is no painterly nature in blurring or gradually blending with 3D GANs. In contrast, painterly is applied when elements and sequences are being hybridized. So changing from 2D to 3D data sets, from pixel to voxel, blurring or blending is replaced by hybridization. And to close the loop of how AI generates latent manifolds, we need to look into the concept of interpolation and how that has shifted from the first to the second digital turn. A line of thought that recently was just also presented a month ago at EKD by Ingrid and myself. And let's begin with a historical perspective. Consider the structural beams of the Sydney Opera House as an early example of linear interpolation, where beams transition continuously from a U shape to a T shape. But during the first digital turn, linear and geometric interpolations achieved remarkable advancements. And here what you see, a video on the screen. Greg Lynn's embryological house serves as a prime example, showcasing infinite variations with the same typological form. That means remaining within the same genus. So let's take the minced digits, which is often used in deep learning and which you see on the left below. Linear interpolation between two samples does not produce a minced sample, but blurry images, and the same holds true for architectural examples, or if you do a linear interpolation between building footprints like a slab and a block or a topology. So you do not receive a plausible form, and everyone who has tried this knows that you have to cheat by creating either self-intersecting geometries or generating the illusion of variant genus in the geometry. So, but when we're using manifold interpolation from the latent space, valid results occur even between different topologies. The fascination in regard to latent space lies in this compression of data points and example input data, whereby previously unobservable linkages across topologies and scales become tighter and thus visible. In other words, huge data sets are ordered and simultaneously compressed based on similarities. The emphasis here is on the plural that remains inaccessible to the human eye or cognitive abilities. It revolves around deep learning's potential for manifold interpolation across diverse building topologies of different cities and across scales, means making use of the ability of the machine to process vast amounts of data. And therefore, we're investigating about the existence of topologies invisible from human perception due to a data processing limitations. Through manifold interpolation, we have unveiled results with typological variation that are impossible to generate through the linear interpolation methods. And a walk through the latent space gives us an insight of the manifold interpolation across various topological forms and Cartesian dimensions. So the 3D GAN results proves what we already observed in the 2D urban topologies, namely manifold interpolation seamlessly transitions between topological variant topologies that wouldn't have been possible with linear interpolation from the first digital turn. And to deepen our understanding of manifold interpolation, we also again have labeled the data sets according to building types. And our approach involved labeling topologies with different color ranges, enhancing label differentiation using RGB values. And in this interpolation process, we observe a significant deviation from conventional linear interpolation. Instead, the machine orchestrates intricate transformations akin to a seamless jigsaw puzzle assembled from multiple components of a larger ambient space. So consequently, to grasp the concept of interpolation with the context of deep learning, it is imperative to comprehend the nature of latent manifold interpolation as distinct from interpolation in a physical Cartesian system. This interpolation was characterized by dithering rather than linear interpolation, serving to index the elements and their relationship within the voxel field. This is a physical model that we created also again in collaboration with Stratasys that demonstrates the hybridization of topology, spatial sequences, and also materiality utilizing 3D data sets and most importantly point clouds. For this particular example, we are leveraging the high performance and research computing facilities at A&M, where we are able to train vast amounts of data and billion data points. And the results suggest that manifold interpolation involves continuously hybridizing across topologies of various genera and scales, resulting in spatial compositions that align more closely with contemporary living and working practices. So the research emphasizes the importance of accurate and precise terminology in the field of deep learning and architecture to avoid misunderstanding and to leverage the full potential of a new techniques and applications. Thus, this research initiates the search for an adequate description around manifold interpolation And departing from the first digital turn, we resort in our research methods to concepts, to hybridizing and synthesizing until a deeper theoretical discourse around interpolation, its terminology, is established. Moreover, the study showcases the utility of manifold interpolation and GANs in uncovering latent and heteroinvisible relationships between architectural topologies, proposing an innovative hybridization using machines. So leaving the architect, as indicated earlier, as the curator of data, trying to shape and control the latent space, which holds all possible depictions of what a machine thinks architecture looks like, from these vast and messy data sets, until the introduction of diffusion models, right? A new architecture, and we're all aware about it, and I don't want to spend too much time on it, but we're all aware about a new architecture of AI tools that resorts from the latent space and latent manifold interpolations, but omits the architect as data curator, based on the data set it was trained on. So we see a shift from data curation to prompt engineering, where models are trained on famously on the Latent data sets and billions of images, annotated images from the internet, where we potentially all have contributed to it very generously, but are also mostly reflected by popular culture. And I'm just going to zap through these real quick. These are some examples of an exhibition that was invited at UT Austin that was called Architecture After AI. And I asked the same questions about a modern LA house as I did in the 3D GAN or Yamitski house. Just in this exploration, it is triggered by text prompts that describe or ask for modern houses in Los Angeles. And there are forms like imagine a modern house in Los Angeles with columns, ornate, mycelium, white color, plaster, or brutalist architecture, modern Los Angeles house, just a series of keywords, or even a modern house in LA aggregated from wood joints, or a modern brutalist house, decay, irregular, and so forth. But in a more depth investigation on how latent manifolds are generated is carried out, is examined in the project Diffuse Countryside. This is a project that was funded by the Academy of Visual and Performing Arts at Texas A&M with the intent to promote the arts in the Brazos Valley. Therefore, we ask the question, how are rural settings or vital and urban interfaces represented in pre-trained diffusion models, and how can we again extract these latent manifolds? And this, what you see here right now is that we made a survey of buildings and infrastructures in College Station, Bryan, where Texas A&M is. And these surveys serve as a building stock and housing for our case studies, starting to point and trigger these diffusion models. And demanding from the AI system to imagine these colonial, industrial, and southern housing stocks to be imagined in the fashion of contemporary style. So the project critically investigates the issue around data justice and also bias when developing diffusion models to generate architecture and its elements, and resulting in a composition of known and unforeseen latent manifolds, leaving us with deciphering traces that might derive from the data set and the model was pre-trained on. So yet we see the unfamiliarity that is forced onto the original input case study, that is an indication of the underrepresentation also of wildland and urban interfaces compared to influences from popular culture and governing canons. And in almost an archaeological process, I disseminated these realities in the latest issue of UCLA's Pulse magazine, where I search to uncover the traces from the latent space that made up its multidimensional, constantly oscillating and also permanently changing state. It compares an AI model that are created by the architect and pre-trained models that are not created, but rather an agglomeration of digital footprints. So resulting in a search for traces, digital footprints, smears, and the DNA of data revealing that only the ones with the biggest digital footprint are considered while the others are left behind. And so to end up this journey, maybe we need to lean on Carpo once again. GANs and other AI tools basically start a formal search in a data set to extract these essence of architectural precedents and suggest novel depictions of manifold realities from a data set. This can be also compared with the concept that Mario Carpo iterates in his chapter, Search Don't Sort, which originally comes also from Google, where corporate explains that there is no need to sort data or information through novel algorithms such as Google or Gmail searches. Instead, we can just task an algorithm to search and suggest what we are looking for. And by now, knowing that there are also machine learning algorithms behind these search processes, GANs and ML-based searches or any AI process suggests their manifold solution based on the machine interpretation and knowledge they have harvested from data and stored in the latent space. And what that offers is a latent space, what that offers is a latent manifold series of realities where each representation has its own justification, inhabiting the essence of diverse data samples, yet speculating on non-binary intersecting hybridizations. Thank you.
All right, as you know, he's not off the hot seat yet, but the observant ones in the audience will have noticed that the optimal strategy is to drag out your talk so there's no time for questions afterwards. But
we have half an hour, so go on.
Okay, so.
What was your last word? And really like the phrase non-binary intersecting.
The last word I will read from my notes. That's why I like notes. And what that offers is a latent manifold series of realities where each representation has its own justification, inhabiting the essence of diverse data samples, yet speculating on non-binary intersecting hybridizations.
Well, sorry, I just
Yeah.
say why I asked that.
Yes.
I think there's connections with my own thinking on binary architecture from a transcendent perspective.
Great.
And I think that the image that you showed at the end, if we look at them from a trans theory lens,
Right.
there's a lot that can be generated there.
Thank you.
Yes, thank you. One thing that I was intrigued about was how in your work you increasingly kind of cultivate this ever larger manifold, and
Right.
you explore the latent space of it. And I was wondering, would that be, I was trying to step back and imagine kind of what would the brief be of an architectural project that would try to work this way with this or these manifolds. And I'm wondering, do you see the architectural project as something which lives in an ever richer, in the latent space of an ever richer manifold? And is the human, if we were to say there's kind of a moment, I forget the names you had, the discriminator,
the generator,
the
yes,
generator
yeah.
and the curator, is that where the articulation of the architect is occurring? And what happens when, because then you've built kind of you've built your latent space, or you've constituted it, and then you would be articulating a building project on top of that. How do you see that relationship?
I think that's a very interesting question, and I would say in an ideal world, this latent space, this training just keeps going on and going on, and we just feed more data in it, right? And yes, the understanding of an AI, no matter if it's 3D data, 2D data, empirical data, whatever data you just feed in, right? It happens between, at GANs at least, at this interplay, at this cat and mouse game, or the game between the forger and the critique, in between these two adversarial networks, right? So they somehow build each other up and then also try to give feedback. So what do we have you learned? What new came into the picture and what is most essential? Technically speaking, there are some issues to that, something called like overfitting and underfitting, where you cannot endlessly train, right? But if we leave that behind, and I think your question is more about the conceptual agenda, I feel like we as architects can assume the role of just like making sure that we collect the data and I tackle a project, let's say an urban project or a housing project or a building project, that I think is going to be essential or important in order to trigger these kind of like manifold outputs, right? So to your question, what the role of the architect is, I think it's very clearly curating the data set, depending on which tool you're working with. Obviously, what I try to point out as a small critique, but not about diffusion models itself, but whatever they are trained on, you go into prompt engineering, but you can try to engineer as hard as you want. There are certain moments when College Station Bryan, most of you have never heard of, but that's where Texas A&M is situated, is not on the map because our digital footprint is not great, right? While Los Angeles, oh, it's fantastic. The palm trees are coming up, right? The neon signs, because it also goes after data sets like Zillow, right? Or real estate. So I don't know if this answered your question, but I think it's about creating the data and being as responsible as possible, you know. And I just don't want to advocate solely in my research about data justice and whatsoever, but I also have learned from the very early start that by controlling the data, I can also get what I want as an architect, right? Because I also want to go for certain formal features. I also want to go towards a certain aesthetic. And I think that also goes a little bit back to what was asked earlier to Igor. I don't know where he is. He's over there. Like, who made the decision in that? As a designer, I still want to have a certain say in what the aesthetic output is, right? So I also try to bias it purposefully a little bit, and that I get what I want from that machines, which is not always the case, right? Obviously, I think diffuse countryside also showed, like, do I really want that? Is that really the future of housing in rural Texas? I don't think so, but that's what the diffusion model thought it might be. I don't know if this answers your question, sorry.
Obviously, the way that the models are trained are aesthetically based. And that was a choice you made in the data sets. Is that the most necessary in the current world? Should we be looking at other data sets? And when you have a voxel, which is capable of dealing with a lot more data types than a two-dimensional pixel, should we be going in another direction? And is that a future for your own research now that you've developed these diagrams for a human-machine interface?
Very good question. Yes, I think, you know, in the early examples, and which were literally one of the first ones where there was an attempt between Barcelona and Marrakesh, or Barcelona and LA, that started beyond an interest in formal features. That was literally curiosity. How can I cross-pollinate these two very different urban fabrics, and what would be a result of that? Like, how could Barcelona be cut down and have these deep courtyards that are coming from Marrakesh, or at the same time, how could a Barcelona block emerge in a different topology, urban topology, in a sense of, like, not this density, but LA suburban, would say, quad. So there was a non-formal approach towards it, but obviously I also like the outputs to agree with. And you're absolutely right. There's so much more information we can label on it. And I didn't talk about it, but that's also the potential of remote sensing technology. Because what we see as RGB is just the tip of the iceberg of information that a satellite gets from each pixel. And the same is from with voxels, right? So we are starting now to train point clouds. And that's why we need to use the high-performance research computing resource at A&M, where we can train not just their location, not just their vicinity, but also way more information that we get from a LiDAR scanner, like color, brightness, and so forth. So yes, I think this is just a foundational start, and we're working on just, like, deepening it way more. That goes literally also in, I would say, what we start to tackle with Convoluted City into material ecologies, but also seeing, like, how function and architectural elements could work towards, like, a different materiality, and what is actually the reality from where we are drawing it. Yeah. But I think this is the next hot topic. Yeah.
So does that result in improved human environments, for example, right? I mean,
that's what I hope so. But you know, I think the problem is sometimes even simpler. I would train this model, and then the first step, I think the first challenge we have is to just understand how does the machine even train it. And then once we have figured that out, then the applications are, again, manifold or widespread. But I completely share that trajectory, that I think that is the future, you know, of all this research. Thank you.
So thank you, Benjamin. I really enjoyed it, and I really, it's a kind of formal exploration. I find it very successful. What are you achieving? And I'm seeing some new things that I haven't seen before. But I have a provocative question just to spark the discussion a little bit. So my question is, like, you know, like we have number systems, we have natural numbers, rational numbers, real numbers. But to come from rational numbers to complex numbers, you cannot interpolate to get there. So you can try interpolating whatever you want. You will never going to get complex number. Complex number is not a process this kind of model could somehow learn from data. Because all data has not been, it has been described with a different structure in mind.
Right.
So my question in terms of that, so to invent complex numbers and then the whole science of the 21st century, we need to have invention. We have to step out of what we know and create something radically new. My question is, can this thinking be passed to architecture? Is there still a role for invention in architecture rather than interpolation? Is there something there to be invented to put on the table as not seen before? And how can we even formulate that? What comes to mind is Corbusier, which I'm not saying I'm a fan, but I'm saying that Corbusier, when he created those forms, they were novel. But they were also, he created a man. He imagined a man to live in them. And he imagined a building technology to build it. So, so in that sense, can you?
I think a very, very important question, and thanks for asking. To me personally, I think what we had talked earlier a little bit, like going away from binary descriptions of what an architectural element, an actual architectural function, or even materiality needs to be, seems to me very contemporary and very, very important to tackle. Does that yield to the groundbreaking new innovation within the field of architecture? I don't know. I can't predict. But there is a fascination for me that all of a sudden I can interpret data very differently with these AI tools than I was able before. But by me saying that doesn't mean that these systems are incredibly smart. At the end of the day, they're actually not that smart as we like to explain them. They can execute like very, very simple tasks. But yet, having this formation of human-machine collaboration, I feel like something new can be sparked, right? I mean, to go back to Corbusier, or I mean, he's not the only one, the first one. Also, the time he lived in and innovation in technology and whatsoever also formulated or were a vehicle for his concepts and architecture. And I feel like tackling maybe aesthetic forms of AI, or even just the idea of grasping larger amounts of data we were able to do before, or being aware about much larger issues like climate change and injustice, right, in this world. And being able to train that could potentially then yield towards something new. And I mean, I'm a strong advocate of changing the medium or changing the lens you look at it, or changing your point of view you look at a problem. Usually is not a bad idea. You can't lose, right? Because you already have the views that you're biased in. So engaging with these tools and trying to get a different filter on top of it might yield to it, but I don't know. But I appreciate the question, because I think we should ask ourselves that every day. Why do we use that, right?
I'm not suggesting that I have a solution.
I know. I appreciate the question, because we should talk about it. Yeah, thank you. Connor.
My question is about your last statement with Mario Carpo's quote about search and sort. And I was thinking that maybe there is an extra layer on that maybe architecture is not only about search, but about imagination. And I think that relates a lot with what Nicola was saying. What will be architecture if we are now in this very powerful momentum where we see that these data-driven approaches are, like there, and we can leverage that. So when you think about imagination in architecture, and then you go back to your latent space,
right?
All of your work is beautiful and fascinating because you're imagining what this latent space could become. Now that you have really kind of synthesized maximum your data set that you created, then your latent space becomes this creative ground where you're imagining what can be. So I think I was just trying to feel how you will think about my way of interpreting your work, if this is what you're doing when you're thinking about this latent space and imagination and data curation.
Uh-huh. Also, very good question. I don't know if I have a very clear answer to that. I mean, I always like put out, I usually very often end with that Mario Carper slide because it is controversial, sometimes a little bit outdated, but at least I like the idea of searching, right? And just to be very clear, whatever we see here, again, it comes back that the AI is not as smart as we might think it is, but we always need to collaborate with these systems, right? And by collaborating, no matter if I write a text prompt, if I create the data, if I bias it a little bit to be beautiful or formal or not so formal, I have certain agency towards this imagination. So yes, and I think it's very clear. I played it with my students. I let them use diffusion models. The first day they go into that game, if they don't have their own image in head or their own trajectory or agenda they want to get, they get no useful results from any diffusion models, GAN, whatsoever, right? So yes, it needs the human first who has a trajectory and agenda to go into this game when you create data, when you engineer prompts, which also yields us, to something which is great. And I know nobody here is afraid that AI takes our job, but it won't, right? Because I need to go in there and ask the right questions. And I don't know if this answers your question, but I think the imagination starts with the architect or the designer who tries to collaborate with these tools.
I know Adil is there, but I know Adil, we know that you're there, and you're gonna be next. I'm just thinking, this is very interesting work, and that's why I'm so excited asking questions about this.
I appreciate it.
I don't really think the machines are not smart. I actually think that they are smart, and what we've seen now with all of these generative algorithms is that they become this common sense. They really know. And I think this is something that we need to leverage. We don't have to treat them like slaves. They just create results. We have to engage in what you're saying, right? They should become agents or active agents that are really contributing. So if you already tell them you're not smart, then you're just putting them in a very, very, not an interesting ground to play with them. That's what I wanted to say.
And I want to answer that. I completely agree with you. They're not. I didn't say they are dumb, right? I said they're not as smart. And when you think back at the slide I showed twice about what the role of the curator, think about. I wrote the machine entity, right? I see them as valid and eye-to-eye level collaborator in this process. So I just don't think that they can right now do a project without us, right? But I think we both are completely at the same on the same board. Cool, thank you.
All right, Adil. Adil, go ahead.
Can I go ahead?
Hello.
Yes.
Yeah. Fantastic. Thanks a lot, Benjamin. Fantastic stuff. I'm curious. So my question is related to noise. Like, what's your angle on that? Because, for example, with these latent diffusion games, so like as an example, just to think of there was a Pokemon GAN that was pretty popular when it came out. And then now if you Google Pokemon, you get 1 billion Pokemon, you get Pikachu, you get this, that, etc. And then you get hundreds of latent ones as well.
Mm-hmm.
But then I'm wondering, but still Pikachu has a presence. Pikachu has a legacy. Pikachu has an indexicality to the multiple stories and the amount of times it has appeared on screens. People have a relationship to them. And then to kind of relate that to this idea of the hybrid, I'm curious about that because I would think that a hybrid would be something that keeps paradoxes alive. So you would be able to identify certain sensibilities of the things that it is comprising of.
Right.
Then when we go to the latent space, things get blurry, things get dissolvable. I'm wondering with these very beautiful, colorful models that you have, what would be an angle of indexicality in them? Would it be possible to kind of trace a legacy from them? What would it take to make them a thing rather than a blend?
Mm-hmm.
You know what I mean?
I think you know what I know what you're talking about. I'm not 100% sure about the Pikachu example, but I know of Pikachu, and I'm not the most knowledgeable about that. But what I think is important to point out, and what you mentioned, like, you know, at the first Pokégon, that it was not quite there, and the results like were lacking fidelity, but it was a good start. Once we're in this latent space, right, and once we are extracting, I would say, a certain state or a walk to this latent space, like shown in Convoluted City, we need to rethink how we read it, and I think we both agree on that. How we specifically would make an indexed legend, right? I don't even know if that is even possible, right? Because Convoluted City, if we see it as a different cartography of all different kind of like maps and satellite imageries that we lay on top of it, how would we be able to make even a legend of that? Because if I take a different latent walk, the legend might be a completely different. So I potentially resort to Carla, and we might rely and just accept, for now at least, that the machine does its job right and that everybody is represented properly. Another angle to it is certain GANs do not just equalize data, but they also learn high-level and low-level features, right? Especially all the style GAN, not the style transfer, but the style GAN that I show with the faces and that we also use for these latent walks, where compared to a face or to a building, the shape, the overall composition, the outline of these data sets are kept very precisely. But then small nuances, like if I'm smiling, if a building is brick, if a building is concrete, these are then other like types of high-level features which can then be sampled or directly be called out. So I would say the best way to do this, or creating the legend or an indexical kind of like approach towards this, is to use, again, another AI system that tells me what kind of features are most prominent, or a kind of like a way to call specific, like a smiling or a brick building with more control. We haven't achieved that yet, to be honest, but I could see a lot of very interesting and also useful applications in terms of research also of that. I don't know if this answered your question, but that's what I can.
Offer an answer?
Please, yes.
If you go to Deleuze and Guattari, the definition of a diagram is that it doesn't contain anything that exists before.
Right.
So it only contains what can be drawn out of it, in other words, and it's not a thing, it's an operational existence. And so if you take these as being somewhere not quite indexed like a Pikachu, but also, and maybe the point is not to index them at all, but to actually engage interpretation. So I think the next steps in your diagram might be to go beyond an output and
right.
into a second phase of curatorial or interpretational, not linguistic, it's meta-linguistic, actually, with that as source material. I think you need AI, like you were just suggesting, to pull seeds out of that. In other words, our ability to see the thing is limited to a moment in time. We can turn it, we can move it around, we can try to probe it. Ultimately, it's how we sense the thing that gives us the information we need to take it a step further. But I think that's really where these lie.
I love that we should talk. Thank you. There's one more question over there.
So I wanted to thank you for the presentation. It was really, really informative. But I have a question on if there's some sort of sustainable approach that can be adapted into the technology. Like if it's adapted into the technology, how would that affect the outcome? Would the outcome still be as beautiful and as kind of abstract as it is, or will it start to simplify the outcome a bit more? How do you think that?
Very good question. I think it goes a little bit what we already talked about. If it's going to be as beautiful, I don't know, but that's not the important point. But we certainly can, for example, Convoluted City, at least start with an idea of like, we the place we live in is not always the place where we draw our wealth or draw, generate our waste landscapes and whatsoever. So incorporating more sustainable, and I mean, I would rather say resilient ideas towards feeding the data, definitely would be fantastic. I mean, even in the early attempts, right? Let's imagine Barcelona gets like 10 degrees hotter, which it won't, right? But how can we retrofit the Barcelona block in the fashion of with Marrakesh courtyards to make a more resilient urban infrastructure, right? Yes, I think we can. I haven't talked much about that, but I'm aware, and I think we need to do that. Yeah, beyond just making everything beautiful. I didn't consider to come across like a formalist, but maybe it's because I showed Wolfland. But I appreciate it. I think you're right. It's very important. Thank you. Yeah.
I had a question regarding when you're talking about designer and prompt engineer, and I don't know if you already started talking about this, but when you create the 3D GAN models, how much integration do those geometries have with, say, like other 3D modeling softwares?
Very good question. So the very first one where I tried this 3D GAN process, like the house Yamnitsky, when you see all the furniture and the mullions and stuff, the GAN didn't give me that. What the GAN gave me was the rough outer and interior shell, because that's all I was able to train it, right? I was also not able to train much of materiality, much of segmentation of architectural elements. Later on, we're just getting better and better, where we can feed more underlaying and nested multidimensional information per voxel, which potentially will yield to also an increased fidelity. We are by far not close to any fidelity what diffusion models have in terms of like realism and output, but that's also not really the goal for now, because my critique also not critique, but I think that there is a discussion around diffusion models, which is the exact same scenario of what I showed from 2017 at UCLA using style transfer. At the end of the day, you need to sit down and you need to model it by hand, okay? So if we take that into a practical application, because Midjourney right now in widespread, also in Texas, local office, 3-people office, they use Midjourney to show these outputs to their clients immediately, right? The problem is when they say, I want that. We haven't jumped the loop of like taking away the laborer's process.
That's where Igor comes in.
Right? Exactly. Figuring that out, right? The thing about convoluted city, why I'm mostly excited about that project is that latent data goes directly into physical matter. There is no 3D modeling in between, right? And I think that's also one of the other holy grails. If we can achieve that, we're gonna be billionaires, or we're gonna have a very nice life as architects. I don't know. Does that answer your question? Sorry. Yeah. Thank you for asking.
Can I just jump in very
Yes,
quickly?
please.
So you said, okay, they have an office and they use Midjourney. They say, okay, I want that. My question is, what is that they want? Is it a product? Because a product usually, to be a product, to be a successful product, you have to sell that. You have to market it. You have to go through an incredible amount of steps of trying to convince people to buy something. Or you need to say what it is. What does it relate to? What does it bring to you? And when I look at the output of Midjourney, it's nice, but it's mute. It doesn't talk anything. It doesn't suggest anything. It just looks. So how do we go about that?
I completely agree, but I think it also comes back to depends on your client, right? If I just want to have I would say off-the-shelf house in rural Texas or wherever, and if you show me that image, or you show me the image of my neighbor, I equally tell you I want that. Maybe not my neighbor because that looks suspicious, right? But 3 blocks down, I will take the exact same building. You know what I mean? Again, it depends where your client is in a specific example, but also it goes down to what can we even generate with these models when they are only trained on popular culture, right? Because Obviously, if you ask for in the style of Frank Gehry or Zaha Hadid, you will get very close results. If you ask in the style of Benjamin Adamos, you get crap because I'm just not famous, right? Because I'm not represented in there. So it again comes back to bias, right? Like, what do you want to sell with these images? I don't know if this answers the question, but yeah, but I think, you know, I think we should also think about that. Yeah, thank you.
Does this also speak to for the importance of metadata on images? So I'm actually trying to think, because I'm not working in this area, I'm a historian primarily, so I'm trying to think about, do we have to ask our students to, when they post images of buildings or kind of cultural landscapes, to embed them with some historical data that then can be used by machine to produce things? There is, the Society of Architectural Historians has the Archipedia, which is an encyclopedia of historical architecture and comes all the way to the present. But I actually don't know if the images are usable, or if that's an archive that can be used for something that has more historical depth as well, or meaning.
Right, I think I agree, and the funny thing would be if we all would do that, we could bias the system towards a better or worse way, but yes, if you want to know what these diffusion models are mostly trained on, or at least for the biggest time of their existence, which is not that long, the way that we are using in Midjourney, just go online, go to Lion dataset, L-A-I-O-N, and then look for cats, look for architecture, and it will spit you out all the labeled metadata and images that it's trained on. It also gives you a very good understanding why certain keywords work so much better, right, than others, or why we as architects sometimes need to resort outside of our I would say comfort zone in terms of terminologies and borrow from other disciplines to get what we want. Like I remember, like in the first couple of versions of Midjourney, V1, V2, in order to get something, I would say, that I formally think is more appealing or pleasing, you always had to use mycelium, right? Because it was trained on tons of my images of fungi and mycelium, and then it made you some more curvilinear, right, structures. That also has changed, right? I mean, as far as I know, generating or asking for architectural plans is still horrible. I haven't tried it since a couple of months, but I still think Midjourney is still really bad. And it looks like a plan, but it doesn't make sense at all. But it might have changed in the last 2 months.
Okay, I think.
Thank you. Oh.
All right, I think we've grilled him enough. Thank you all for this great discussion. I think all three presentations kind of link to these topics that we're talking about, both in terms of data, even search, sort, interpolation, all these kind of really topical questions that I think the conference is meant to really interrogate and ask about. I think we'll continue these conversations informally over lunch, and we will re-adjourn and restart the afternoon sessions at 2:30. Is that right? 2:30, right? Thank you very much.
Lunch is over here, so you don't have to go anywhere. Lunch is here, and then you can just wander around. There are a lot of nice places that you can sit and have lunch.
Okay, I still have, sorry, there's something that's not looking good. But Adil is going to give a bit of a speech, no?
I'm just going to introduce this session.
Ah, okay, Adil is not doing it?
Yeah, no, I'm just saying.
Okay.
Here's Adam.
Okay, just give me 1 second.
Hello? Hello?
Everybody can listen to you.
Okay. I can probably only start in 5 minutes, something like this. I'm not sure if that's enough for you to fill.
No, we wait, we wait. So we continue the afternoon session, and we welcome Adil Bokhari, who will be moderating today's afternoon session.
Hello, I hope you can hear me well. I'm Adil Bokhari. I'm a PhD candidate at the chair of digital architectonics at ETH Zurich and a tutor for the architecture design studio of the chair Studio Meteora. I'm happy to introduce the theme and talks in the panel. So we have the first panelist already on stage, but I will continue with the theme. So it's titled Sculpting Images, Engendering a Geometry in the Free-Form, Free-Structure Condition. This particular panel will discuss ways of articulating projects, specifically architectural projects in the realm of contemporary, artificially intelligent imaging technologies. Sculpted faces that can begin to converse without being exhausted by their constitutive technologies, bodies of knowledge that can begin to travel without being reduced into singular systems, mechanical constellations that can begin to move without being caged into definitions. In this context, I would just like to throw out a couple of questions to set the stage. How can disparate images that are simultaneously simulated, generated, sensed, and documented can be brought into a composure? How can the myriad analog and digital technologies that shape architectural renderings and drawings be hosted in a new scale of geometry beyond representations and illustrations? How can an instrumentality be fabricated beyond the realm of the purely visible and the sensible? So with these questions, I would like to introduce our first panelist, Agostino Nickel. I think, Agostino, you can come up on stage if you can. Yeah, Agostino Nickel is a doctoral fellow at the Institute of Technology and Architecture at ETH Zurich. He received the Architecture and Technology Doctoral Fellowship in 2021 at the Chair of Digital Architectonics Research Group, supervised by Professor Ludger Hovestad and Professor Vera Buhlmann, who will be joining us tomorrow as well. Before joining ETH, he worked at Arup Studio in London in an interdisciplinary design innovation team and taught architectural design at the Oxford School of Architecture and Landscape Design. He also taught video game urbanism theory at the Bartlett School of Architecture, UCL, where he received his master's degree under Professor Laura Allen and Professor Mark Smout in Unit 11, where his work was awarded the Sir Bannister Fletcher Medal, the Bartlett School of Architecture Medal, and the Saint-Gobain Innovation Prize. I think he got all the prizes there. Agostino's talk is titled Questing the Open Expanse, Exploring the Unworded Vectorial World of Large Language Corpora. Take it away. Thank you.
Yeah, thank you, Adil, for introducing me. I did not get all the prizes. Yeah, it's my pleasure to speak today about a topic which is very close to my heart, it's very close to my PhD, and it's about the idea of the quest, the architectonic quest. And I need to connect my computer to the screen for you to see something. Ah, thank you. That's it.
From the bottom, from the bottom.
Don't worry. Oh, you're mirroring. That's more like it. And what I'm going to try to do in my research and what I'm going to share with you today is to think about how bridges can be built between architectural research and artificial intelligence. And as all of us today, I'm excited about playing models because I think that these are the very models that play up and make up our world. So the very chair that you are sitting on right now exists not only as this like mass-produced technical object in this room, but it's also as a digital object in the web. So here I found it on Kid Superstore online, and you can download it from there. And so this is not really news for anyone who has ever been tasked with designing a building. Things that we find online or in our building information systems, they become things that we select and fabricate, and then from this kind of sheer multiplicity of technically fabricated objects, then there's still the moment where somebody goes on site and makes them to fit a very specific location in a very specific place. And I think that this translation, because between the technical and the digital, and are things that don't only work one way. They kind of affect the source domain where they're coming from. And I think that this becomes ever more pressing because the so-called digital world became a whole more interesting over the last couple of years, more vibrant and more alive than we could have ever imagined only a decade ago. In the 1960s, the philosopher Gilbert Simondon invited us to think how technical objects reticulate our world anew. He writes, techniques return to the world to ally itself with it. A new reticulation establishes itself, chosen by techniques privileging certain places of the world in a synergetic alliance of technical schemas and natural powers. The mediation between man and the world becomes itself a world, the structure of the world. Now the more contemporary philosopher Yukui invites us to think about how digital objects do that too. For example, through relational databases, which we can query with SQL language, which is a structured query language. And this would look something like this. Oh, I have an issue. Sorry. Certain things don't work. I think because I am presenting from a notebook, so if things are not loaded into memory, then the presentation does not work. So I'm afraid that I need to take 5 minutes to make sure that everything is working before I can continue with my talk. I'm very sorry about this.
No worries, of course. Take your time, you can go over here.
In the meantime, Adil will do an interpretive dance for us.
And Lee Su will sing a song.
We can talk about what playing models is in the meantime. So playing models is a symposium that we've been organizing already for the second year. The first year happened in June 2022 in Orlando. That's what I want to say. So the first round was in Orlando, and we also had about 12 speakers. We're getting funding so we can run this event for the next 4 years. The idea of this project is that we will be ending up with a book about all the different experiences that every researcher, architect, theorist, musician, artist, designer has to say about AI, architecture and storytelling. So this is the second year, and as you've seen here in the gallery, we are running some images from the last year event. And also what we did last year is that we made a publication of the talks that happened and some ideas of workshops that exist after Playing Models 2022. So we welcome you to join this event and in the coming years, because at the end, this is going to be a collaborative effort into talking about AI, architecture, and storytelling. And thank you. Yes, so I will talk about as well the people that made this event happen. So we had Professor Lee Su Huang. He's a professor at the University of Florida. His research focus is on computational design and digital fabrication. He was at my research committee, so I'm really glad that we get to collaborate together. We have Professor Nikola Marincic. He finished his doctorate at ETH Zurich. We've been together all my academic life, which is 6 years. So I really have a deep respect and care and love for him. So I'm really glad that he's at UF. We have Adil Bukhari. We also joined, we got to know each other from ETH Zurich. He is now about to finish his PhD, but we started this journey together, and he and Lee Su, we did the last year Playing Models 2022. As well, I want to thank all the logistic team that has been behind all of these organizations. So we have Janelle Jack White. She's been here for the foods and today and tomorrow. She helped us book the house. So all the guests should thank Janelle. We have Yassine Delabar, a PhD student at the Shell Lab. He's behind cameras and busy, and it's been helping transport you around. So also big thank for him. Movina Nourani, she also is a PhD student. She's been helping us with the microphone. And we have Jimmy Wei Chun Chen, or Jimmy Wei Chun Cheng. He plays around with these names, and so we're very thankful. He's the DJ of the 2 days. And so now, are we ready? All right, so we're ready. I stop.
Okay, thank you again. Peter is again with me. It turns out there's only so much we can ask from from our computers, especially in a performative environment like here. But we stopped with Simondon, and now you can actually see the quote. Now, the temporary philosopher Yukui, he builds a lot on Simondon in particular, and then takes this a bit further and think about what does that mean for the digital age. As we have relational databases like SQL, which I tried to show, where we can start making models, queries in structured language. But today, I think that the digital world is more than the renders that we can see on our screens, and it's more than the kind of things that we can see in mixed reality headsets. The world is newly reticulated not only through technical and digital objects, but through a very special kind of digital object, which I like to call the vectorial object. And it would look something like this when we apply the clip model, which is, for example, behind DALL-E and behind Stable Diffusion, to the chair that we are looking at. And so clearly, this indexes a space that is hyperdimensional and that lies well beyond what we could normally visualize or simply query. And there's not even a question that we can ask because there's not a structured language in which we could ask that question. And yet this vectorial mode of existence, I think, affects every single digital query that we do. So how do we make sense of this digital reticulation and the vectorial reticulation of the world? And there's this very beautiful quote by Simone Weil, writing, "I have no way of satisfying myself about questions concerning the world, because, such as what this piece of paper is. Therefore, I must invent a new kind of analysis unknown to logicians, an analysis that is the source of an orderly progression. But isn't that absurd? What could such a progression be based on? It must be based on the world." So we could say with this, we thus observe in the world is firstly our method of questing it. And so today I want to present an attempt at what such an orderly progression might look like. Because that which cannot be queried might allow for being quested. And where the structured query knows its way, the quest does not, but there the method and the path needs to be actively found or invented. And so if we want to learn about this new vectorial reticulation, then we need to go on a quest. But how to think of such a quest? How could we use code in such a quest? And when does such a quest become epic? So of course we know of the epic quests in antiquity. So for example, the Gilgamesh epos, Homer's Odyssey, Virgil's Aeneid. And then of course today we know about quests from epic science fiction movies or from video games, where the player follows missions or quests, or as well from fantasy novels such as The Never-Ending Story. Both the query as well as the quest harbor the Latin term querere, to seek, to search. But as Heidegger tells us, etymology can only go so far. So there is a way of approaching this slightly obliquely, and that's where like a small serendipitous encounter came handy, which is about a year ago. I bought this smoker pot, and it's actually quite bad. So like the coffee that it makes always tastes incredibly bitter, and like I left it on the shelf since then. I bought another one. But on the packaging, it has this very beautiful quote by its designer, Aldo Rossi. And it goes, if I translate from Italian, "In life, as much as in architecture, if we search for a thing, we do not search only for that thing." With this, I think that we can start thinking of the quest as something that cannot help to exceed the thing that is in question. So how might this look like today? Questions, it's kind of obvious, but actually it's striking to think about it. Questions only really exist in language, writes the philosopher Werner Hamacher. But also, if there is such a thing as a vectorial world, there's no getting around language properly. So today, the most transformative neural nets are transformers that work with large language. And maybe we shouldn't be surprised. Natural language processing is the field that allowed large language models to come about. Processing natural language allowed not only these models to become intelligent, like as reading in between lines of text, but also they allowed to become foundation models that we can use for all sorts of different applications. And here's a remarkable video of how Ilya Sutskever, who is the CTO of OpenAI, speaks about how AI learns to see through text. Let's see if this works in terms of the sound.
Things are much easier.
Not that great, but I can just make it on full.
Learn from images and diagrams and so on. But I claim that you can still learn them from text only, just more slowly. And I'll give you an example. Consider the notion of color. Surely one cannot learn the notion of color from text only. And yet, when you look at the embeddings, I need to make a small detour to explain the concept of an embedding.
Yeah.
Every neural network represents words, sentences, concepts through representations, embeddings, high-dimensional vectors. And one thing that we can do is that we can look at those high-dimensional vectors and we can look at what's similar to what. How does the network see this concept or that concept? And so we can look at the embeddings of colors. And embeddings of colors happen to be exactly right. You know, it knows that purple is more similar to blue than to red, and it knows that purple is less similar to red than orange is. It knows all those things just from text. How can that be?
Yeah, this I think was very striking the first time I saw it, because it's incredible how language allows for these very complex relationships to come through, even though you might think that they might only be internalized by looking at a multimodal training approach. But if we take all of these things seriously, then the brief just became way more complicated, because our quest is vectorial as much as linguistic. It must not only quest language, but also question language itself, to not get into a mode where language becomes a totalizing reality, or, to quote the feminist philosopher Luz Irigaray, giving into an unforgiving system in which everything is snared in sameness. So rather than using language as a means to technocratically dwell in the world, Luz Irigaray invites us to quest a different kind of place. She writes of the open expanse, to make sense of how this expanse might unfold indefinitely, gathering all things together, relating them one to another and each to each as if nothing were happening. And this applies to our quest too. If we trust in this assumption that AI and large language models in particular reticulate our world anew, and if this reticulation arises between things that are mathematically encoded and then modeled in language, then this cannot be quested in language alone. And Irigaray finishes her book by introducing only one character who seems somewhat successful in approaching this open expanse. And this is a venturing poet. Alone, ever alone, the poet runs the risk of moving out beyond the world, and from there of inverting the open until the ground of the groundless is reached, saying yes to that which calls him beyond the horizon. He can trust in no heaven, no earth, no mouth speaks his pathway. He thus must leave the world, remaining all the while mortal, holding nothing back, giving themselves up to the measureless open. So we can try taking the lead from Irigaray's venturing poet. However, he is quite an elusive figure, and the book ends quite soon after these sentences are written. So we must take cues from other venturing poets. And there's one epic poem in particular that seems to be quite close to Irigaray's venture in the open expanse. And it concerns a venturing poet who embarked on a venture about 700 years ago. This poet visited an abyss and the clouds, staying all the while mortal, and versing his quest into versicles. And this is Dante, the poet pilgrim, and his Divine Comedy. In its both mathematical and literary abstractness, the Divine Comedy might help us as a model to think of what such a quest might look like today. It follows a striking mathematical model that actually, and this is GBT's attempt at modeling it, which is not quite right, but but still not bad to kind of like show how it works at a very high level. Where like Dante would kind of go down the spiraling descent to hell, where then at the very bottom you would find the devil himself. Then the whole thing kind of inverts and becomes a hill to climb, which is purgatory, and then as purgatory ends, he's being picked up by Beatrix and then flies through the heavens. So let's look at these central elements of this epic a bit closer. So first, we have this very precise mathematical topography that we are dealing with. Then this contains, well ordered, all the things to learn, which are in this sense, or in this story, conveyed by souls. Third, we have Dante, the poet pilgrim. And because the quest is quite a scary endeavor, there are fourthly guides like Virgil and Beatrix who take care of him as time unfolds. But there are, of course, also very obvious differences to what Dante is doing and what we might be doing. Dante looks at the afterworld, while we are trying to quest the vectorial world that surrounds us as we speak today. Dante is mainly concerned with human souls, while we are looking at the digital and vectorial objects that surround us today. So let's think about how these elements could work for our quest. The hero is, of course, intrinsically linked to the idea of the quest. And here especially Campbell's hero journey comes to mind. But musing on some notes by Virginia Woolf that equate heroism to a disease that one gets from eating rotten sausages, which is botulism, Le Guin writes, "We are told that a heroic stories shall be like a spear, hit a point and require a hero. But this hero has a real problem, because after Irigaray, the hero is so shut up inside himself that to attain anything from outside is a very difficult task." And so next to the botulism equation, Virginia Woolf writes, a hero is also a bottle. And Le Guin then picks this up and then continues this and writes, "I propose the bottle as a hero. Not just the bottle of gin or wine, but bottle in its older sense, of a container in general, a thing that holds something else." And so we can think of a hero as being no one in particular, but as someone or something that collects things and then keeps them safe. And I think that this is quite close to we might think of ourselves as architectural researchers. Now, we said that the vectorial world might be less concerned with human souls, as it's the case with Dante, but more with bodies, corpora containing millions of digital objects, which are their corpuscles. And if we are to gain some access to the vectorial world of today, then it's probably through them, because each of them floating about in the world and in the World Wide Web taught the intelligences of today how to read, how to sculpt, and how to imagine the world. Now, digital objects, they share many different modes of existence, because the web is multimodal. It includes books and sentences, sounds and scans, database entries. Of course, as a sole researcher, with like this MacBook at my disposal, which sometimes works, I can only accommodate a small fraction of them in a curated corpus. So what to choose? So primarily, a scholar works with books. So I sourced the books for this experiment from 3 sources: from the public domain from Project Gutenberg, freely licensed books in the Internet Archive, and then open access books from the Open Library. And then using my research plan, after a year at ETH, you write a research plan, as a kind of digital fishing net, I would then go and fish in this kind of sea of, I think I had 22 million book titles, the kind of 10,000 books that I actually wanted to have in my corpus. Then, next that I want to work with are 10,000 things. So these things are considered precious or not. Each of them are scanned with phones or with scanners, and then they are turned into digital objects. And they might be in museums, they might be in on the curb, they might be in the forest or in a city, and they're all hosted on Sketchfab. Then I work with 10,000 sounds from and all the materials from the ETH Material Archive that catalogs material knowledge. And then recently I also added 10,000 videos, aerials, poems, and finally artwork. So it's really a massive corpus, multimodal, spanning all sorts of different media. Now, to make all these different types of corpuscles participate in the vectorial world of neural nets, they need to be translated, encoded and vectorized into a domain that can accommodate all of them. And the high-dimensional space of language, indexing sentences and words, might be such a generous place. And often the intelligence of the uploading users, they made a start. So they gave things titles and descriptions, even though they're not always in English. Then with varying degrees of success. Also, artificial intelligence translates between domains, such as image to text or sound to text. And so I think that no technology by itself is enough to pursue this role. Rather, we need to orchestrate a whole constellation of technologies into roles that can help us with this task. So I set up a kind of a technical ensemble where there is a lector, and the lector reads all the, reviews all the text, then the translator gets to work, translates all the texts that are not in English. The auditor gets to work on all the sounds. The inspector then looks at all the colors of the materials, looks at the 3D scans, turns them around into all the different configurations. And then all of these things, okay, this did not work, are then joined in sentences and text. So there was a bit of a hiccup here. However, through this kind of process, by having this chain of different neural nets that pursue different roles, we get to a point where everything sooner or later can be circumscribed as a text and then can be encoded in a neural net. So then now everything is made out of the same stuff that language speaks with and then thought thinks with. And everything thinks in this sense, maybe not necessarily how Heidegger would see it as everything thinks, but then at least everything thinks words, if not world. Now we have these millions of sentences. We have descriptions, circumscriptions, titles, circumtitles, names, and definitions. However, we cannot really count on these words. In order to count on them, we would need to make a dictionary of all of these things and then assign each word a number. And then by doing that, it becomes a token. And then we can think of this as a space where every token is a dimension. Against this dictionary, every sentence is a point and basically a simple frequency value. And so encoded by our technical ensemble, if it's working, everything starts to be translated into this domain. And in doing so, we forget all the sentences once we are at that point that these things were found. Right? The sentences are literally suspended in midair. All of them are of the same kind. They are points in hyperdimensional space. They are hyper-objects connected with everything that's expressed in the tokenized language of our corpus. We can count on them now. So language becomes spacious. Where do we enter? Now that we have encoded all of these things, we need to find a way of thinking how they might actually be in the world, how they are connected to each other. Irigaray writes, they are things and are things in relation to each other. Only when resettled in good order within the open expanse. So how can we think of the order between things in their suspended state? And can the relations between these things, when resettled in this good order, form a crystalline mapping of a possible region of this open expanse that we are interested in? So where Dante, the poet, fashioned a precise model for all the souls that he wanted to encounter on his quest, we let our corpuscles turned vectors self-organize into a map of the vectorial world. Working in code, this must not remain an abstract idea because we can actually code it, we can make it real. But we need a mechanics that provides this kind of ordering, which has to share some of the cosmical moments in common with with the mechanics that order the world. And so we have this kind of cosmotechnical algorithm, which is the self-organizing map, which we can train, like here, on vectors. And if we are then often used for classifying things, for clustering things, we already saw some examples, but we are on a quest. And so we are into the idea of this as a map that helps us draw this kind of world, but also as a model that in its modelness realizes the world that it is modeling. Now, if we look at this training of all of these millions of things, we see that we don't see anything. And that has to do with the fact that we are in a dimensionality that's completely outside of what we can visualize in 3 dimensions. So every attempt to see what is going on requires a reduction of dimensionality. And then we can start seeing how this neural net starts to adapt to the vectors that are shown to it. Now, after the training, we then select a model to avoid the over and underfitting that we also heard today about, that is kind of smooth and retains the relations without getting too discrete. Just like in this case would be 18 or 19. After we have obtained this model, each node in this net now becomes a cell which is capacious of holding things that are nearing each other. And when dealing with these hyperdimensionally encoded text corpuscles, this self-organizing map is not mathematically only topological. It literally draws together topoi, which are commonplaces. So when we look at the text that is contained in all of these things and the words that are contained in each of these cells, we can see that things that are related to each other are very close to each other. And there are very different kind of regions as we move across this map. Now, where PCA, like the principal component analysis that we use to actually visualize this in this vibrant colors, shows us these kind of regions, means allows us to actually show a veritable topography with valleys and hills and peaks and troughs. So I'd like to think that Robert Venturi would say that this is PCA in plan and mean in elevation. But we have this multiplicity of possible valleys and hills, peaks, but where to go and what to see? In such a network of high points, key points, high places, writes Simondon, there is a primitive lack of distinction between human reality and the reality of the objective world. These key points are points of contact and mutual mixed reality, places of exchange and of communication. But this is not really a stable ground, and looking at it alone does not really make any kind of communication arise. So we need to step in. And if we take this as a kind of imaginary model, then there is not really a privileged beginning from where to start, as Michel Serres writes. Rather, there are multiple entry points, ramifications among weighted links between vertices that we can explore. Now, an infinite amount of possible quests are possible in this topological map, which we could not ever exhaust in a lifetime. So how to trace kind of meaningful paths through this topoi? Quests are known for being scary, like whether that's a video game or whether that's a story, and they normally get scarier along the way. In the beginning of the Divine Comedy, Dante finds himself in the middle of a dark wood. In the wood, writes Heidegger, there are paths, they are mostly overgrown, that come to an abrupt stop when the wood is untrodden. They are called Holzwege. When Dante himself finds himself in a gloomy wood astray, it's just a couple of lines until he is assured to find someone who leads all wanderers safe through every way. So I'm not actually rhyming this. This is actually how it's written in Divine Comedy. And then again, a couple of verses later, he meets Virgil and Beatrix, who know sections of the topography well and take care of him. But who could be a guide within this model? Authors, in fact, make great specters. Their whole oeuvre can be a guide or some of their selected works only. A guide shows us a way in sequence, unfolding in one dimension. And we can model such a guide quite similarly to our topography. So here is a one-dimensional self-organized map. And as we spoke of Aldo Rossi earlier, I now imported and cleaned all the books by him to train this guide for this leg of the quest. And trained on any corpus, this guide now learns how to show the spectrality of all of this corpus at a given amount of resolution. So these are like 16 cells. And now the cool thing is that we can start mapping these things to our topography as long as it's vectorized accordingly. So these are the kind of places that Aldo Rossi would go and visit in our model. And every spectrum, every character has their own way of navigating this world. So the question is, how do we translate, how do we read from one place to another using our topographic map? And this is, I think, by reading in a notebook. Because a notebook is far more than a receptive surface. Like I'm presenting from a notebook right now, but also the notebook is a way where we can record things, we can save things. So in that sense, it can be a travel log. Illich, who's a scholar who wrote already some time ago about concepts that are very close, feel very close to us and our kind of idea of digital literacy, even though this was written way before personalized computers were a thing. He writes about the act of reading as a physical activity, picking, bundling, harvesting, or collecting. And this was especially true in the 12th century. When Hugh reads, he harvests, he writes. He picks the berries from the lines. Soon after, there was this massive turn from this bodily monastic way of reading to a scholastic kind of moment of reading, where people no longer approached the book as a vineyard or a garden or a landscape for an adventuresome pilgrimage. Rather, the book connoted for them much more the treasury, the mind, the storage room, the scrutable text. And so I think that while the latter way of reading presents us more with something that's quite close to the idea of a query, as we query a database, the former seems to have worked more along the lines of the quest that we are interested in. Now, for most of the time of the Divine Comedy, Dante the pilgrim walks. And even if guided by Virgil, he must walk this walk himself. And so a guide can help us in paying attention to things or putting them into relation with each other and how they speak about the world. And so with some algorithmic combinatorics, we can see the path that Alro would take to visit its high places. And so if we go with this kind of reading setup, then we see how there are moments between these points that actually Alro has something to say, and then all the things in between which are topologically close but are connecting these things. And actually now, as we speak, I'm trying to let this run in the background. And now we start seeing how there's this kind of book that starts being populated by all the things that Alro, the model, picks up from the other model. We can see the things in bold, that are the things that Alro speaks about. And then we see the things in normal plain font, which are the things that are picked up from the map itself. And so in there, sometimes we have sculpture, sometimes we have things, some we have materials, we have aerial views, we have all of these different things. And then, of course, all of these elements that are picked up, they don't come only by themselves or alone. They always come in a multitude. So they come from deep of this kind of neural net, and then they're being shown to us in this notebook. And make this a bit wider. We can start seeing that everything is kind of hyperindexical. If I click on something, then it should open up the link to the material base. If I click on a 3D model, it opens up in here. If I click on something like this, it opens up in my Zotero on the right page. So it's kind of a nice way of thinking of how to conduct research using these neural nets. But then, of course, walking is only one way of transversing something like this. So, for example, we spoke that with Beatrix, Dante actually flies through the heaven. And there's also a moment where he flies with an eagle a bit in Purgatory. So we can code ourselves also a kind of a pair of wings, and then with which we can fly on our topography outside of the topological relations of it. So we are jumping from one place to another. So now we are following the spectrum of Alro much closer than the spectrum of the map, if that makes sense. And we proceed directly to these high places. But what I just showed here is just a start. So over the next weeks, I'm planning to develop a kind of another model, another meta model, or a schema, or a framework to undertake multiple, at least 100 to stay in tune with the cantos in the Divine Comedy, of these legs of this quest. And each sequence would then show me sections of the vectorial world that I'm interested in. And some of them are by foot, others are by flight, others are hybrid, some are guides, some are maybe quested alone, some will be indexical, some will be generated. And I think that is playing through these multiple levels of abstractions in dealing with models, whether they are more indexical, like a self-organizing map, as we spoke before, or more generative, like the ones that we saw already today when we speak about Stable Diffusion, Midjourney, and so on and so forth. I think it's very key to abstract away from common use paradigms of how we might use these things. And so now towards the end of the lecture, I actually want to show two small things, two small projects. The first is something that Adil Bokhari and me developed as a very simple meta model or scheme for a project titled Automata at Code, in which a large language model and a text-to-image model role-played several roles through a table, then to, in the end, inhabit a full structure. And then in this latest installation, I worked also with Adil and Miro Roman from also the chair of digital architectonics here, like not here, but there in Zurich, to let us transport us, as well as hundreds of visitors that came to this exhibition, to 1001 places. And here, this kind of schema, quite similar to the table that we looked before, allowed to play neural nets by finding very discrete obstacles around which then these tables and windows could be crystallized from this very continuous latent space into these very discrete things that then would be rendered and shown in screens in a very concrete location in Zurich. And so every 30 seconds, we as visitors would experience a completely new time of day and a new scene with a new view out of window. And then every 8 minutes, we would step into a new synthetic day. And then, of course, this goes towards this idea of thinking of a schema through which we can start conversing with these neural nets to tease things out of the latent space that are not generic, but are interesting us as designers and architects. So now I hope that I have showed you a bit of an outline of how we might think of such a quest in the vectorial world. And all of the things that were in there, so the researcher, the hero bottle, the guide specters, the divining rods, and all the other coded helpers and schemas are now ready with this sifted cosmos of things awaiting them. As we quest this new world, we tell us stories of what we find. We might even sing. This is when the quest then becomes properly epic. This year, I'm putting this method also to a test at ETH Zurich, where students train their own guides to explore the multimodal corpus that I prepared, and then to think of ways of bringing it to life. In this sense, I hope to have shown how the mechanics of this quest abstracts away from a digital query to free our eyes and hands up for a new kind of architectural research and practice. It aims not to exhaustively, but to intelligently discovering modes in which digital, technical, natural, as well as vectorial things make up our world. And with this, we can start thinking about how every piece of architecture we design becomes inadvertently a model, bringing together things, the vectorial and the digital, the technical and the natural, the probable and the improbable. Thank you very much.
Okay. It's like her arms are gonna
interesting in general. Like, I mostly want to just play around with it because, like, the idea of getting access to the data set and like getting to find your own way through that is very exciting. I also love just the idea that everything is really just vector math, like the more we think about it. But in this journey, whether walking path or the flying path, I wonder if there's an opportunity where it might be, showing things that are on your path, but also might show you the direct opposite of if you were on the opposite journey of whatever that might be, like, and then so that you could compare instead of just like reinforcing the same path that maybe, I don't know.
Yeah, I think this is a beautiful idea, and in a past experiment, I played around with this actually in a course that Ricardo taught, who's also here, with like doing kind of an opposite search engine that shows you always the opposite of what you're looking for. The problem is though that there's something quite funny about how there are things that are near you and they are close to you, but opposite could be literally everything. So this is kind of like the things then start to become sometimes incredibly funny, but also like I had like a little experiment like Robert Venturi going to, I think, to Wikipedia. And then the things that Bob, because I think it's quite important to differentiate between the model and the real human being. So Bob would pick up certain things that would be close. There would be like, I don't know, Baroque houses in St. Petersburg. I mean, that made complete sense. And then the opposite was Bugs Bunny's birthday ball, I think. And it was kind of, on one hand, and then I'm not even sure if he would have hated that, But it was kind of like just from the cosine distance, the most further away thing to think of in this kind of like already dimensionally reduced vector. So it's super exciting to start thinking of this opposite, but like it's sometimes very surprising and not at all what you think sometimes, because it could be everything. Yeah, but I'm very excited to play around with these things, also thinking of like, other kind of encounters that are actually be on the sides of the path, or even characters that have a slight, play a role that are not your friends, but they're actually looking to get you off the path or showing you things to make you deviate. But the beautiful thing is that like with these codes that we are working with at ETH Zurich, they are quite, they are algorithms that have been around for a long time. They're not deep neural nets, so they're quite shallow in that sense. But what is beautiful about them is that you can still use them in connection with deep neural nets, and that you have a possibility of actually coding quite hands-on the models that you're working with. So there is this possibility of actually hacking something to some extent to make it work for you and to really play it, which sometimes with the massive models becomes very tricky, because you are given a black box and then you can tune it or fine-tune it, but you don't have the possibility to just turn it around or make it work in a completely different way.
I have a question. I was wondering, I enjoyed your talk. Even if I saw part of it before, it's always like, I always see new things. It's always very enjoyable to see your work. And I was wondering, because you spoke about things and things, and about hyper objects or objects. And I was wondering, how do you think about the difference of things and objects or hyper objects? And if it's something similar to the difference between Robert and Bob?
That's an interesting one. Probably this, I have not thought about it in this constellation, but like I think there is something there. I think something which is beautiful about this idea of thinking of the natural object or the technical object with Simondon, or the digital object with Yukui. The problem is that like these things, they remain objects to some extent, even though in Simondon there are already these moments where he wants to see these objects not as these things that we place in a safe distance and then say you are an object and I'm a subject, but he sees them as a kind of instrument to look at the world. So he decries that there's not enough technicity to actually make sense of the technical objects that surround us, and by doing so we kind of falling for either like singularity narratives when it comes to technology and being afraid of being taken over by robots, or on the other hand, to see these machines as slaves. And then this is actually written in 1957 or something like this, which is kind of insanely clairvoyant if we are thinking of the discussions that we are having today. And with the digital object and the vectorial object, I think what I'm trying to explore is to bring some of this idea of this object which is beyond this object versus a subject, but like more something which is like an instrument that relates you to the world, also to the realm of machine learning and vectors. Because I think that there is something that makes, at least in the idea of the things world, where we start thinking of the thing, especially like in this Heideggerian moment, that the thing is kind of like connected in the fourfold of the world, and so by that the thing, not the object, has a kind of fixed place and is in a relation with its environment, whilst the object is kind of devoid in a vitrine and closed off and all of that. And I think that with the vectorial object, because actually these things exist as vectors in a massive space that indexes everything else in the world of that model, I think is actually quite close to this idea of a thing which is by default relational and not a separated thing for itself. So I think that like with this idea from the natural object to the technical digital vectorial, I think we get closer to the idea of a thing as a relational thing than getting away from it as an object versus a subject. Yeah, but that's an assumption.
Well, thank you for the presentation. When I was listening to you, it made sense, the diagram that you have with the spiral to go to hell and then to climb and go to heaven, because I'm seeing how beautiful you're articulating the relationship that this, what we're talking, is not new, right? This way of thinking, it's already been there. So humans have been always intelligent. So we cannot claim that all these things that we're seeing right now, it's only because we have computers and only because we have computational power. So on that line of thought, I've been thinking about how all the big tech and all of this push and funding is going into creating these multimodal predictors, which is what we're seeing with ChatGPT and Midjourney and so on. But you're doing the same approach, which is creating this multimodal fusion for creation. So I was very curious to know, how do you really, because you're saying everything is indexical, everything then is related with something else, how do you decide to turn that into the thing? How do you, like I'm thinking it's easy for these big tech and companies to say, I will predict what's the best product to buy based on all these different multimodal data, but then you're saying, I'm giving you the same technology, this beautiful way of thinking for creation. So how do you decide what to create? What will be your creation with this? That more or less will be my question.
Wow, that's a big one. Also because like it's, I mean, personally, like now being a PhD student, it's like, again, I feel a bit more distant to my role as an architect or designer, with how I worked before, like also designing with intuition. So I think that there are different I think, scales to this, like what is the role, and I think we touched also in Benjamin talks a bit about the idea of the role of the architect and the designer as these neural nets kind of are coming about. And I think that there are like multiple things that we need to think about. On one hand, there is this the narrative that, like, of course these neural nets might take away our jobs. They might make nicer images that we could render in way less time. They make write better emails that we could ever write, so like on one hand there is this kind of fear is real, and it's probably also right to be worried about this. What especially in my experiments with Adil and with Miro now at the chair, what we were starting playing with is kind of, can we invent a new way of working with these that is outside of the normal way of using them? Because like if you're using them, you're a user. So like you are kind of being designed for by normally a big tech company to use it in a very certain way. I was working as a UX designer for a while, so I know roughly how that works. And I think as an architect, it's always nice to kind of go to the seams of these experiences and to start thinking and making a world in which you can play with these things rather than use them in another way. So I think that there's this moment of, let's say, creativity or invention spirit for the architect, where we can go on another level of abstraction, and we can start, despite not having the computational power, despite not having the massive teams of AI developers, despite all of these things, we can start speculating, okay, we take that these things are for granted and that they exist and that they work well and they work better than what we could code them as architects. But we can take the liberty to start thinking, how would we play them differently? What stories do we want to tell? And then start using them in a way that maybe nobody ever intended them to use. And then this gives us a bit of freedom and a bit of exploration. Thank you.
Thank you so much. Very thought-provoking, and there's so many things kind of running through my head. I think part of the issue, of course, with search engine is that they're controlled by these large corporations, and I think this is a kind of way for us to establish our own relationship, our own priorities, right? This is kind of a tool that allows us to find our own journey through this vast search space, right? But I'm also kind of really interested in this idea of both the vectorial relationships between things, that is somewhat reductive nature of it, right? And this relationship to the physical world, in which sometimes the Japanese kind of notion of wabi-sabi and imperfection of the physical realm that exists, and we start to, let's say, produce a personal relationship with these imperfections of things, right? And then how does that, kind of exist in a world like this, when, sometimes, people get kind of annoyed when your car gets nicked, but nowadays I kind of go, well, that makes it mine, right? In this sort of very personal sense. So I'm kind of very curious about how do we imbue this sort of sense of personal relationship to these things that we start to collect.
Yeah, I think this is very nice. Very nice. I mean, it's also thought-provoking for me to think about this, because I think that there's a moment in which the way, this gets very philosophical and I'm a bit out of my depth, but but of course, if we start, first I think that these vectorial objects, I think they are never kind of absolute. They're always in relationship to a kind of a space that was established by a kind of algorithm to host these things. So that can be a 10,000 dimensional space of words. Then it might not have the 12,000th word in it, so it cannot account for it. And then even if we would want to work with a 10,000 dimensional space, and we would reduce it, then the vector that we would get out of it would be a vector that was done with an autoencoder, or it would be done with an LSA, or with a different method. And so these vectors, the clip vector for this chair, yes, that's what clip thinks of that chair, but that's not what another model might think of it. So there's not a singular vectorial representation for all the things around us, and I think it's very important to remind ourselves of this, that there is not this absolute reference point. Even though, of course, there will be probably companies and models that will be so successful that they might become a kind of a reference or a standard.
All models are wrong, but some are useful.
Yeah, exactly. Yeah. But then on the other, let's say the more personal part of how we start to see our world, I think that the way that we scratch our car, and then by doing that it becomes a bit more our car because we have another story to tell about that car. I think this is a very nice way of thinking about how also the way that things take place in our reference space that we have, which might be completely different, working in a completely different and not mathematical way, but still we have models of the world, and things have places in this model. And if I scratch a car, then it's only bad because I have something in me that says that's the value goes down of the car, this was a mistake, I should have not done this, why am I so clumsy? And then these kind of things, they start to play, of course, into the weighting of how I see my car. Or on the other hand, if there's a nice story of how the scratch came into the car, it might also elevate the car. But so I think that not just the models, the computer models and how they see the world, but also we have our own models, how we see the world, and they are kind of dynamic and in constant relationship with each other. Please.
So thinking back to the beginning of using language to explain the color orange, or like that process. My mom teaches color theory, so I was thinking a lot about that, but also in her telling me that in the Russian language there is a different color name for light blue. And so if you ask Russian children to pick out when does it become blue versus light blue, it's a very obvious line of delineation between those two things, versus in English that's much blurrier. And so I wonder about in the initial stage of like everything can be encoded into language, but like which language? And that in the beginning also of you saying that students or someone was tagging some of these things and not necessarily in English, but then that being translated. And so I wonder if you have like thoughts on like how that influences the rest of everything, kind of.
I mean, 100%. I think that's a very good and also tricky thing. Like I like to say this is, you could also say this is a large English model, because it actually is. But like I think that, that like I think it makes sense to think of this as language, because like language as a category, I think if you would have enough data to train this on a completely different language, and this language would have been spoken by intelligent beings, then that intelligence would have probably also find their way into the model. So I think that like even though we have the large language model now, like these big models trained on English, there's nothing that would prevent us, and I would be very, very surprised to see if it would be a completely radically different kind of intelligence that comes out of it. But it might be different, and it would, I think, still work though. Like it's not that like it's just the English has so much material on the web that allowed for this quantity game that was important for English. And it's quite interesting to see how a foundation model of OpenAI, which is trained mainly on English, can then through fine-tuning and through additional training start to pick up other languages that have way less representation in the internet, and to start conversing in these languages as well very satisfyingly. And yeah, but the question of course remains, like what would happen if we would train this language model on the language of, let's say, an animal language? Yeah, what would, I don't know what would happen, but it would be very interesting to find out.
Can you push that question further? Say if we have two large language models, and if the goal is to find the most efficient way of them communicating, how do you imagine that language to be?
I mean, there was, I think, once this experiment where I think two language models were released to speak to each other, and then after a while they started speaking strange gibberish that like no human could disentangle, because they found a way of communicating kind of concepts to each other in a very efficient form that is beyond the way that we speak, for example, in our English grammar. So it's quite interesting to see these things unfold, but I think that's the beautiful moment of these this AI, is that like we learn a lot about ourselves as we start looking at these models, because we get a kind of an objective distance to how we see and speak and learn about the world, and then how do we learn from these things without anthropomorphizing them? I think that's the challenge.
Yeah, but I was wondering, concerning this question on language and on English, because you had Dante as a reference. I know Dante doesn't write in Latin, which would be the English of the time, no? He just writes in Italian. So I was wondering if what somehow you were showing can also resonate with Dante in that sense, that you are kind of developing a digital vernacular tongue. So it's not by abstracting from the Latin/English language.
Mm-hmm.
Latin language that, by the way, is like also contains a kind of resonance with Latent, but yeah. So using English as a latent language in that sense.
That's very interesting. Yeah.
That would go also with your mattering, perhaps.
Yeah, it's true.
Very quick. But
I think I would need to think a bit more about how this would work, but like, yeah, it's a great idea. Thank you.
I'll try to keep it short. As a musician, it's very interesting to talk about this, because we're talking about this idea of quest or journey, and there is a temporal aspect to that that's often, connoted, associated with it. But when it comes to this discretization into thingness or objectness, I find this very interesting, particularly in modes of creation where we deal with more continuous time series of states or things, or this is something that I'm gonna ask about is when we try to distill these more continuous temporal processes into language, right? There has to be a minimum time scale at which we discretize it to be able to attribute language to it. Or, I mean, the other thing is when we think about knowledge production and storage and transmission in terms of the body itself, how do we discretize that massive network, analog network of all of these different questions? So I wasn't quite fully formed on the question yet, so I apologize. I guess I'm just interested in how you would adapt this sort of a system to these more analog temporal processes and temporal modes of creation, and how do we capture that experiential aspect of what it means to be human and walk through the world and interact with objects and things that we, you know, attribute names to?
Yeah, I mean, this is a great question. I think there are a couple of points I think to unpick. On one hand, of course, the second leg why this whole thing is working is because of mathematics, because like there are frequencies. I mean, that's kind of cool that like all of these dissimilarity things can only work because actually all of these words, they start being encoded into a domain, which is a frequency domain. I mean, in this case, it's like term frequency, inverse document frequency, which is kind of quite a robust and also well-tested algorithm. And then these frequencies, they then are the vectors that we are speaking about. And yeah, sorry, and then these frequencies, of course, there is a way of doing that without actually having the whole language in the loop. Like we can we can encode a piece of music based on the pitch, for example, and how the pitch changes. We can change, no, but like I think like we can encode it on many different ways, and like this is a bit like alchemy, like how these things work. There is not really a perfect solution. If we work with like images, then we can take RGB values, and we can take a neural net that looks at concepts, and we can take a neural net that is multimodal, and we can put all of these vectors together, and then we have something that might just work. So like it's not like there is a perfect way of representing these things in vectors, and I think there will also not be necessarily only things that work better than others from a pragmatic point of view. I don't think that we can, and all of these vectors, they're always, as far as at least in my knowledge, most of them are, you can never get the original back. So like they are basically a radical compression technique. So I think that like you can never kind of, you sacrifice a lot of the piece of music as you vectorize it. You basically sacrifice all of it, because you cannot listen to it, it doesn't make sense, it's compressed in a way that like only picks up certain things like the pitch or like the bass or like the beats or like the tempo. I mean, I don't know like how Spotify has a couple of 6 or 7 metrics like danceability, energy, and some of the other things. Based on that, all the songs are encoded. So I think that when one starts to look into how these things work a bit, it's kind of very clear that it's kind of a fantasy to be like, oh, like there will be the perfect way of capturing this. There will just be ways that are better suited for certain users and others for not, and others and others none. And then I think that there are simple domain problems, like there is a reason why we listen to music and we don't hear the music spoken in words. I mean, then that would be maybe something else, but like it would not be music, right? So yeah, there is a like mathematically it would not be an isomorphic mapping from music to language, 100%, never. And like I think that's with more the things that are encoded in this corpus. Even the sentences themselves lose a lot by going into this.
Just to add on that, I think it's very much kind of in line with what Nicola asked in the previous presentation, thinking of complex planes and real planes. There's not necessarily, I think, the need to be able to fully represent an actual object that we speak about through an encoding in a digital thing. We don't need to appropriate it in the digital, but it's more about being, like you said, what's the most useful way of representing that in a vectorial space for the means that we want to talk about, which is exactly what Nicola was also talking about, where it's it's about the proportionalities and the adequacy of making these things talk. And then it's not so much about making an isomorphic projection that is completely internalized within the digital, but that it stays as a representation. It's not an internalization.
Yeah. Yeah, I agree.
Okay.
All right. Thank you very much,
Thank you very
Agostino.
much.
Thank you.
That's good.
We received the executive order from Adil to kick you off the stage.
I'll write him on WhatsApp.
All right. So I'm excited to present our second panelist, Laura Michelin. I'm sure I'm pronouncing that wrong. Do correct me when you get up here. Laura is a founding partner of MMR, a lecturer at UCLA Architecture and Urban Design, and a creative and architectural technologist based in Los Angeles. Her research and practice focus on digital simulation and algorithmic mutations with specific interests in infrastructural systems, climate engineering, machine vision, and fashion. Laura has taught at SciArc, Kent, CAED, and AAVS Seoul. And she has worked as an architectural designer at Studio Kinch and at Euler Wu Collaborative, and as an energy analyst, CSR lead, and a building facade analyst at Glumac Tetra Tech. I'm having trouble with these things. Her personal work has been exhibited in galleries throughout Los Angeles, including Wohnzimmer Gallery and the Tetrapod Gallery, and she has curated multiple shows in collaboration with Super Collider. Laura holds a postgraduate Master's of Science in Architectural Technologies from SciArc, where she graduated with distinction, and a Bachelor's of Science in Civil Engineering from Columbia University. Laura's talk is titled Mediation Layer. Welcome, Laura.
Man, I gotta edit that bio. It's so long. I'm so sorry. Just give me 1 second for it to load. Come on. Cool. Yeah, hi. My name is Laura. I'm coming from Los Angeles, where I teach in the postgraduate program. It's a Master's of Science in Architectural Technology. I'm happy to be here. I'm super excited about all the presentations so far, so I think this is going to be fun. Hopefully, we'll see. So before I start, I always love to give myself a tiny bit of context, because I think, as was said, like I have my undergraduate degree in civil engineering. I did a lot of research and work there on using recycled waste material as aggregate in concrete. Most specifically, we were kind of focusing on e-waste and recycled computer parts, but also styrofoam and glass. I've worked as an electrical designer on Disney Shanghai and the Wilshire Grand in LA. I've also worked as an energy analyst, energy modeler, and sustainability strategist who worked on everything from campus scale energy audits to high performance facade design to microclimate analysis. And I have my master's in architectural technologies, where my final, not thesis project, but like final project, was focused on air quality in Mexico City and using direct air capture right next to high density housing. So my expertise is not in computer science, nor is it in architecture or engineering, really. Not in urban design, nor is it in art. It's kind of in a weird hybrid world that, if you can't tell already, I'm having a hard time classifying and still trying to figure out where I fit within all of this. But most of my work falls within 2 different categories and scales depending on the project, either large-scale climate engineering or fashion. So today my talk is titled The Mediation Layer, which to me, the mediation layer is the interpreter and converter between data collected from different sources and most likely in different formats, and those who end up consuming it. So it's like the way of making sense of complex ideas and insane amounts of information. And throughout this presentation, I'm going to try to think about it over 3 chapters, from representation to interaction to systems mapping. So first, in terms of research and then representation. So
kind of like the basic interpretation of this mediation layer is like researching something and then applying visuals that might either enhance it or essentially act as data viz. Essentially, generative AI models, in a way, especially these diffusion models that are steered by CLIP, are really just essentially data visualization. Complex language as the input gets synthesized and the output imagery is the representation of that. This is essentially the premise of my piece, Translation, which was shown at Biosphere 2 last year. Climate change is essentially a pattern or series of patterns drawn from planetary scale data collection that is synthesized and interpreted through a climate model. By the time the information makes its way to the public, it's already been translated through numerous phases and filters: sensing, dataset collection, climate modeling, the IPCC condensation and filtration, and the media translations. As our culture becomes more dependent on the visualization of information, it kind of necessitates a reinterpretation of this information. So this project emphasizes both the success and shortcomings of the language that was used to write the original documents. The act of translation suggests an alteration, a change in a given language's form, condition, or nature, often with the intention to explain the original subject matter in a term that it could be made more easily understood. So by translating the IPCC climate report into visuals generated by a variety of neural networks, translation aimed to adjust the way in which we could be informed by the data inside the report. So these trained machine learning models reinforce and reconstitute known imagery through the bias inherent in the curated dataset, producing visuals that broaden the report's ability to be understood and serve to a broader call to action. As an aside, this project being shown at Biosphere 2, it was projected on the North Lung, which, if you don't know about that building, it's my absolute favorite, and the entire history of it is so fascinating in both of its failed experiments. I would highly recommend going and taking a tour of it. I also made friends with the mechanical engineer who took me on his night rounds through the building, and I got to experience everything through the lens of the person who's there to make it continue to operate, which was a dream come true. I hope to go back and visit him. But so this project is less like data visualization and more like adding a layer of legibility to existing data. Also, just in general, I think that some layer of machine learning overlay or manipulation remains constant within all of my projects. But in the office, we're working on a temporal coherence kind of strategy using a variety of workflows for using, let's say, dirty input video. Here, this is screenshots. It's actually video, but screenshots of Google Earth of downtown LA. And then adding layers of diffusion models and some other tools for constraint. So adding information, cleaning information, adding legibility, or a kind of layer of paint or filter on top of it. These LoRa models that we're working with aren't meant to completely transform everything, but instead to act as a kind of render pass on top of it. And then really kind of leveraging segmentation models and control net to constrain it back to make sure it stays within a reasonable bounds of what we're aiming for. The focus on research is probably more obvious in two seminars, well, a couple seminars that I've taught at UCLA. This project, Planet B, Speculations on Exoplanetary Life, started with researching or kind of using existing research from NASA that they've put on this platform called Eyes on Exoplanets, which is taking kind of their basic information that might include the chemical composition, mass, temperature, what have you, and represent it in Unreal Engine and Houdini, which for incoming students to UCLA that have a more traditional architectural background was very fun for me to watch them go through. Seems mean, but it's not. And then in this project, students were tasked with designing a VR experience or game from the eyes of a non-human other. This group obviously chose one of their dogs, Cora. So the color scheme here references the colors that dogs perceive, and the communication methods of movement and gamification are tailored towards the dog and not the human. I think this is most specific in the P-mails that dogs leave each other, apparently, as a way of communicating. This project is really fun, but they were actually interested in continuing this into being less of a game, but more of a visualization of how a dog might experience this as a way of better understanding. Not machine vision, but the project was an exploration in the vision of the other. So funny. I think the intention of this at the end is he had to find his toy to be able to get back home, but. So the next step beyond just representation is obviously interaction. And coming face to face with the data set or with the complexity of a system, and then being able to interact with that data, you obviously gain another level of insight in how the system is either working or not working. And this might be in interaction and gamification of infrastructure systems or in a data set that is rife with bias. But I mean, I also think back to my previous life as an energy modeler in the energy model of the building that is simulating the energy, water, waste systems of that building. So in this class, it was using game engines as a training tool or a gamification tool for a complicated infrastructure system. So designing or reimagining the architectural home in which we live in close proximity to decentralized infrastructure systems that might include algae, carbon capture, or wastewater treatment. And then through this course, students learned how to design and integrate these systems into the architecture of the home, design the UI/UX maintenance infrastructure needed to operate the system in VR, and then representing it both in VR but also in pitch decks in terms of how to get funding. So here, the VR experience of maintaining a direct air capture plant that is within an apartment complex is split into two users, the tenant and the engineer. The tenant view sees whether an engineer is remoted into the space or not, or maybe if something is working or not, whereas the engineer has the range of inputs and errors that they can access. The ways of, like, this way of interacting with data isn't even like novel or new or exciting. The Air Force, HVAC companies, Rolls-Royce Aviation are all implementing technologies and workflows like this, a lot of which is for safety and also just for cost savings. So here's an example where the interaction with the data set is less gamified and more kind of just reflected back at you. Machinic Reflections was a piece that I did last year, and I started thinking about this piece as a way to try and figure out how to explain myself and my categories of, am I an architect, an engineer, a technologist, an artist, a researcher, an educator, and then forcing others to undergo the same sort of snap judgment made by the other. I ultimately expanded this to 16 different categories of jobs and then 400 associated faces that I scraped from LinkedIn, except for, besides jobs, obviously conspiracy theorist is not a job that is on LinkedIn, but I wanted to add it, so I did. I also want to kind of mention the fact that 400 is not that many faces. I mean, it was a lot to do per category, don't get me wrong, but in terms of building out a robust model, that's really not enough. But that's not the point. The point is to kind of think about the bias inherent in the data set and even to highlight that. So in this sense, having a poorly trained model made a lot of sense. But machine vision, image classifiers, object detection, and facial recognition are used in governments, police departments, security companies, the military, tech companies. We allow our faces to be recognized for our phones, both for security reasons and TikTok filters. During COVID, classification models were used to recognize if you were wearing masks or not. These algorithms exist and are being implemented in a variety of classification models. And according to these algorithms, what do you look like? And what do you want to look like? Do you embody any of these classifications reflected back at you? It's both a version of reality and a simulacrum. The classification reflects an unknown representation from the data and the model of us back. As an aside, those are my parents on the right-hand side. My dad was very proud to get architect, which I thought was very fun. He's not an architect, but beside the point. But yeah, I think the most interesting part of this project was actually people's reaction to it. So treating it really as like a fortune teller, or they were so angry with me when their reading was not what they wanted, I guess. to which my point is always, there is no correlation between your face and your job. You should be wary of how this data is being used, because it is being used today. The point is to highlight that bias. I also had made these masks that were different generated versions of my own face that you could hide behind if you felt uncomfortable. So this project turned into, or kind of extended into a course that I taught last spring at UCLA called Proxy Faces, Masks, Manipulation, and Machine Vision, that investigated both the classification and generative machine learning models, as well as a variety of mask making techniques that might help us to embrace, distort, or hide from our classification, where the masks or proxy faces served as a type of prosthetic through which the user could disrupt their classification. And students could have an aim of looking more human, less human, to look like something else, to look like nothing at all. We actually only had one student that tried to increase the percentage of human. And she did this by adding multiple eyes, noses, and mouths all over, which it's funny because we didn't, because of how we were testing this under different lighting conditions in different ways, which is why most of these look like person instead of how we were actually testing them in class. But at the final is when we finally got like the actual numbers for her back, and she could increase her percentage human by about 3 percentage points, which was really fun. Again, here you can't really tell, but if she had done this under the correct lighting conditions that I said, it would have been fine. But these, oh, I guess actually I'm gonna skip to the end of it because, oh shit. Come on, let me do it. Oh well, I'll just say it. But at the end of it, I also made students wear them out in public and take photos of people's reactions to them, which was so much fun to collect homework in terms of that. But also I think for the students, it was really interesting to see where they decided to take them and under what context they decided their mask made the most sense. So, yeah. But part of me also, like, these are all very interesting kind of interventions or ways of thinking about, I guess, my version of architecture, but ultimately I kind of come back to like what's really important here, like what's really important to me. And a lot of this is coming back to systems mapping. And so when talking about mapping systems, I think it's more of focusing the data analysis not on the individual, but on the mass. So a lot of this work stems from my anxieties for our future. The climate anxieties associated with carbon and methane emissions, about critical mineral mining, about energy generation, and about waste. Over the past few centuries, humans have very chaotically and often accidentally transformed Earth's ecosystems, and in response, the emergent intelligence represented by large-scale systems mapping and computation makes it important to conceive an intentional, directed, and worthwhile planetary scale design, which is often referred to as a terraforming. This comes not from the computing infrastructure itself, but in the design intention with which we focus it. So systems mapping applied to the city scale opens the door for a field of inquiry and practice that sees urbanized areas as a depository of various types of intelligences. Algorithmic governance and data-driven planning, in their attempt to deliver new urban efficiencies and decrease the messiness of lived realities, often forgoes the intelligence of local communities and knowledge institutions. So thinking about alternate concepts of computational models of urbanism, possible ways of embedding digital technology into existing environments, trying to navigate a complex web of urban policies and development, and understand how large systems work, engage with local communities, local issues, and design new social and technical infrastructures that prioritize spatial and digital justice, which is kind of funny to go into the next, well, this project, which was asking, this was essentially asking students to project into the future with a what-if statement. So what if the city of Seoul's landfills were 100% filled? What next? Dealing with an issue of lack of space for landfills, thinking about the problem on a temporal scale that allows us to transform them, not a quick fix. It's zooming out and thinking about it more holistically, and then diagramming these systems, which I think is a super important part of the step, taken really from like cybernetics as a way to bridge between the past and obsessive interest in prediction, the future, and the virtual. computational searches as a foundation for observing, documenting, and analyzing the world using feedback loops and management of urban space. Because like, how do maps shape our understanding of the world, and how does this world get coded into the maps and diagrams of any of our data dashboards even? The historical continuity of our cartographic culture parallels the rapid change in mapping technologies and forms of visualization. So using archival and technical research, machine vision, intelligent agents to analyze, represent, and manipulate infrastructure at the urban scale. Here, students created a historically situated, technologically literate, and data-driven representation of 6 different areas in Los Angeles. All the areas were designated for freeway construction that never took place for a variety of reasons. And then instead of kind of discussing the geographic and economic fragmentation caused by these freeways, students who, in this case, I feel like it's important to note these students were ages 13 to 17, but created multiple representations of the socio-technical urban fabric. Then representing this in a stack of a digital collage with layers of satellite imagery, GIS data, segmentation models, archival images, really anything that was important for the developed topic and argument. One of the first ones, not this one, well, I'll talk about it when I get there. One of the students was obsessed with the idea of mapping the Christmas spirit in Los Angeles, and dead set on doing the Christmas spirit, and there was no changing. There were no other holidays. It was the Christmas spirit in Los Angeles, and it was like, okay, let's do it. It's this one. And I was like, gathering information for her was also not using a traditional search engine, but TikTok. And then I was like, fine, let's screenshot it, and that's gonna be how we're gonna represent this at different data points. And then, I mean, for me, this is fun because it wasn't ever a topic that I would have necessarily chosen for a class, for a workshop, for what have you, but letting them kind of run with it in their own way was so much fun. So I guess getting back to my anxieties, the temperatures are increasing, carbon emissions are untethered, sea levels rise, the reservoirs are depleted. Wildfires are constantly consuming the Northwest and Los Angeles. Hurricanes flood New York, as well as the rest of the East Coast. How do we interact with and confront these realities as designers? With ecological, social, and formal systems pushed to their limits. How do we use technology and design as operative tools to envision a future landscape? So again, based off of, after reading through the IPCC climate report, on advancing carbon capture and sequestration, and then a few months after that, the US released their methane reduction plan. I guess for me, I spend a lot of time thinking about carbon emissions as the main culprit to focus on for anthropogenic climate change, but what I had not realized is that methane actually accounts for 30%, and as the IPCC had explained in that report, 1 ton of methane in the atmosphere has about 80 times the warming impact of a ton of CO2. And this was a total game changer for me because I guess I didn't know. And so this project, which is part research, part art project, aimed to connect the systems of large-scale seaweed farming of brown kelp for carbon sequestration and red seaweed for the addition to cow feed in order to reduce methane emissions. So these are gonna be fun. Some fun statistics, but each cow burps about 220 pounds of methane annually. I bet you did not realize that it was from cow burps, because I think everyone thinks it's cow farts. It's not, it's cow burps. In fact, one company actually designed this helmet to put over a cow that would capture their burps, and it's just like, what? That was wild. And then, okay, so 220 pounds of methane annually, and California has about 1.72 million dairy cows and 670,000 cattle. These numbers are from 2 years ago, but staggering. The site is just north of Los Angeles, off the coast of Ventura, and extends inland towards Bakersfield. So I used mostly CycleGAN for this project to transform and manipulate satellite imagery of the area into a proposal for locations of seaweed farming, as well as areas that would be used as the nursery pools and seaweed sport incubation for the red seaweed. then ran it through a variety of other models to help extract information about what type of seaweed could be grown in what location. The new system is in 2 parts, again, diagrammed as always, but the brown kelp for carbon sequestration is grown on a series of kelp elevators, of which they're testing off the coast of Catalina now. In deep water, they grow about 24 inches per day. Once matured, they are then harvested by autonomous drones and then sunk to a depth over 1,000 meters, which then means that it's sequestered. Anything less than that is it rises to the top and then just reintroduces into the carbon cycle. But the second part of the system was growing red seaweed in the shallower areas. It grows about 10 inches per day and is harvested every 6 to 8 weeks. It's then dried, processed, refined in order to maximize the amount of bromoform content. So cows eat about 50 pounds of dry food per day. And then by replacing 1% of this, that's 0.5 pounds of dried seaweed, the change in diet, like strictly from adding bromoform, reduces the cow methane emissions by 87%. And of course, like with either current or proposed system, the cows could be used as like biogas to fuel any other aspect of moving part of the system. So all of this research is based off of research being done at UC Davis right now. One part of how they're testing this as well is that they are still testing the milk and meat for taste afterwards to make sure the bromoform doesn't affect it, which is fascinating. But so this project then, it kind of merged with another project, phytogeography, which was shown here at the Tetrapod Gallery last year. But phytogeography is the study of the geographic distribution of plant species and their influence on the Earth. It implies a new planet-scale shift in the understanding of how and where we exist. From this aggregation of data, phytogeography aims to create an aesthetic interface, making the borders of planetary biology readable. 24 minutes, I'm going so slow. I was really trying to speak slowly because when I'm excited, I talk way too fast and it's a whole situation. So this is a student project. Okay, so like the system design and terraforming isn't just biological. Sometimes it is synthetic, it's artificial. But that doesn't mean it's fake, just that it's designed. So in order to kind of reclaim this human machine intelligence and urban scale automation, become a part of this expanded landscape of life, information, and labor, they are part of the living environment and not a substitute for one. So this project is a part of a Maximum City Studio at UCLA, was looking at a city scale way to remove excess carbon from the atmosphere at scale. And located in Russia due to the different basalt formations that are currently there, moving the landscape in order to better think about wind flow at scale, and then representing it in a little bit too sci-fi of a way, but fine. Or maybe as a project that's like a little bit more human-centered. A studio I co-taught with Casey Ream at Kent State that was looking at how technology in the realms of sensing, simulation, and automation could generate new architectural models for how we inhabit future landscapes. In this project, Diane and Sarah proposed a way to kind of capture excess carbon in the atmosphere and wastewater from the surrounding Cuyahoga River, simultaneously purifying and cleaning Cleveland's polluted air and water through microalgae production. This farming infrastructure system takes the existing toxic site and carves into the land to create our new transformed landscape, where waterways bring the Cuyahoga River water into the site to provide for the algae production. This kind of systems thinking and urban scale affords us as designers the ability to like leverage efficiencies of scale that we normally don't get to play with in order to address the most pressing issues of our time. I'm trying to remember what happens after this. I also just find it very interesting in pairing either waste systems or infrastructure systems that you normally wouldn't live next to with high density housing or just housing in general. as a way of us needing to come to terms with what it might be to live next to or with any of the processes that help us exist. And then a teensy bit about the firm and work more specifically done at Studio MMR, which is our design firm based in LA that was started by me, Galileo Morandi, and Casey Ream. We are deeply committed to the intersection of contemporary technologies with art and design, and we leverage machine vision, data analysis, and interactive simulation to try and shape a more intelligent, responsive, and environmentally conscious future through the application of innovative design strategies. So this project in particular is one of a series. It's like we've done quite a few variations on the Hoax Urbanism project that was started by Casey Ream and has been going on for I'm not sure how long, possibly 10 years. I've only been a part of it for the last couple of years. But we first used Zillow to mine real estate data. Actually, we did end up only using Zillow, but we also were using Redfin and Compass before this, but to mine real estate data for experimenting with artificial intelligence algorithms in an architectural context, and then using convolutional neural networks and related models to generate speculative cityscapes through processes of accretion, to simulate an infinitely tall city block, amplifying the banal through automation to produce a speculative context for architecture. We were generating real estate listings, the interior renders, language associated with the rental properties, speculations on the future cost. Spatial analysis, machine learning, simulations, and digital modeling techniques enable us to unravel the complexity of raw data, possibly from sensors, and then acting as a mediation layer. I haven't looked at this project in a while. It was kind of a fun one. So this project was commissioned by the Guinea Airport Authority in Conakry, Guinea, with the aim of investing in sustainable energy sources. The solar canopy consists of standardized PV panels mounted on a concrete structure. The objective was to obviously provide shade for airport visitors as well as their cars, while simultaneously delivering cost-effective electricity to the site. This was also the first opportunity I had to go back to the energy modeling aspect of my life in the last couple of years, which was fun. I kind of missed it. Okay. And then as the final project that well, actually it's not. I forgot I added two more. I lied to you. So this one is called Neural Net City. It was an exhibition we did for the Seoul Biennale in 2021 that explored the transformation of the existing Seoul city plan based on extrapolating currently proposed or already implemented smart city technology. The specific focus of this transformation is how digital forms of governance and perception allow us to rethink traditional boundaries within cities. These boundaries could include between urban and wilderness, public and private, and the different program types within the city. I think I paused it on accident. As digital sensing and governing become more prevalent, what sorts of alternative thresholds could be established in place of these traditional city designs? The installation is composed of two main pieces, a 1 to 2000 mixed media master plan model and an interactive projective media piece that incorporated 3D sensing and 2D cameras to simulate a contemporary smart city technology. Yeah, essentially the second piece, which will come later in this video. This was more like the analysis and manipulation of the site. The second piece is an interactive exploration of the design opportunities afforded by ubiquitous sensing within the urban environment. Rather than focusing on dystopian tropes usually associated with the pluralistic panopticon embodied by the smart city, the piece leveraged surveillance space opportunistically as a new design space that we could use as architects. This piece also kind of helped me try to branch ideas of the urban scale master plan design and ideas of commodification, views of self, digital commerce, platform design, etc. If we ever get to it, we'll see. I'm like afraid to skip ahead to the video because then it'll say, but I really want you to see the end of it. Because there's a lot of highly deformed faces in it, which are fun. Which might be a different theme of my work, but that's fine. Nope. Okay. I might show it later, we'll see. If I still had it on this computer, we could all just test it out instead, but that got moved to the archive a while ago. So.
Was this the pandemic year?
It was. Yes. So a different type of project working on is, it's like been a long-standing, there are a lot of different versions of these kind of generative chairs using different technologies, whether it's like more procedural or just generative, whether it's more procedural or whether we're trying out a new technology, like these are the Gaussian splats type of models, and we were using NeRFs before this as a way to just kind of, one, figure out how all of these models work, but two, figure out ways of designing and constraining within them. Or this is, we've done a series of, we call them decadent triptychs, so working with a pretty specific in-house process, but for generating large-scale diffusion images, so using the process of really zooming in and adding detail and increasing resolution, starting with something that's maybe 512 by 512 pixels, and by the end of it, seeing how far we could push this. And I wish I had the number for you, but we're definitely above 16,000 by 16,000, so. That's it. Thanks. I think I should hit escape. Should I unplug it? Show something else? Okay. That was like the buckshot approach to everything, because I feel like it was like a little bit of everything, so sorry.
So of course, we always say about science and engineering that it's the hardest thing to communicate, right, to everyone else. So I see this as a great opportunity for that, and it certainly is entertaining. It makes me wonder how many of you there actually are, to cycle through that much. And you are in a unique position, I think, because you're straddling those two worlds of art and engineering, and that's a place where we see lots of breakthroughs throughout human history. And you're presenting to us that AI is one of the tools, the methods that a person on either end of that spectrum or that lies somewhere in between can use to not just explore or think about solving problems, but also present problems in other ways. Because, there's a lot of information in here that, to use a cow pun, is not readily digestible.
Yes.
Right?
10 out of 10. Thanks for that.
AI, however, is like a series of 5 stomachs, right? And it's a series of being able to interpolate and put things and make things together. And so what comes out then, it's better than Burbs, right? The seaweed, does it imbue a umami kind of
it does.
flavor into the
If you've ever had, like we eat
that
it.
was
This
my question, by the way.
we actually do. Many of you might have consumed this without even knowing, because this particular red seaweed, and the name is escaping me right now, but I can look it up later, is a lot of what gets added to like traditional Hawaiian poke. If you've ever had that, there's like little flecks of like this purpley red seaweed, and that's the same seaweed. because there's obviously definitely a conversation about ethics and feeding cows something that maybe they normally wouldn't. So the amount of testing that goes into that is, one of them was like, yeah, it's safe for us to eat also. We just generate less methane, I think.
It's also great to see that the intergenerational reach of the projects is good. Yeah.
I mean, some projects are too big for, I don't know. Yeah.
I mean, it seems to me that even though like there are instances where you said, for example, you know, you're maybe even intentionally using a bad model, right? That you're trying to bring together such a diversity of different information elements, right? But I think the sort of social commentary that your projects take on is always rather precise, right? In terms of like what you're trying to highlight and expose to the conversation. And I wonder, you know, if you have seen, at least with some of the artwork installations, what the response of the audiences are in terms of like kind of what you're trying to highlight and how they decipher it, let's say.
Interesting. Again, like how people have responded to it is probably one of the, it's just another aspect in the study of the work, right? Like how people react to it or what they gain from it is like a part of the feedback loop into like the next iteration of whatever, because nothing exists by itself. Everything is a part of how we consume it or understand it. I think specifically with the machinic reflections piece, which I might rename the vanity, who knows. That one was very interesting. One, because it was the first project that I showed that was not for an audience of people who understood, one, anything about me, two, anything about machine learning. It was in a very traditional like art context, and the people that came, this was very new in terms of just an interactive piece, but also in terms of what it was trying to do. That's also kind of why in the piece I wanted to show the user the code as it was running through, because it was important for them to understand that they could at least have a window into that insight. I think what I understood from that is that the language of me explaining it was still very important, and that not for everyone, but for many people. And I think the first person that looked at it when he got lobbyist, and he was the one that was so unhappy. And he was like, I can't believe you're doing this. Like, I can't believe I got lobbyist. And I was like, yeah, well, okay. Like, I'm like, glad you're mad. Like, that's interesting. Like, let's unpack that. I think I lost sight of your question already, but I think that yeah, for me, I think looking at how other people experience it is very important. This also comes with students, because a lot of the students that I work with have, again, like backgrounds in, I almost want to say like capital A architecture. And so then by forcing them, and me and everyone else, in order to think about this at a completely different scale, through a lens of which I think often people say is like, no, that's for the engineer to figure out. Like, no, that's for someone else. And I'm kind of like, no, like we can also kind of take control of these things as well. We don't need to shed that liability. Like, that's something that I think architects could do. That's a very interesting conversation as well.
There's a question in the audio
Hilarious, I can see. Yeah, thanks a lot, Laura. I'm curious. I mean, like the huge kind of tirade of projects that you showed are each kind of beautiful in their own way. I'm curious about ideas of beauty and kind of love and humor and joy in the projects, because they all kind of fall into this. And I mean, you kind of showed us your intertwined background as well. I'm wondering towards the side of aesthetics and the kind of idea of beauty in the projects, because they always have this science fiction kind of pseudo-scientific data visualization aesthetic. And then I'm wondering, is it essential for the projects to look like that for you? How do you kind of see that? For example, this chair that you showed us, you know, what would be a register of talking about it beyond the kind of technique of production?
That is a very good question, and one that I am definitely still grappling with, because yes, there is definitely that overarching aesthetic theme of most of my work. I was actually talking to a friend and colleague the other day, and we were talking about branding, which I think this is a part of that conversation. And trying to figure out, when you're working with these diffusion models, when you're talking about prompt engineering, when we're talking about intellectual property, how to make something yours and like your style, and what does that even mean? How do you find that? And he was talking about it in terms of his work and how he needs to figure out a new language for this series he's working on. And for me, I was like, I don't have one. I need to figure out what my language even is. Like, what am I interested in? Like, what is beauty? And he was like, are you serious? It's very obvious to me when I see your work that there's like a line running through this and that it's very obviously yours. And like, I didn't show a lot of the fashion images, but the fashion one is like technical fashion, like, yeah, for sure. So I think I'm happy that there's like an aesthetic theme over all of it. Do I think that it's important? I think right now it is important for me in that maybe it's tied to the branding aspect of it. Maybe it's still important to have that window into the back end of how things are working, because as an example, again, tied to the machinic reflections piece, another thing I had that went along with that was I had actually printed out the data set and put it in a binder on the table next to it, so people could flip through and kind of look at the different categories and the faces associated with it. And that was a very vulnerable moment for me. I was like, but this is the project, like this is the intelligence, like you don't understand, like that, sure, this is how you might interface with it, but like this is terrifying to let someone look through and get access to. So yeah, I think that for me it's just important to have that window into that back end of it. I also am happy that you read the sense of humor that comes through that, because if you can't tell, I have a lot of fun in doing all of this. Because, of course, I wouldn't be doing it if I didn't, but I'm glad that comes through.
It's clear that the joy is incredibly clear, but then that's what I'm kind of troubled by, you know, how. So you have this kind of scientific projects with the students, and then they somehow, even with the students, they fall into a genre of imagery that goes directly with kind of fake news and propaganda images around climate change and this and that. You know, how to kind of grapple with that? Is it, because then if that's a stance against kind of the destructive practices of the planet, then it falls into the same genres that they perpetuate their propaganda, you know? And not that you have to invent a new genre of imagery to fight that, but how could we possibly play with that? And I have no answers, huh? So I'm just
No,
asking.
it's a very interesting point, and I definitely need to think about that a little bit more, but I would say that I am very interested in the language of propaganda as a way of talking about anything, and it doesn't matter which side. I think that propaganda is fascinating and very human. That's interesting.
I loved your presentation. I love that there's an artistic flow and joy through it. It makes me want to learn more about the work behind it. It stimulates my curiosity. And you mentioned a couple of times that you had this project and the anxiety that you have about having all these different classifications. And I'm wondering if you find that that's maybe what makes your work really exciting, is the interplay between the different disciplines and being able to maybe step back in and out of different ones, and maybe that makes your message more accessible. I don't know.
I think it definitely affords me a flexibility that maybe others don't feel that they could embrace. And I really enjoy that, and I take that freedom very seriously. So yes, I think that that makes sense. But I also think that it does add some complexity in terms of interfacing with the rest of society in certain ways, or which isn't a bad thing. But yes. Thanks.
Sorry, me again. I really, really enjoyed your talk, and as others have mentioned, I really appreciated the way that you talked about the pedagogical aspect of that. You know, I also work with a lot of students who have never in any way, shape, or form experienced the process of coding or designing, and so I appreciate that. But the question I have actually relates to Adil's question about propaganda, and also working within these capitalist systems. So kind of to continue from my question from last time, from a philosophical perspective, I would argue that a lot of these systems of discretization or compression are actually incentivized by capitalism, right? And I love your work where you're trying to actually repair a lot of the harms that have come from those systems. So I love the example about the cows, right, where you're saying, okay, based upon these models where we're taking this discretized data and we're saying, okay, if you feed them, you know, this mutton was half of a pound of seaweed a day, you can have this massive positive effect. And yet they're looking at the analog qualia of taste of the meat, that experiential aspect, and then meat companies and producers are coming in and discretizing that into a capitalist system that they can use to maximize profits. And so I guess what I'm asking is, how do we engage with these tools in reparative ways and supersede these capitalistic, you know, lids that they're placing on our attempts to subvert or supersede them?
Yeah. Well, I think that education plays a part in terms of never taking anything at face value and needing to understand where everything, well, trying to figure out where everything comes from, and, you know, but with any of these systems, with literally any of these projects, everything is so much more complicated than I could even understand or hope to. I think a project that I just started researching was talking, which I think kind of exemplifies this idea exactly, and maybe explains how I'm also just not sure and still trying to think through a lot of these things. But so there's a lithium deposit in the US, and there's the will to build a lithium mine on top of that. The issue being that there's a specific type of flower that grows there and only there, and it's protected as an endangered flower. And so, you know, you're playing with these ideas of like, oh, well, we're trying to electrify the grid, we're trying to get EVs everywhere, you know, in order to reduce carbon emissions, but at what cost? Like, what do you disrupt within, especially like when it comes to mining and heavy mineral, like, the needing to think through the history of everything gets more complicated. Like, sure, you drive, you know, a Tesla, but where does that all come from? And the life cycle cost analysis of things, which is something you can do, and I'm sure you can then make those decisions, but now you've spent 3 years researching this and you don't have a car because you don't know what to buy or whatever. But okay, so when it comes to the lithium mine and the flower, what really interested me in this story was that the owners and operators of the potential mine, I think they're based out of Australia, but I'm not sure, have funded the single biggest biolab in order to try and figure out how to grow and increase the population of that flower so that it's no longer on the endangered species list. And to me, that is fascinating, because now you have someone who's on the mining side of, and if you're just thinking about the world in terms of like black and white, good and evil, you're like, oh no, like mining bad. But, you know, spending insane amounts of money that normally would not be given to any university in order to study, in order to do something in terms of like saving this population of a flower, and like how complex that is. But also it's like, this entire conversation is so, even though we're talking about the flower, it's still so human-centered, and that like what we're caring about is really like we still get access to the lithium in order to do this. And so a part of even sending the scale out so much further is like maybe trying to not center us in many ways, and like thinking about it from a different target. You know, I don't know. I find that interesting. I'm not even sure that answered anything, but it is what I'm thinking about. Yeah.
Very short question. If you imagine that your work was textual, that it was text-based, what kind of genre would you put yourself in?
Oh no! I have to categorize myself. It's my worst fear.
I'm sorry if it's offending.
No, I'm just laughing. Okay, so I'm in, questions I was also asking about the ideas of language on the last project, because I find it so interesting that so much of the work we're doing in AI right now is language-based, but it also makes so much sense, because how else do you explain anything? How else do you get any sort of anything? Like, the importance of the feedback loop from my projects is when having to talk about it through someone else. And language is so complicated and so nuanced. It changes so much depending on where you are or what era you're in. I'm trying to dance around this a lot because I have no idea. And I think I would need to find out what your genres are, and I would choose from one of them.
But I also think that there's a very humanistic aspect to the work, right, where there's a very sort of serious side. We're looking at climate change and coefficients. There's also this very human side that's about, and I think this comes from the pedagogy of the students, that they have a sort of naivete, right, that exists and says, I want to map Christmas spirit, right? I think that's the thing that's like, so, because I think like if we only focus on this, then we lose sight of the joys and like the taste of meat, right, which is important, right, and that kind of all filters in. And I think somehow there's this sort of connection or feedback loop between all these projects that you're starting to kind of construct, I think.
Yeah,
it's really interesting.
I think so too. Yeah, that was a fun one. She was also the youngest one in the group at 13. So I was like, this is wild. I don't know, that was an interesting experience. But, yeah.
I could offer science journalism in a way. There's a whole series of books that are out there that take really difficult topics to deal with and put them into language that we all read. And usually it's interwoven with stories and anecdotes, pieces of history, projections into the future, bits of pleasure, and tales of pain. But it's always about conveying the science behind it, right? The latest research. So maybe that's your genre.
Thank you, I appreciate that. I had joked earlier that one of the reasons I went into engineering is because I didn't like writing, and that I wasn't very good at English, so I'm gonna hold on to that one. So, yeah.
I'm actually looking at your work also through the lens of previous presentation, and I was thinking especially, and by the way, parenthesis, I was thinking also of the powers of pen as a pedagogical tool. Students always find it fascinating, and there's a little bit of that happening here as well. But what I wanted to say was slightly different. I was thinking about the proxy faces that the students did. And there's a lot of connections here to the Victorian era, as well as contemporary art, like I'm thinking of Rebecca Horn, who maybe was a reference there. So if we use your corpus, is there a way that we can look at these artifacts more as historically, culturally formed, rather than, I'm not actually quite certain, maybe you talk a little bit about how they came about, but maybe they come about as a way to understand the Victorian era, for example, or a different period.
I find that very interesting. I would definitely love to extend this project. We did a little bit, this is a 10-week project with the students who had never used any sort of machine learning before. So we got to dive a little bit into the history of some masks. We obviously talked about Victorian masks. We also were talking a lot about the dancers in China that changed their mask without using their hands, and like the importance of switching characters within that, as well as a range of others, including like the Japanese demon masks, or like the purpose of a mask even, whether it's to hide or to show something else, to scare something, have you. I'm obsessed with the data set and the ability to go through it. So if you want to collaborate on something and folks, like you let me know, I will get you that data set that you need, and that's fine. Yeah, I don't really have anything else besides, yes, I find that super interesting, and I think that that's definitely something to be explored a little bit more. I think a lot of the masks that we were working with and the students were designing, and one interesting conversation that came out of that was the importance of needing to possibly still look like a human to us, but not to the model, or to not look like a human to us, but to the model, and like making sure that that was different, that you didn't just read as a bird and look like a bird. Which then made you kind of refocus on ideas of like, you know, fashion, makeup, all of that, and how we represent ourselves in daily life outside of thinking about machine learning, but just through adornment. But yeah. That's it. Okay, cool.
All right, apparently today my role is the human curtain call. But we're gonna take a quick 15-minute break, coffee break, and then we'll start again at 5 p.m. for the last final panelist.
Okay, Adil, do you want to go ahead? And
Sure. Okay. So our final panelist for sculpting images is Ricardo Villa. Ricardo is a postdoc researcher for the Department of Architecture Theory and Philosophy of Technics at the Vienna University of Technology and a scientific assistant for the Chair of Digital Architectonics at ETH. He holds a master's degree in architecture from the Polytechnic University of Milan, where he graduated cum laude with a dissertation about the contemporary mutations of the architectural profession. In 2022, he obtained his PhD with distinction with a dissertation on the role of images in architecture, so very fitting in the age of information. His interest revolves around images and techniques at large under a spectrum of investigation that spans from architecture and ethics to mathematics and theology. Ricardo's talk is titled Digital Epos. The stage is yours. Go ahead.
Thanks, Adil. Thanks Carla, thanks Lee, and thanks Nicola for having invited me for a second time. I'm very honored. And I have to say that the first time I was here 1 year ago, I put myself a bit into challenge. I thought, okay, what if I come to a conference in which, let's say, the main topic is AI, and I try to talk about AI by talking about orthodox icons. So I said, okay, they're never going to invite me again, and here I am. So for this time, I wanted to challenge myself again, and so I'm talking about epos. But so just a recap about last year, so to continue the talk. So why did I talk about icons? So what was my interest? So this is linked to also what I, let's say, investigated in my PhD. So the fact is that my interest in the icon is the fact that it's an autonomous image, or at least an image that is not merely the picturing of a pre-existing object or of a pre-existing experience, but rather acts like a screen. So an image able to bridge incommensurable domains, mundane and divine, matter and light, energy and information. This is a bit a kind of a recap. And so the icon and more at large the image become then a sort of informational currency. So in resonance with my PhD dissertation that hopefully will be available in the next weeks in Berkhäuser website. So you're invited to read it. So an understanding of an image as something emancipated from object, so a kind of non-referential image. But not just that, so not just emancipated from object, but also emancipated from subject. So according to a certain tradition, and here I was quoting Pavel Florensky, which is a, I think, Russian polymath, the icon is an image in which the author does not really matter. So the author that paints the image does not really matter. So the author cannot really claim intellectual ownership over this kind of image. And the icon is described by Florensky is a fitting model, for precisely for this. So the painter does not author create the icon, but similarly, if you want to, Michelangelo's notion of sculpture must simply paint what is already there. So it says, just as the spiritual word needs copists, so does the spiritual image need someone to reproduce the icon, the ikoniki copists. So the author here is simply like a copist, so not a creator, but more like an editor or a publisher or a curator of images. So it's not really a matter of creation, but of invention, also in the Latin sense of invenire, so finding something which is already there. And another of the paradigm that I like to think of the image through was the one of the garden. So, so both the image and the icon are in this sense an encounter between two different intelligences. So it could be human and divine, but also human and natural, for instance. So again, not in the sense of a creation, but an inventiveness that works through, in this case, a naturing or an engendering. The garden is, needs to have, let's say, it's a kind of contract between a human intelligence and a natural intelligence. So it needs the activity of both to work. So this was, let's say, in very big lines, what I laid out last year. What happened in the meantime, so this is like is you know it well. This, amongst other things, also this happened. So, and I was quite, let's say, happy to a certain extent to see the development of images in these terms, because there are, in my understanding, some similarities to what I was interested in the icon. So some features that interest me in the icon are present also there. So for example, it is an image that has no experiential references, but that sources its form from a domain which is incommensurable to its own, the one of scripture and of text, so of the textual input. And an image in which the author does not own, that is not owned by an author, but in which the author draws from a collection of sources, so a kind of canon that is cultivated in order to produce this image. So an image that somehow contradicts the usual paradigm of copy and original, and just affirms the one of, let's say, what we call absolute copies. So not a paradigm which is not linear, but probabilistic, or more weathery, as we will see further on. So, but today, as I said, I will not talk about images. Today, I want to shift from the image to the word, and this is a part of the work that I'm doing as a follow-up on my PhD, and so it's still, let's say, a work in progress, so taking again with a grain of salt, and I'm happy to hear what you might think about it. There are some experimental lines you will see. So, and yeah, so for shift from image to word, and if the topic of the last year was how can we think of the image in the information age, which was also the topic of my PhD, the topic of today would say, how can we think of writing, and can this be similar in some way as the way I was thinking of images? There are many sources of inspiration for this shift, and one of these sources was this reading that is a book entitled Il copista come autore, The Copist as an Author, which is a book mostly about medieval and ancient philology, but that nevertheless brings an assumption that I think is interesting for today. The title is already a provocation, so how can the copist be an author if he copies something which is already authored by someone else? Here I just translated for your convenience the table of contents. So the book, as you see, contains several provocations. So what is the original, questioning the idea of the original, the copist as an author, the archetype as a modest surrogate, and some other interesting tracts like the art of extracting extracts, or the chapter on scroll and codices that somehow highlights what happens between writing in scrolls, which are always rearrangeable, and the introduction of the codex that instead sets a kind of a fixed order and removes the necessity of what today we would call hyperlinks between the scrolls that needed all the time to refer to the other scrolls in order to declare the order of the chapters. And there is a chapter of this book which is in particular interest for me today, which is the one of the library book, so the Libro Biblioteca, which is about the idea that a book itself could be or could act like a library. So but not in the sense of an anthology, so not in sort of a discrete collection of text, nor of an encyclopedia, so that would claim, let's say, general validity, but a book that somehow integrates other books, and by doing so acts like a library. Within this chapter, Camphora quotes a passage from Edward Gibbon's History of the Decline and Fall of the Roman Empire, in which the English historian talks about the loss of books and the literary sources of history in events such as the burning of Alexandria's library. And here I'm just going to quote the passage of Gibbon's, which is, "Many curious and interesting facts are buried in oblivion. The three great historians of Rome have been transmitted to our hands in a mutilated state, and we are deprived of many pleasing compositions of the lyric, iambic, and dramatic poetry of the Greeks. Yet we should gratefully remember that the mischances of time and accident have spared the classic works of which the suffrage of antiquity has adjudged the first place of genius and glories. The teachers of ancient knowledge, who are still extant, had perused and compared the writing of their predecessors, nor it can be fairly presumed that any important truth, any useful discovery in art or nature, has been snatched away from the curiosity of the modern age." So the point of Gibbon is that, yes, many texts have been lost. There's been so events like the burning of the Library of Alexandria is tragic, but in the end, eventually, we should nevertheless be happy since these mischances and accidents spared the classics, so the important text for us. This has been spared. And then those classes are such precisely because antiquity has judged it worthy of being preserved, so copied in many more exemplars that would then more likely survive such kind of accidents. So it can be thus presumed that nothing of relevance can be lost, has been really lost. So there is almost an evolutionary, if you want, idea in Gibbon's statement, so one in which irrelevant or redundant texts get automatically discarded by a sort of natural or historical selection. And this is precisely what Camphora picks up in this book, by commenting with these lines, in which it says, it is the most serene view one can have of tradition, of the way texts are preserved. So much has been lost, but the great books, which were books of books, worked for us. They drained and put together what was worth preserving of an entire written and scientific civilization. So what I find interesting here, besides, let's say, if you want a philological interest in this kind of phenomena, is that there is a suggestion that there is a kind of intelligence at work in the classics. So besides this kind of evolutionary force implied in the classification that works, if you want, horizontally by selection and exclusion, also the classics are precisely in the sense that there is a kind of exclusivity to them. What Camphora seems to address is a kind of vertical axis that seeks to integrate or preserve. So these books that are the ones that are somehow kept, of course, makes it so that the other are excluded, but they also manage to, they're the ones that are kept because they are the ones that still preserve what has been excluded. And Gibbon's quote points precisely the attention on that. So the loss of the Library of Alexandria becomes almost a relief. So it is a tragic loss, only if one does not consider how these kind of library books, as Camphora calls them, work. And the library book is precisely a book of books. So by acting as a kind of ark that preserves what is lost, it becomes what Camphora calls also a great book. So its greatness, we can speculate, derives from the fact that in comparison to it, the sources that get lost become also redundant and hence negligible. So according to Camphora, here I quote again, the library book is the book that seeks to encapsulate, if not all knowledge, at least much of it, and ends up being enjoyed as a single self-sufficient book. And he quotes as examples of these library books, two main examples. He says one is the Bible and the other is Homer. So library books, great books, books of books, these are not merely anthologies. They are plastic, they sculpt the source, they absorb as an organic wall. And at the same time, they're not encyclopedias because they are self-sufficient. They are endowed with a kind of objectualities, whereas encyclopedias always depend on knowledge as something exterior to them. So there, I would say let's say to pick up a usual word of game of words that I share also with Carla. They are not just tools; they are also instruments. So these books, as I was saying, embody some kind of intelligence. They work for us, Camphora writes. They are not simply a representation of a certain knowledge, but they are manifestation of what we would call a sort of genius. And here, I would like to come again to draw a parallel with between not anymore the image and the garden, but the book and the garden. So this is Gilles Clément, Gardens, Landscape, and Nature's Genius, which is his inaugural lecture of the Collège de France, in which there is, let's say, a kind of architectonic disposition within the garden. So the garden is an articulation of incommensurable domains, the subjective one of landscape and the objective one of environments, and is a kind of contract with nature as an expression of her genius, the genius of nature. So, and perhaps we can stretch it forward and make a parallel or an analogy between garden and nature's genius and intellect and intelligence, which was something which was somehow questioning recently. So what is the difference between intellect and intelligence, and what if the difference is something similar, or more than a different relationship, is something similar to what happens between garden and this kind of natural intelligence? So the garden and intellect, in the sense, organize materially and tangibly what would be instead an impalpable agency. So in the intellect, faculties are a matter of architecture on the way it is organized, like in the garden. It is also a matter of architecture in the way this kind of natural genius becomes organized and visible. But then I was talking about writing, and I took like a kind of side road. So let's go back to writing. What about writing? So we all know that at some point there was the introduction of printing, and now we shift from the printed book to the digital text. And the way I would like to address the digital text is not just a matter of, let's say, hypertext, but in this paradigm, so in the confluence between digital and digitable. So there is an interesting quality I understand let's say, the digital is the fact that the digital is always also digitable. So it's always open to this kind of constant editability. No? So if we take Latin motto, which says verba volant scripta manent, so spoken words fly, written ones remain, no? They're saying so, because of course what you speak is never really traced. Today I would say scripta volant, no? So writing has a kind of volatility of permanent editability. So there's a kind of confluence of actuality and potency, to speak in Aristotelian terms. And why am I so interested in that is because the confluence of digital and digitable challenges the linear conception of time. So with the digitable, I would say we shift from a thermodynamic understanding of entropy, in which entropy is a notion that serves to distinguish the past from the future, if you want, through heat, to a quantum physical and informational notion of entropy, which is always, let's say, immanent to reality itself. It's not just about the narrow of time. We can discuss this later. I will not bother you too much on entropy, but we can also, if you have questions, we can debate it later. And yeah, so this challenges somehow this kind of linearity of time, which is something that, for instance, is described, if you like, by Victor Hugo's Notre Dame de Paris. No? So if you're familiar with the novel, there's this famous phrase that says, "Ceci tuera cela." No? This will kill that, meaning that architecture will be killed by the printed book, because the printed book will be able to replace this kind of figurative function of architecture. So there's a kind of paradigm of linear substitution or project or a progress. So you have architecture, the printed book, and now we can add the computer. So in which everything is kind of guided by necessity or by fatality. And I think within the digital is precisely this paradigm that gets challenged. So this is what interests me. So how to frame this new paradigm in terms of writing, and how to shift, as I was saying, to a thermodynamic, to a quantum mechanical notion of entropy. A suggestion, I would say, comes from the ambiguity present in some Romance languages. So in time itself, in Romance languages, is not distinguished. There's no distinction between weather and time, but it's always temp or tempo. And what I found interesting is that this kind of ambiguity is also present in the notion of writing. So in English, you distinguish between writing and scripture. And in French, you have écriture, or les écritures, as well as in Italian. So, and what I found interesting in these two concepts is that, so if you want, deals with chance, so with something foreign as something objective, then something similar is done by the scriptures, if you want, in the sense of the sacred text, that deal with an agency that is impersonal. So they're also written by or reported by authors, but they're not, it's an agency that is impersonal, if you want. Now, let's go to the title of my contribution today, which is about epos. So why, what about epos? Why epos? So this is a question that I investigated in the course of the last semester in a course for PhDs, in which also Agostino took part. My interest is like is as, let's say, three main points in epos. So the first one is that Epic poems are one of the main examples of what Kamphora would describe of great books, so books of books. So they integrate and collect knowledge and foreign sources by, in the way that I was describing, precisely in this kind of intelligent way. Secondly, they do not so linearly, like the encyclopedia or the anthology, for instance, but in a more weathery, climatic way. So it's not, epos is not the same as logos in that sense. It's something different. It's something more that has to do with rhapsody, with a waving. And the third reason is because even if they're not, let's say, sacred texts, they're not scriptures, they nevertheless contain a kind of contractual element with an intangible agency, or with what I would call a foreign intelligence. So in the first lines of the epic poems, the ones from Homer, for instance, there is always a nod to the muse or to the goddess, and the epic poem is the result of this, let's say, contract with the muse. We ask the muse to tell us the story. So I found this as interesting guidelines for choosing epos as a topic, let's say. So, like the scriptures, epos is a book of books that organize in a tangible and readable body a dealing, a contract, or a covenant with an intelligence or a genius that is alien to the one that reads. And like the scriptures that are impersonally written, so Homer is not the name of a real person, but a persona, masks for this impersonal and diffused rhapsodic effort. And let's talk about rhapsody. So rhapsody, in terms of epic poetry, is this raptain, is this kind of weaving together. So the scripture writing or epos is not a matter of mere input and output, but a matter of weaving. And here we see the figure of Penelope in the Odyssey. That's she weaves this web during the day and unweaves it at night. So it's a kind of mise en abîme or precisely of what the epos does. So weaved and unweaved, raveled and unraveled. So there's these two kind of movements that are there. But this is not just a picture. Also, what I would like to bring here is Arendt's readings of Homeric poems in her text Introduction into Politics, where she writes, Homer celebrates this war of annihilation, and precisely by doing so, he undoes this very annihilation. So there are also as well these two bridges, but that express these very contrasting movements, but at the same time they are very effective. So then it's a kind of picture that is not representative, but is kind of operative, precisely like the one of the icon. And Arendt's reading is interesting here because to her, epos is a literary space. So it's not just a kind of, it's not just a matter of literature, but also of space. Because the one of epos, the space of epos, let's say, the literary space of epos reflects the architectural one of the polis. So if we follow her reading, we discover that intelligence encoded in the epos is the political one of the Greek city-state. So the equality granted to the heroes as peers in the Iliad and in the Odyssey is homothetical, is comparable to the equality of the citizens in the polis. So in that sense, the battlefield is the mirror of the agora. But this equality is not an equality as we understand it today, it's not absolute. The one of the polis, and consequently of the epos, is a constructed equality, not just metaphorically, but an equality constructed in concrete architectural terms. Isonomia is the equal right of the citizens of the polis that manifests itself in a special form. It is bound to the wall of the polis and abstracted from the real necessity, so the economical domain. And this really is also concrete as the oikos and the collection of the household. The political space of the agora in Arendt's reading is the negative one of the economical, a bit like in an Olimap. She wrote, a necessity is precisely what politics is not. In fact, it begins where the realm of material necessity and physical brute force ends. So necessity is somehow absorbed by the realm of the household so that the political can deal with the contingent. Necessity and contingency, economical and politics, we could say, are thus weaved together in the architectural fabric of the city. So two kinds of speech coexists in this space, in the space of the polis. The declarative one, we could call it, of the polis, and the imperative one of the oikos, of the economic. So we have a kind of more programmatic kind of speech and a more kind of, if you want, coding kind of speech here. I also try to think of this in terms of, let's say, imperative programming and declarative coding. So And the one instituted by the polis is a speech that goes beyond economic necessity, transcends it. So isonomia is the frame in which this speech can be measured without being the object of a political calculation. So this connection between polis and epos, or between epos and the declarative coding. So this is how I thought about it. And like the polis, the epos is, if you want, the garden in which a kind of intelligence can speak. So they all are, in my understanding, so these are all kind of models that I find fascinating: the garden, the polis, the epos, because precisely they encrypt or they kind of articulate this dealing with an intelligence which is, let's say, alien to whomever is reading or who is speaking. You know? So there's something else. Yeah, so the fact that the political speech, so the speech within the polis, is emancipated from necessity and economy, does not mean that it's merely contingent, subjective kind of speech, but is also a kind of public objectivity in the speech, provided precisely by the fact that the isonomy of the polis allows for measuring one speech against the other. Like in the epos, the deeds of the heroes are measured against each other. And it is, however, not a measurement that happens against an absolute scale, but in which the scale is immanent to the measurement itself. So it is a matter of proportion rather than ratio. So like the polis, epos is a space or a domain in which words can be measured against each other. And this quality connects again epos precisely to the polis as a political space, so a space in which the deeds can be measured in form of words or speech. So the connection between epos and polis is one with the connection, if you want, between deeds and words, or gestures and words. And here, just a little, let's say, glimpse of Wittgenstein, which he says architecture is a gesture, so something that transcends the economical needs and imperative purposefulness, and yet does not deny them. So these are, let's say, three, to summarize, three chapters to come to a kind of conclusion. So we had the autonomy of the copy, which was my interest in the image, a quest for a kind of more weathery kind of writing, a kind of écriture temps, so a writing which is not just logocentric or linear, but goes more with the weather, so resonates with the idea of the digitable. And then the epos as perhaps a model to articulate and address this. How to do so? So the occasion to, let's say, test this kind of model that I was building in the last semester came with a proposal to work on a publication celebrating the 100th birthday of Fritz Haller. Haller is a Swiss architect mostly known for the USM Haller modular system, but whose work extends way beyond the scale of interior design. And most importantly, Haller is someone that conceives of architecture as what he would call a weaving or a joining of things after his master, Konrad Wachsmann. And also that has, is one of the first that has integrated a certain certain application of digital technology into building. So how to write about Haller? So how to make a book about Haller? This was my question. So, and how to do it so in the age of the digitable, so to say. So a way to celebrate such figure would have been to make a traditional history books, no? So a kind of analytical approach in which one or more contributors take on different aspects of the object of study. So we could have an essay to contextualize the figure, so to explain his Swissness, for instance, one on his furniture, an essay on the notion of system according to him, another on his idea of the total city, and so on. But this, I would say, would be a kind of classic or thermodynamic, if you want, approach to historiography. So now that Haller is dead, it can be considered as a closed system to analyze and contextualize within the instruments of today. So this would have been an effort to make a picture of Haller as closer as possible with what he really was. So this idea of the original again, no? So as understandable as possible to the contemporary mindset, no? And then entropy, if you want here, the differential, it would be then the differential between the past and the present. as something that would need to be brought to the minimum. So this would be a paradigm of optimization, no? The observation of the past has to be optimized as much as possible, so the kind of discrepancy between our reading of today and what he really was should have been brought to the minimum. So, but this I would say is a way of approaching history and historiography as a sort of death mask, so something that has to do with inorganic matter that does not change, that is concluded and can be thus observed and determined once and for all. But I think, so with the challenge for me as a theorist and a part as an historian, would be then the challenge of the digital, is that precisely that is not that, it's lively. So being digital, being digitable, the digital is discrete, but also open to continuous change. And this is also the challenge of the quantum, so time is not an arrow. So this is then, many of you who would already recognize the natural communication scheme from Elias Zafiris, but so not to make a death mask, but to talk to Haller, so to say, to sound his intelligence on something foreign, alien to us, this would be my interest. So not to neutralize it, not to try to neutralize the entropy, but to affirm it and affirm this distance as an instrument precisely of work. So to bridge, again, intelligence and intellect, and not to make a graveyard for it, but of garden. And here, again, we have these two bridges, one of waving and unweaving, like Penelope, or annihilation and its celebration, like in Arendt. But then, how to articulate this joining? So, and here I also, where I found epos could be a fruitful paradigm, I borrowed from, let's say, the figures of epos. One is ekphrasis. So ekphrasis is a technique that waves together text and image in a way which is not merely referential or representational, but more operational. So the ekphrasis is a way to describe an object through text and evoke this object through the text. And then that works also with these two bridges. So while focusing on a specific object, so working by exclusion, it integrates a word. So here it is the shield of Achilles, in which a whole scene, a whole cosmos is depicted. So by exclusion, it also works with integration, precisely like the great books. So it's completely is not epistemic or ontological, it's technical or architecture or architectonic. The other instrument that I borrowed is precisely the one of rhapsody, so the waving together of things. So not a matter of collage or putting things together, not a putting or addressing things as discrete parts, but a way to address things precisely in their duality between discreteness and continuous. So, and which is something that, yeah, here you see the 10 books of architecture by Vitruvius, which is precisely a way, in my understanding, to articulate discreteness and continuity in that way, because they are 10, not just because it's a partition, but because they somehow embody a mathematical model, which is the one of the tetractys. And I try to reproduce this double articulation in the organization of the project. So on one hand, we have a mathematics of joinings, Mathematik des Fügens, and a joining of things. So there is a part of joining which has to do with rhapsody, with waving, and a part of things which has to do with ekphrasis. So the first book would be Mathematics of Joining, Mathematik des Fügens, is a rhapsodic book written impersonally and waved together through computational instruments. So I'm working on this with Professor Ludger Hoverstadt. And the idea is precisely to write a book of books. So to use computational instruments to address a huge amount of books and to try to be the, let's say, the editors or the curator of this book, not the authors, by bringing together and waving together what is there in this incredible amount of sources. The other one is, let's say, the specular opposite to it, the joining of things. It would be an ekphrastic book in which different voices address through their personal interests, the different objects, the different scales of other works. So it takes exactly the opposite paradigm. So then I go towards the conclusion. This would be then hopefully soon a book about epos and architecture, so in which I will develop more the theory behind this, and with also a collection of essays from some brilliant students of ETH and of TU. So that was it for today. Thank you.
So, thank you very much. A couple things that you mentioned that kind of triggered a couple things that I'm curious about. I appreciated. So there was a way that I started to think when you mentioned polis and the oikonomia and isonomia. I was wondering, so, and then with your link to the Hannah Arendt, there were a series of things that came to mind that kind of, I think, reflect on some of the questions we were asking earlier, or at least my interpretation of what those questions were. And I was wondering how we could think, or so if we could think of, because I've been trying to think, what is this, whether it's a manifold or it's a latent space that is somehow constituted by machine learning algorithms and corpuses of different kinds. And if that isn't, in a way, a kind of oikonomia that is articulated, and then what would be, at least for ChatGPT, but probably also for Midjourney, would be a kind of, which would be the art of the prompt, would be this vertical isonomia. When you get closer, when you emancipate from the tyranny of the household, as Arendt calls the oikonomia, into the freedom of the polis, so that in the polis you are able to speak in an orthogonal fashion, or perhaps with the imaginary. And if you remain entirely in, so this becomes almost an ethical, well, I would then also build another symmetry with, in the isonomia, it becomes an ethical question, or a question of ethics, whereas in the oikonomia, it's a question of morals. So it becomes there's a risk in the kind of total system of the algorithm that has articulated everything and placed everything relative to everything else, of a kind of tyrannical system. So in a kind of on the one hand, and perhaps an ontology, but also maybe almost an epistemology if it imposes a kind of way of looking at it. So that, I guess I'm curious to see if that fits with the way you're looking at some of those terms.
Yeah, totally. I know. I agree that it fits more. It's more a kind of epistemology than an ontology. But what I think it's important is, because often like this kind of two paradigm, if you want the economic one and the political one, you could see them as antinomies, no? So that one, you have either to affirm one or the other. And I think what for me was interesting was the promise of these models, so the one of isonomia, the one of the garden, etc., is that, and I think this also applies to the computational instruments, is that it's not an either or, so it's a way to integrate one with the other. So that's also the idea of the books, no? So it works by exclusion, but with next to the exclusion there is also an integration. So the two things are happening in parallel, and one does not exclude the other. So it's not if you want a logical paradigm of either or, no? So if it's not that, then it's the other. So both of the things are happening at the same time, and they're waved together. So these two movements are waved together, and then that is how it becomes a matter of architectonics. So how to weave these things together, how to make a case, how to construct this model so that these two movements are have their own can be accommodated, no? And I think this is let's say my interest in looking at this kind of all disparate models or very diverse models, and I found it always very productive until now to address all these kind of things. Yeah.
Maybe just a follow-up question. How would we think differently than today, in your mind, the notion of canon, from the classical canon to thinking in canonics today?
I think it's something that is becoming, let's say, we had let's say a more pop period in which the canon was not important that much anymore. No, so it was kind of refused. It was a kind of revolt against the canon, and I think now the canon becomes again with computational instruments on the foreground. No, so this kind of idea of curating a collection and deciding what goes in, goes out, and then precisely not being an author, so not giving authority to the fact of being the one that writes the original and not the copy, but by being an author in the sense of curating a garden or curating a canon, curating a collection, and letting it grow with time. I think that is what is becoming more of relevance today. And then the canon is not just that. It's not just a matter of curation, but it's also a matter of mathematics. So how things are translated through time and through different domains that are incommensurable to each other. So this is precisely also what I think many examples of today we were seeing. Yeah.
I'm curious about, so the first example, especially related to the Library of Alexandria, and the notion of the copy, right? That one of the curses, but also kind of benefits of the digital world is that copies are effectively free, right? You can make so many. And the sort of value system that it sets up in terms of what do we consider to be great works worth preserving, in the sense that if we just go by numerical numbers, then what ends up being preserved are maybe cat videos, Pokemon, right? Like as Adil mentioned, and pornography, right?
Yeah.
And so, like, how do we determine the sort of relative value system in a sort of world like this?
Yeah, I think that's a great question, because I think it has precisely to do with what I'm trying to articulate with this dealing of a kind of impersonal intelligence. No, so there is an impersonal intelligence at work, and if you want, in the informational paradigm, is what perhaps could be called objective chance, which is precisely, okay, if you have all this kind of multiplication of copies, etc., so at some point what get lost, and then it can be cat videos, but then who is this we that decides the cat videos is an impersonal agency, so it's not us that we say, okay, the cat videos must be saved. So it's something that is there in this cloud. But then the question is like, how not just to affirm the absoluteness or the let's say the superiority of this impersonal agency, but how to make stipulate a contract or talk to it so that we can then say, okay, I want maybe yes, some cats videos, but I want also to save other things because they're dear to me, no? And this this I think is what is possible today, in my understanding, with artificial intelligence, or where we're going. And this is what the promise of all these models that are more historical, if you want, the garden, the book, and the image, etc., they can inform us on how to think of this precisely, for this kind of contract. Yeah. I don't know if I was clear.
I have like a couple of thoughts. They're not incredibly well ordered, but thank you for your talk. There are so many nice thought models to take away and think about. I'm thinking about the idea of the epos and the epic also as this kind of active moment. And I'm just wondering how maybe this feeds into this project as well, because on one hand, I mean, our setting right now that we all coming here and we tell each other stories and we go again somewhere and keep telling these stories, I think is an epic setting of like telling each other these kind of stories. And I think like our current kind of academic setting has set up these kind of pockets for these kind of like storytelling moments. And I think that there is something very beautiful about it, is that like it does not become this like, or even if one does historiography about something, in the moment where you're presenting there and you're lending something a voice, this kind of like starts to live on, you know, it's not dead in that sense. And I think this is very beautiful, but I'm wondering like also in the Fritz Haller project, have you, or are you thinking about ways of creating these kind of like epic moments of storytelling, not on a meta level in the book, of writing about the epos, but actually of storytelling or of creating events or possibilities for these things to stay alive?
What do you mean not writing them in the meta level?
Because like on one hand we discuss now epos, and there is a moment, or there's a certain epicality of the moment that we are in now because you're telling us a story. But I'm wondering, like in the setting of Fritz Haller and retelling the stories that come with these nodes, the objects, the things, is there like also beyond speaking about the epos from a theoretical point of view, a way of enacting the epos?
Of netting?
Enacting.
Enacting.
The epos.
So I have to think about this, but the book, like let's say the Haller book is one book in which I will not speak on so there will not be, unless perhaps from an introduction, there will not be meta level. So in that sense, my idea was precisely to enact it and to do so with these two, if you want, escamotage, or with these two, how can you call it, tricks of the ekphrasis and of the rhapsody, you know. So and one way perhaps where this becomes more paradigmatic, so in the on one hand, so the first book is this kind of let's say a contract with the artificial intelligence as a foreign intelligence, and the second one is a contract, if you want, with human intelligence. So it's these personas, these people that talk about their interests through objects of Haller's work. But the way I thought this should be enacted is precisely by having them as personas. So in one case, there's even someone else collecting thoughts about from the people that should speak and articulating this. So to have a kind of, again, an activity of the screen, if you want, or the mask, no? So the mask is, this persona is not just transparent, it's not just someone telling their story, but they have to show up and declare their own autonomy in that sense. I don't know if this comes close to what you were asking. Okay.
Ricardo, thanks a lot for the talk. I'm curious regarding, so just something I came across recently was this Primavera painting by Botticelli, and how it's supposedly it was meant to be a pair with the birth of Venus as well. And then this Primavera painting, I found out it's a kind of a really rigorous documentation of like 350 species of flowers that pop up in spring. And then this garden kind of unfolds the mythology that is constructed and that is given birth to with Venus. So I'm just curious about this pair of mythology, which is concerned with the birth of things, versus folklore, which is everything except that, and which is the kind of the whispers and the screaming outside in the garden. I'm wondering, where does this fit into the scheme that you have built, or does it not fit at all even?
So you would say that mythology is with the birth of things, and then you have folklore is with the ghosts or something.
Yeah. So with mythological kind of stories, it's always like how the world comes into being. And the other is the world is there, and what happens within the world.
Yeah, I
I
don't know.
I don't even know if this is correct. That's just my kind of
Well,
interpretation.
I think correct would be not the correct category to address it. I think it would it's it's adequate. I think this is but I didn't think through it. But of course there is like if you want I can give you so there is almost a cheap way to address it, that death and rebirth, the two things touch. Yeah, I didn't think through with the mythology and folklore and this kind of different movement almost, but
yeah, just because this word lore nowadays is everywhere, right?
Yeah, no,
always,
it's true.
In computer games, this, that, it's always like, how does this world kind of
which has
relate
also
to what
has
is
to do with the
happening in
latent preservation of things. So it's like, no, I agree. Yeah, I'm not sure. I have to think about it.
I couldn't help thinking. Well, brought to mind the way you took us through texts and ways of thinking about them. If there's a chapter in your book about the meme, right? Because the idea that it's something that is a unit of cultural information that is replicated. I mean, in Dawkins' case, it becomes genetic. In previous cases, it was just the idea that something is repeated and repeated. It fits in with your idea of the copy, and it kind of follows through this whole presentation. And it is something, of course, that we confront today all the time, and it almost it's both prolific and generative.
Yeah, no, totally. The meme. So there's not a chapter on the meme. Perhaps in the new edition there will be. But I remember quite well that before finishing my PhD, at some point I was giving a course, I don't remember, and I had a lecture in which the meme was playing a major role precisely for the reasons that you were pointing out. And yeah, funnily enough, so sometimes when I talk about the image in my lectures, I still use this kind of classic reference of Benjamin's The Work of Art in the Age of Mechanical Reproduction, in which there's a part in which Benjamin indicates how captions can alter the meaning of a picture, and the meme precisely exploits this, no? So also as well, and it goes as well with what you were saying with this kind of abundant repetition, and perhaps also connects with the idea of lore in a certain sense. So it's a pictorial or figurative lore. So yeah, it totally makes sense. Yeah.
So I've been, I want to test something. So I'm thinking about the idea of the copy as a model, but then if you just go to the meaning of the word copy, you always can challenge what is creation. So if you portray the copy as a model, which I think you're doing with the line of, I don't know if you're doing this, but this is how I read it. How will you? Wouldn't you like to call it something else than copy then? So it doesn't have so much loaded meaning on that.
Yeah, I mean, in my
it really gives space for creation because it becomes the model that is very projected and is personalized and so on.
Yeah, no, it's great. But I think so. That's why in my PhD I didn't speak of copies, but of images, which is not a picture, because like a picture is, say, a painting of something. An image is a copy of something because it comes from mimesis, so a kind of imitation. But at the same time, whenever you think of image, it integrates the idea of copy without precisely making it so such a burden in the sense of copy, not original, as you were saying. Concerning creation, I think I always prefer to speak of invention, precisely because invention has this ambiguity between, let's say, as a kind of creative act, so I invent something, but invention has also, if you want, a more etymological understanding in which you find something. So you create something by finding something which is already there. There's this kind of oscillation which I find interesting. Creation always entails this kind of generation out of nothingness, no? Which is, I think it's always a bit tricky to address, because then it's very, yeah, it has this kind of divine act. So again, it becomes shifts again the weight on the fact that there is an author and that there is an original that creates something out of nothing. So I think creation is a tricky term. So I would prefer to talk about inventiveness or invention. Yeah, I think that's it. Yeah. If there's no other question, I think we can let Adil go.
Thank you, Ricardo.
Thank you, Adil.
So if you look at the sketch tool, we were scheduled to do the poster competition. I have asked the winners to join us online, and they are supposed to be here in 2 minutes. So if we can wait for 2 minutes, otherwise we do it tomorrow. We have one winner in the room, so I'm waiting for the other two to show up. So, I mean, we can hang out until then. We can wait. 2 minutes, so then you can, where is Ricardo? Ricardo, you can come, and we keep asking you questions. All right, it's 6, so we do it tomorrow. Thank you so much. So for everyone, we are going to go back to the house. We have dinner waiting there at 8, so it will give us enough time to hang around if you want to check on what is playing on the TVs, get some cookies if you still are hungry, and then we go back to the house. We take you with us in the cars, similar to how you came here. So, do you want to say something?
Bye-bye.
Bye, Adil. But yeah, also just for all of you online, just remember we'll join us again tomorrow morning at the same time, 9:45 a.m.